how to write the contract itself that we are going to be using, watch the video. Going to set up the dApp from scratch, connect it to MetaMask and the blockchain to interact with it to create a... Hey, how's it going guys? My name's Daniel, aka Hashlips, and welcome back where I'm going to show you how to code a dApp from scratch. In the previous video, we've created a dApp using Remix and now it's on the test network. Now we're going to set up the dApp from scratch, connect it to MetaMask and the blockchain to interact with it to create a page like Rarity Tools for fun. So let's get started. If you want to learn how to write the contract itself that we are going to be using, watch the video before this one. That's what we exactly did. We're going to build the dApp part only and hook it up to our contract that's living on the test network on the blockchain. Now, a bit of cleanup, and what you need to do, the prerequisite, is firstly go ahead and download node.js. You can download this for your operating system, and this is simply the framework that we'll need to run some of the commands. Next, you'll need a great IDE. I recommend Visual Studio Code. I always use it and it's a great tool. For those of you who are new to coding, an IDE is simply a text editor that helps facilitate you writing code, and it also allows us to run built-in terminal, and that's why we want to use it. If you are struggling in any way, go to hashlips.online and go in channels. There you'll get tons of help from people who are devs who has already done the process, and they're more than willing to help you out. Lastly, go and leave a like and a comment in this video before we start, because I can promise you'll learn a lot. We can jump right in, so go ahead and open Visual Studio Code once you've downloaded. Then go and click at the terminal here right at the top and say New Terminal. I want you to run node-v to check the version. If a version pops up, it means that you also have Node installed correctly. That's the only prerequisites you will need. Now, what we're going to do is you're going to click on Open to open a new folder. Go to any place. I'm going to go to my desktop and create a new folder. I'm going to call it NFT Hunt, like so. NFT Hunt or NFT Rarity Tool, like so. Then open that up. I'm going to say I trust this, and now we can cite that folder. We can also see that that folder exists on our desktop, and here it is. It's empty at the moment. But we are going to populate it with a very special command, and this command will create a React application for us. And yes, I did mention React. Don't freak out. Even if you don't really know React or programming, you can still kind of follow along. It would be beneficial if you already know tools like React and programming, HTML, CSS in general, and just want to up your skills. So if you really don't feel comfortable at this stage, go ahead and YouTube create a React application or a bit of HTML, CSS. I will create those videos in the future, but in this video, I purely want to focus on the fact that we are going to hook up a dApp to the blockchain, and that is what we want to achieve. We are going to focus on a bit of CSS, and you'll get to learn a new tips and tricks of the trade. But apart from that, it is going to be a lot of tech heavy stuff. So if you are a beginner, this might not be the right video. But that being said, you guys know that I explain stuff very thoroughly. So if you want to stick through and try the challenge, then go ahead. I will try my best to explain everything step by step. This is the React framework that we are going to be using. It's written by Facebook, and it's a great tool to use when writing HTML pages. It has a great way of state management, which we'll use in this tutorial. I'll talk a little bit about React as we go along so that you can get used to the nuances that it has and the best practices when it comes to React and how to use it. I'm not going to take it too slow, but you'll get the gist of it as we go along. So to get started, and the best way to get started is actually to use a tool that's written an NPM script that will initiate a React application for you just by running this command. So simply write npx. Now npx is used so that you don't have to physically download a lot of libraries and it will go and fetch it from the cloud. So you need internet access. npx create -react -app space and then give it a name. Seeing that we are going to be listing drops, I'm just going to call it nft underscore drop underscore app, like so. And now hit enter. What this will do is pull down a base project for us to use. Once we've pulled it down, we can now install the dependencies and then go ahead and start our application. You will see that it creates a new folder in there. Now we have to navigate inside this folder, even though we have created a folder outside, which is called NFT Rarity Tool. Inside the NFT Drop app has just been created. It's going to take a while, so let it run, and then once it's done, we're going to reopen Visual Studio Code inside of that folder. Once it's done, you'll see the terminal looking like this, giving us a few suggestions what we can do to start our project off. Now, I'm just going to teach you the commands. They are saying you need to use yarn, but you can use npm as well. So what we're going to do now is just simply say file, open, and just open that folder that you just created. The reason why we do this is so that the terminal that is built in points to this folder instead of you navigating in the terminal. So now go ahead again and say terminal, new terminal, up there. Now you can see that Node Modules was already installed for us, so we don't need to do that again. All we have to do now is simply run npm run start. Once we do this, this program will actually start up the base application for us, and that is great. This means that it's going to spin up a local host and then host our application. This is kind of similar to hosting your website on a hosting service, but you can see that it's locally hosted over here at port 3000. And this is the basic dApp. It has a spinning React logo, some text, and a link. And we can go and explore the project, and that's what we are going to do now so that you can get the base understanding of React. Let's take a brief look at the folder structure that we got when running Create React App. Now you can see that at the very bottom we have 4 files. This is a yarn.lock file, which is generated whenever dependencies are installed if you are using yarn. So don't pay too much attention to this file. It's just going to be generated if you were using yarn. Similarly, there will be a package.lock file if you used npm. So we didn't install any dependencies, we simply ran the command, so the command ran yarn. Then we get the readme file, which has to do with source control and GitHub, which we're not going to get into, but it's really not important to fiddle around with any of these files. Then we get the package.json file. Now this file is super important for any node-based project. It basically governs what dependencies it needs to install by providing it a dependency list, as well as some other configurations to do with the app execution. You can also put some scripts in here to run in the terminal to execute certain things. But that being said, after it installs dependencies, where do those dependencies get saved? For instance, where does the React DOM, React scripts get saved? Well, that is in the node_modules folder. This folder is something that you also don't need to worry about. It's simply a place where Node manages and saves its modules. The git ignore file is also something that we can technically ignore because we are not going to be making use of source control. If you are an experienced programmer, then obviously you know what these files are for and you can go ahead and use them. All that we need to worry about in this course is basically the src folder as well as the public. We might look at the public. Let me briefly go over what these 2 files are. So the public folder is there to tell us what files it needs to incorporate in the final build of your static HTML web app. Now, you usually specify things like the logos, the initial HTML document, that you need to specify and give some descriptions, some name tags. You can change the title tag in here. But essentially, these things come standard and you don't need to really change a lot in here. The only things that you do need to change are the logos, because you don't want the React logo. You can maybe change it into your own logos. And then in the manifest file, this has to do with PWA apps. So this might host the content that might be saved when you are offline. But that is very technical, so we won't get into that in this course, and we will be mostly focusing on the SRC folder structure. Now, this is going to be our safe haven where we're going to explore and write some code. The SRC file, or the folder structure basically, contains all the code needed to basically execute the app, and I'm going to go through these files quickly one by one so you also understand what the base project gives us. Immediately you can see some kind of structure happening over here. We can see that we have got an app.css, app.js, and app.test.js. This means that these three files are related. This one provides the style, the .css. The .js provides the logic, the functionality of our component, because React is component driven. And then the app.test is there to facilitate us with some tests to make sure that the logic works of that component. Here we get a similar fashion. We get the index.css and the index.js. Now the index.js is going to be the entry point of our application, and we'll go through that in detail just now. Next, we get a logo.svg, and this logo is basically, if we go to Chrome, is this spinning one over here. But just jumping back quickly, we are going to remove some of the stuff that we don't need. And the reason why I want to do that is to show you that you can manipulate React. The report web vitals and the setup test, this is basically to do with the PWA and the test that we just discussed. We're not going to cover testing in this course, so I can also go ahead and remove some of the test files that is presented over here. For now, I'm going to go ahead and delete this file, the setup. I'm also going to delete the report web vitals. I'm going to delete the logo.svg, and then I'm also going to go ahead and let me just see, delete this test. Now that I've done that, I can see that I've got 2 app files and 2 index files left. Now we also have an error, and it basically says that it cannot find or open a directory, the logo.svg, and that is true because we just removed it. A nice way of debugging is that we can see where it's being used by going to the app.js file and see that here at the top, line number 1, it says import the logo svg. We're going to remove that line and save the file. Then we can see that the report web vitals can also not be found. So let's go to the index.js, and we're also going to have to remove this. Once we save it, we can see that our app is now running again, but most probably won't have the logo. So if we refresh, we can see that now logo is not defined, so we can jump back to the app, go into app.js where that was being used, and then we need to remove it. It was sitting underneath this image tag. So there you can see it was using source logo. So I'm going to remove that, save, then navigate back, and you can see the logo is gone. This looks pretty bare-boned already. But let's go ahead and strip out some more elements so that we can start with a clean slate. So go back to the code, and let's start off by looking at the index.js. Now, like I said, this is the entry point of your app. And you can see that here at the top, there's a few imports, files, and dependencies that this program needs for whatever is going to be used down here. We can see that we are making use of React, React DOM, as well as the index.css, this file. Now, in the index.css, we can see that the body, and this gets some fonts. Now we're going to go ahead and delete this file. So delete that, like so, and also in the index.js, remove this import, otherwise it will break. Then you can see something interesting is happening. We are importing app, and app is sitting over here. If we look at app, right at the bottom, we are exporting this component. A component structure simply looks like a function if you're using functional based components. After importing the app, they basically use it like an HTML tag. And this is the root, then they append it to the root element of this web page, and basically the app is our entry point via the index.js. When I was learning React for the very first time, I got confused by thinking that I need to nest these components. And that is simply not the case. So to help you along with, I'm going to prove to you that if you go to the app.js, which has this component, and you can see some resemblance, you can see the text and Learn React link over there, which you can see is displayed on the page. If we go ahead and take the component structure, this div, and we copy it, we can even cut it out if we want to, but let's just copy it, go to index.js, paste it where the app should be, and then going removing the app, you can see that our app will still work. That is because technically our index.js only serves as a pass-through and simply renders everything inside the app component, which is all of this stuff anyway. It's a way to structure the component much better, because imagine we had to write all the code in the index.js, and this is how componentizing works in React. I'm going to dive into it a little bit deeper so you fully understand that the index.js simply serves as our pass-through, the entry to our app. We don't really need to work on this file a lot. We can simply focus on whatever is inside the app.js component. Now, this tutorial, I won't show in-depth components and how to structure and create new components and save them and then render them. But what I will do is explain how a component works. So let's take a basic look at what we do over here. All it is a function. Now, forget about this render part for now. This is the basics of a component, a functional component. It looks like this. And you can even forget about this import. All it is a function called app. We can call it anything. So we can call this any app as well, as long as we export any app there. And then in index, we need to now obviously import any app from any, well, it's still called app. So we don't say any app there. This is the file name, but we want to import our any app, and we want to render the any app. I'm going to save this, but technically nothing is going to get rendered. Now, if I go into my component structure and return, right? So if we return something, and for our use case, I took away all the styling as well. So we might as well also delete the app.js file. So let's delete that. And now we can just simply render a p tag like HTML, and let's go say hello world. When we save this and we go back to our app, you can see if we refresh, there's hello world with a blank page because there's no styling on this page. And this is what we're going to start off with. We are going to strip everything away like we've done and now start off with a clean slate. Perfect. So instead of just renaming this file, let's create one from scratch and then import it in our index.js file. We're going to right click and say new file underneath the src folder, and let's call it our drop list. So this is going to be the drop list.js. Once I have this, I can create a new function. So instead of specifying it like this, I'm going to write it in the new ES6 way. So const drop list, like so, And this drop list is going to be equal to an anonymous function, like so. There we go. And this is going to return to us, like we've done, something. And for now, I'm just going to create an empty div tag, like so. And then at the bottom, we need to export this. Now you can see that the exports work like this. If you export something by default, you can simply import it straight off the bat, giving it a name. Otherwise, you can also have named exports, which we'll get to. But for now, we can simply go and see we need to export the default. So let's type in export default and then our drop list. And there we go. We've created a very simple component. Now I'm just going to maybe in here, just for reference, also put a p tag. And if you don't know HTML, this is HTML. I'm just going to write it there. And then we need to import this. So let's go to our index and rather import the drop list. So we're going to say we want to import drop list from, where is it located? Well, it's simply just located here. When you specify an import, you do not append the .js. It's not necessary. Now that we have this, check what will happen if I just simply put this drop list underneath my other component, any app. If I save this, remember we had hello world. Now we will have hello world and HTML because there's two components. This is an example of how you would split components into different ones, creating a header, a body, and we'll get to that as well. But this is the start of it. We're not going to need any app because I want my drop list to be the main list because it's going to be a simple app. Then for my app.js, I'm going to remove it. Now we get a very basic application. We got our entry point, which is the index.js, and then our drop list component. To follow a bit better convention, in the src folder, I'm going to create a new folder and call it components. In the components folder, I'm going to drag my drop list.js and move it there. Then I need to update wherever I've imported it. This wants to automatically do this, which I'm just going to say no for now and just show you that in order to import this, we need to say components and then drop list. That means that we are going to find it in the components folder. Because if your component or you've got a lot of components, you'll need some place to save it. It is just a simple structure. Structures we can get into, it's a whole different subject. But for now, just do this and at least you'll know that it's a bit more structured. Everything is ready for us to now connect to MetaMask and start actually our dApp. Because currently this is a normal web page. It has nothing to do with the blockchain at all. Now we're going to import some libraries that we are going to need in order for us to make a connection to the blockchain through MetaMask, and we're going to import the Web3 library so we can interact with our contract. This is going to come up next, so just a reminder, leave a thumbs up on this video if you are enjoying the content. Also, if you want to, subscribe. Now we have to connect to the blockchain and retrieve the data from our contract living on the Ethereum network. How can we achieve this? Well, it's important to understand how the connection to the blockchain works and what parts are needed to achieve our goal. The two things we're going to need is web3.js, which is a JavaScript Ethereum library API, right? It is a library that provides us a set of tools in order for us to interact smoothly with the Ethereum blockchain, contracts, accounts, and all those kind of things. Now, the web3.js allows for us to connect to the blockchain, but it does not give us the provider, so to speak. We still get to manipulate that part and choose which provider we want to use. What better provider to use than MetaMask? It is a browser extension and they are running the full Ethereum nodes and they give us access to connect to the blockchain. So we can pass MetaMask as the provider to the web3.js library, meaning that the Web3 library will basically create that connection using MetaMask. Then we can create an instance of our contract and we can work with it. That is pretty cool. Now there is other services like Infura, there's a bunch of them. And you can also do a full node on your own and then, connect via that. But the simplest for me to explain is the two parts you'll need is the web3.js library as well as a provider that you're going to be using to connect to the blockchain. Let's go and set this all up, but let's first download web3.js, the dependency we'll need in our React app. So now what we want to do is actually create that connection to the blockchain. So for that, we will need the Web3 library. Let's go ahead and install this. For a brief second, I'm going to hit Control and then C. This will exit the program. Now I can run the npm script again. So I'm going to run npm install like so, and then I'm going to say Web3. We need to install Web3 in order for us to use the tools to connect to the blockchain via MetaMask, which is going to be our provider. While this is installing, let's go ahead and create a space for us to save the information we will need to connect to our contract. I'm going to create a new folder and call this contract. Then in here, I'm going to create a file and call it contract.json, like so. In the JSON, I'm going to start my JSON and list the address, like so. This is going to be equal to something. And we also need the ABI. So where do we get the ABI? Well, we can go to our browser, go to Etherscan, and click on the contract address. This is the creator's address. So let's go back on the contract address over here. Click on contract and then scroll down to the bottom and there's your ABI. So go ahead and copy the whole thing. Go back to Visual Studio Code and then simply paste it. Now when I save it, it organizes nicely because I have Prettier installed on Visual Studio Code. Now this is the ABI basically telling us what the blueprint is of our contract. We still need the address. So how we get that is again by going back and then copying this address here at the top. This is the location of where this contract lives. So go, perfect. Now that we have this, we can import it in our drop list file. To import the contract, simply go here to the top and let's create some space. I'm going to write the keyword import and then we can specify contract like that. And then we need to say, where are we going to import this from? Now we're going to specify that we have to go directory back and then go into the contract folder, followed by typing in contract.json. Perfect. And that's exactly where we want to import this from. We can run a test by just console.logging this out. So if we type in console.log and then logging out the contract itself like so, we will see if we've done this correctly. Let's go and run the program, seeing that the install is also complete. So we can go ahead and run npm run start, and this will start up our development server again, running the application. This time, if I say inspect by right-clicking, I can see in the console there's an object that was printed, and there we can see the ABI as well as our address. Now we will need the Web3 library. So I'm also going to import that. So I'm going to import Web3 from, and then simply specify Web3 like this. This will give us the actual library, which we're going to create an instance from. We are also going to need to use state. Now in React, you can use the use state hook. When you use functional based components in React, you can use hooks. Hooks are simply functions that return an altered state, so to speak. The use state hook is very unique, and how you would use it is something like this. Let me give you a small counter example. When you want to create a counter, let's specify it like this. Let's specify a variable and call it counter. This time, I'm going to wrap it in brackets like so. I'm also going to put a set counter variable like this, and then I'm going to equal this to the use state that we've imported there at the top and set it to 0. Let me show you how simple use state really is. The first variable is the actual value, and the second one is the function that will alter this value. So to explain it a bit better, let's create a new p tag right here below our HTML. What we can do is put curly braces indicating to React that this is going to be a dynamic value. And we can put in anything in here. But I want to put my counter. So if I save this and go to that web app, you can see there's a 0. Exactly what we've specified over there as the initial state. If we want to use the set counter to set the state, every time state updates in React, the screen basically re-renders that component. This means that we can set the counter dynamically and in real time. For example, let's change the HTML to click me. Now this is going to say click me. Let's add a click handler. So I'm going to say on click, like so, and specify a function to run. The function that I wanted to run is actually the set counter. And we are going to pass in the new value that we want this to be. And the value is going to be our counter, and let's say +1. This will in turn add to the counter 1 and then set the state. Let's save this, go to our app, and then click on this counter. So click me increments our state. And that's how we're going to be working with state, saving the contract as well as the Web3 instance, and then connecting to the blockchain, and then saving it all in state so that we can work with it. Now that you know how basic state works in React, I guess we can go ahead and connect to MetaMask. I'm going to alter the state that we have here currently, but I'm going to do it a bit differently. I'm going to create a constant value, and we're going to call this the initial, let's call it info. And this is going to be equal to an object. Now the initial info is going to be the object of values that I want to initialize over here. So let's go ahead and change the counter into info and the set counter into set info. Then we're going to say this should start off with our initial state. It's good to have an object here because the thing is, if we want to set this to the initial state again, it's easy for us to do so. We're going to need a few variables in here. And the first one is going to be connected, and that's going to be false. Then we're going to need a new one, and let's call it the status. This can be an empty string, or let's make it even null. Then let's create one for the account, which is also going to be null. This account is going to be the account that's currently connected to our web app. I have to have a variable for the contract, which is going to be null as well, the address, and this is optional because we technically have the address from our contract over there, so probably not too necessary. So let's get rid of that one, and that's about it. So we're just going to need this few variables, or these few variables, to control what we're going to do connecting to the blockchain. So now is the time to actually set up the functionality to connect to our blockchain. Now let's get rid of these variables or this HTML down at the bottom, because we're not going to use that immediately. We first want to create a function, and this function is going to be called the init function. We're going to initialize this, and on initialization, we're going to ask the person or the user to allow us to use his MetaMask to make the connection to the blockchain. The next part's going to be a bit technical, but please bear.
Oh my gosh, Kitty Mama, get down. You're bad, kitty.
The content that might be saved when you are offline. But that is very technical, so we won't get into that in this course, and we will be mostly focusing on the SRC folder structure. Now, this is going to be our safe haven where we're going to explore and write some code. The SRC file, or the folder structure basically, contains all the code needed to basically execute the app, and I'm going to go through these files quickly one by one so you also understand what the base project gives us. Immediately you can see some kind of structure happening over here. We can see that we have got an app.css, app.js, and app.test.js. This means that these three files are related. This one provides the style, the .css. The .js provides the logic, the functionality of our component, because React is component driven. And then the app.test is there to facilitate us with some tests to make sure that the logic works of that component. Here we get a similar fashion. We get the index.css and the index.js. Now the index.js is going to be the entry point of our application, and we'll go through that in detail just now. Next, we get a logo.svg, and this logo is basically, if we go to Chrome, is this spinning one over here. But just jumping back quickly, we are going to remove some of the stuff that we don't need. And the reason why I want to do that is to show you that you can manipulate React to how you want it to work. Lastly, the report web vitals and the setup test. This is basically to do with the PWA and the test that we just discussed. We're not going to cover testing in this course, so I can also go ahead and remove some of the test files that is presented over here. For now, I'm going to go ahead and delete this file, the setup. I'm also going to delete the report web vitals. I'm going to delete the logo.svg, and then I'm also going to go ahead and let me just see, delete this test. Now that I've done that, I can see that I've got 2 app files and 2 index files left. Now we also have an error, and it basically says that it cannot find or open a directory, the logo.svg, and that is true because we just removed it. A nice way of debugging is that we can see where it's being used by going to the app.js file and see that here at the top, line number 1, it says import the logo svg. We're going to remove that line and save the file. Then we can see that the report web vitals can also not be found. So let's go to the index.js and remove that too. We're also going to have to remove this. Once we save it, we can see that our app is now running again, but most probably won't have the logo. So if we refresh, we can see that now logo is not defined, so we can jump back to the app, go into app.js where that was being used, and then we need to remove it. It was sitting underneath this image tag. So there you can see it was using source logo. So I'm going to remove that, save, then navigate back, and you can see the logo is gone. This looks pretty bare-boned already. But let's go ahead and strip out some more elements so that we can start with a clean slate. So go back to the code, and let's start off by looking at the index.js. Now, like I said, this is the entry point of your app. And you can see that here at the top, there's a few imports, files, and dependencies that this program needs for whatever is going to be used down here. We can see that we are making use of React, React DOM, as well as the index.css, this file. Now, in the index.css, we can see that the body and this get some fonts. Now we're going to go ahead and delete this file. So delete that, like so, and also in the index.js, remove this import, otherwise it will break. Then you can see something interesting is happening. We are importing app, and app is sitting over here. If we look at app.js, we can see right at the bottom we are exporting this component. A component structure simply looks like a function if you're using functional-based components. Now, after importing the app, they basically use it like an HTML tag. And this is the root, then they append it to the root element of this web page, and basically the app is our entry point via the index.js. When I was learning React for the very first time, I got confused by thinking that I need to nest these components, and that is simply not the case. So to help you along with your beginning journey, I'm going to prove to you that if you go to the app.js, which has this component, and you can see some resemblance, you can see the text and Learn React link over there, which you can see is displayed on the page. If we go ahead and take the component structure, this div, and we copy it, we can even cut it out if we want to, but let's just copy it, go to index.js, paste it where the app should be, and then removing the app, you can see that our app will still work. That is because technically our index.js only serves as a pass-through and simply renders everything inside the app component, which is all of this stuff anyway. It's a way to structure the component much better, because imagine we had to write all the code in the index.js, and this is how componentizing works in React. I'm going to dive into it a little bit deeper so you fully understand it. Now that you've seen that the index.js simply serves as our pass-through, the entry to our app, we don't really need to work on this file a lot. We can simply focus on whatever is inside the app.js component. Now, this tutorial, I won't show in-depth components and how to structure and create new components and save them and then render them. But what I will do is explain how a component works. So let's take a basic look at what we do over here. All it is a function. Now, forget about this render part for now. This is the basics of a component, a functional component. It looks like this. And you can even forget about this import. All it is a function called app. We can call it anything. So we can call this any app as well, as long as we export any app there. And then in index, we need to now obviously import any app from any, well, it's still called app, so we don't say any app there. This is the file name, but we want to import our any app and we want to render the any app. I'm going to save this, but technically nothing is going to get rendered. Now, if I go into my component structure and return, right? So if we return something, and for our use case, I took away all the styling as well. So we might as well also delete the app.js file. So let's delete that. And now we can just simply render a p tag like HTML. And let's go say hello. Hello world. When we save this and we go back to our app, you can see if we refresh, there's hello world with a blank page because there's no styling on this page. And this is what we're going to start off with. We are going to strip everything away like we've done and now start off with a clean slate. Perfect. So instead of just renaming this file, let's create one from scratch and then import it in our index.js file. We're going to right click and say new file underneath the src folder, and let's call it our drop list. So this is going to be the drop list.js. Once I have this, I can create a new function. So instead of specifying it like this, I'm going to write it in the new ES 6 way. So const drop list, like so. And this drop list is going to be equal to an anonymous function, like so. There we go. And this is going to return to us, like we've done, something. And for now, I'm just going to create an empty div tag, like so. And then at the bottom, we need to export this. Now you can see that the exports work like this. If you export something by default, you can simply import it straight off the bat, giving it a name. Otherwise, you can also have named exports, which we'll get to. But for now, we can simply go and see we need to export the default. So let's type in export default and then our drop list. And there we go. We've created a very simple component. Now I'm just going to maybe in here, just for reference, also put a p tag. And if you don't know HTML, this is HTML. I'm just going to write it there. And then we need to import this. So let's go to our index and rather import the drop list. So we're going to say we want to import drop list from, where is it located? Well, it's simply just located here. When you specify an import, you do not append the .js. It's not necessary. Now that we have this, check what will happen if I just simply put this drop list underneath my other component, any app. If I save this, remember we had hello world. Now we will have hello world and HTML because there's two components. This is an example of how you would split components into different ones, creating a header, a body, and we'll get to that as well. But this is the start of it. We're not going to need any app because I want my drop list to be the main list because it's going to be a simple app. Then for my app.js, I'm going to remove it. Now we get a very basic application. We got our entry point, which is the index.js, and then our drop list component. To follow a bit better convention, in the src folder, I'm going to create a new folder and call it components. In the components folder, I'm going to drag my drop list.js and move it there. Then I need to update wherever I've imported it. This wants to automatically do this, which I'm just going to say no for now and just show you that in order to import this, we need to say components and then drop list. That means that we are going to find it in the components folder. Because if your component or your app grows with a lot of components, you'll need some place to save it. It is just a simple structure. Structures we can get into, it's a whole different subject. But for now, just do this and at least you'll know that it's a bit more structured. Everything is ready for us to now connect to MetaMask and start actually our dApp. Because currently this is a normal web page. It has nothing to do with the blockchain at all. Now we're going to import some libraries that we are going to need in order for us to make a connection to the blockchain through MetaMask, and we're going to import the Web3 library so we can interact with our contract. This is going to come up next, so just a reminder, leave a thumbs up on this video if you are enjoying the content. Also, if you want to, subscribe. Now we have to connect to the blockchain and retrieve the data from our contract living on the Ethereum network. How can we achieve this? Well, it's important to understand how the connection to the blockchain works and what parts are needed to achieve our goal. The two things we're going to need is web3.js, which is a JavaScript Ethereum library API, right? It is a library that provides us a set of tools in order for us to interact smoothly with the Ethereum blockchain, contracts, accounts, and all those kind of things. Now, the web3.js allows for us to connect to the blockchain, but it does not give us the provider, so to speak. We still get to manipulate that part and choose which provider we want to use. What better provider to use than MetaMask? It is a browser extension and they are running the full Ethereum nodes and they give us access to connect to the blockchain. So we can pass MetaMask as the provider to the web3.js library, meaning that the Web3 library will basically create that connection using MetaMask. Then we can create an instance of our contract and we can work with it. That is pretty cool. Now there is other services like Infura, there's a bunch of them. And you can also do a full node on your own and then, connect via that. But the simplest for me to explain is the two parts you'll need is the web3.js library as well as a provider that you're going to be using to connect to the blockchain. Let's go and set this all up, but let's first download web3.js, the dependency we'll need in our React app. So now what we want to do is actually create that connection to the blockchain. So for that, we will need the Web3 library. Let's go ahead and install this. For a brief second, I'm going to hit Control and then C. This will exit the program. Now I can run the npm script again. So I'm going to run npm install like so, and then I'm going to say Web3. We need to install Web3 in order for us to use the tools to connect to the blockchain via MetaMask, which is going to be our provider. While this is installing, let's go ahead and create a space for us to save the information we will need to connect to our contract. I'm going to create a new folder and call this contract. Then in here, I'm going to create a file and call it contract.json, like so. In the JSON, I'm going to start my JSON and list the address, like so. This is going to be equal to something. And we also need the ABI. So where do we get the ABI? Well, we can go to our browser, go to Etherscan, and click on the contract address. This is the creator's address. So let's go back on the contract address over here. Click on contract and then scroll down to the bottom and there's your ABI. So go ahead and copy the whole thing. Go back to Visual Studio Code and then simply paste it. Now when I save it, it organizes nicely because I have Prettier installed on Visual Studio Code. Now this is the ABI basically telling us what the blueprint is of our contract. We still need the address. So how we get that is again by going back and then copying this address here at the top. This is the location of where this contract lives. So go and put that in there. Perfect. Now that we have this, we can import it in our drop list file. To import the contract, simply go here to the top and let's create some space. I'm going to write the keyword import and then we can specify contract like that. And then we need to say, where are we going to import this from? Now we're going to specify that we have to go directory back and then go into the contract folder, followed by typing in contract.json. Perfect. And that's exactly where we want to import this from. We can run a test by just console.logging this out. So if we type in console.log and then logging out the contract itself like so, we will see if we've done this correctly. Let's go and run the program, seeing that the install is also complete. So we can go ahead and run npm run start, and this will start up our development server again, running the application. This time, if I say inspect by right-clicking, I can see in the console there's an object that was printed, and there we can see the ABI as well as our address. Now we will need the Web3 library. So I'm also going to import that. So I'm going to import Web3 from, and then simply specify Web3 like this. This will give us the actual library which we're going to create an instance from. We are also going to need to use state. Now in React, you can use the use state hook. When you use functional-based components in React, you can use hooks. Hooks are simply functions that return an altered state, so to speak. The useState hook is very unique, and how you would use it is something like this. Let me give you a small counter example. When you want to create a counter, let's specify it like this. Let's specify a variable and call it counter. This time, I'm going to wrap it in brackets like so. I'm also going to put a set counter variable like this, and then I'm going to equal this to the useState that we've imported there at the top and set it to 0. Let me show you how simple useState really is. The first variable is the actual value, and the second one is the function that will alter this value. So to explain it a bit better, let's create a new p tag right here below our HTML. What we can do is put curly braces indicating to React that this is going to be a dynamic value, and we can put in anything in here. But I want to put my counter. So if I save this and go to that web app, you can see there's a 0. Exactly what we've specified over there as the initial state. If we want to use the set counter to set the state, every time state updates in React, the screen basically re-renders that component. This means that we can set the counter dynamically and in real time. For example, let's change the HTML to click me. Now this is going to say click me. Let's add a click handler. So I'm going to say on click, like so, and specify a function to run. The function that I wanted to run is actually the set counter. And we are going to pass in the new value that we want this to be. And the value is going to be our counter, and let's say +1. This will in turn add to the counter 1 and then set the state. Let's save this, go to our app, and then click on this counter. So click me increments our state. And that's how we're going to be working with state, saving the contract as well as the Web3 instance, and then connecting to the blockchain, and then saving it all in state so that we can work with it. Now that you know how basic state works in React, I guess we can go ahead and connect to MetaMask. I'm going to alter the state that we have here currently, but I'm going to do it a bit differently. I'm going to create a constant value, and we're going to call this the initial, let's call it info. And this is going to be equal to an object. Now the initial info is going to be the object of values that I want to initialize over here. So let's go ahead and change the counter into info and the set counter into set info. Then we're going to say this should start off with our initial state. It's good to have an object here because the thing is, if we want to set this to the initial state again, it's easy for us to do so. We're going to need a few variables in here. And the first one is going to be connected, and that's going to be false. Then we're going to need a new one, and let's call it the status. This can be an empty string, or let's make it even null. Then let's create one for the account, which is also going to be null. This account is going to be the account that's currently connected to our web app. I have to have a variable for the contract, which is going to be null as well, the address, and this is optional because we technically have the address from our contract over there, so probably not too necessary. So let's get rid of that one, and that's about it. So we're just going to need this few variables, or these few variables, to control what we're going to do connecting to the blockchain. So now is the time to actually set up the functionality to connect to our blockchain. Now let's get rid of these variables or this HTML down at the bottom, because we're not going to use that immediately. We first want to create a function, and this function is going to be called the init function. We're going to initialize this, and on initialization, we're going to ask the person or the user to allow us to use his MetaMask to make the connection to the blockchain. The next part's going to be a bit technical, but please bear with me and you will understand because I'm going to talk through everything. I'm going to start off by creating a function, and how we do that is by specifying a constant value and equaling it to an anonymous function. You write an anonymous function like this. This is the signature. This function is not going to only be anonymous but also asynchronous. This is because we need to wait for execution to finish inside of this function. Where do we call this function? Well, in React we also get a useEffect hook. This is much the same like this useState hook that we've used, but this time we're going to import useEffect. UseEffect is a lifecycle hook that kicks off on the beginning of a component render and takes in dependencies to re-render whenever you tell it to. So we simply wanted to basically render on the fly or when it starts off. So this is how you specify it. You pass it an anonymous function again, and then these empty square brackets because we don't have any dependencies. I just simply want to call my initialization function over there. Let's check if this works. We're going to console.log and say this worked, like so. Once we have this, we can basically run our program by again typing npm run start, and let's see the console. And there we go. Our app spun up, and remember there's nothing inside the app at the moment because we took it out, but in the console you can see that we have a log and it says this worked. Perfect. Now we can go back and you can see that this initialization function gets kicked off once. But what do we want to do? We don't only want to console.log that. We actually want to create a connection to the blockchain via MetaMask. In order to do that, we need to first check that this browser contains the extension MetaMask. How can we do that? Well, the window object that the browser has, if you have the MetaMask extension, it injects an Ethereum object. So we can basically check for if this window, so let's talk through this, right? If this window has the Ethereum, so Ethereum dot, well, if it has the Ethereum object, basically, you can just check it like that. Or you can just say dot is MetaMask, I believe. I think that's also something that MetaMask gives us. Else, do something, right? If we don't have MetaMask, what should we do? So let me just open these up. Let's console.log and say you need MetaMask. And if we do have MetaMask, we can just say you have MetaMask. How's that? So we're going to run this again. This time I'm going to open the browser and check what it says. It tells me that I have MetaMask. Now, this is pretty interesting, and I just want to show you how the Ethereum object looks. What you can do is go back, and instead of just console.logging that out, let's console.log the window.ethereum object as well. If we go back, you can see that we have MetaMask, and this is how the object looks like. It has a handler with a target and to see what chain you are on and all these cool things about the blockchain. Now, what will happen if we open this in a new incognito tab? We can see that it cannot even read the isMetaMask variable. So basically, to resolve this, and I really do want to use this MetaMask, so I'm going to add a question mark there. This allows us to check for this variable without breaking the application, and then we can see that it says you need MetaMask. This is only for the incognito tab, because in the incognito tab I don't have the MetaMask browser extension, and that's exactly what we need. So let's close the incognito tab and see that everything is working as it should, and let's continue on our journey. So now that we have this, we don't simply want to log this out. Later on, we might need to use this information to communicate to the user that they need to install MetaMask. That's where it becomes necessary to update our info state, and in particular, this status variable. How can we do that? Well, maybe we can get rid of the console.log and say set info. This will set our state to something. Now, instead of just saying we want to set the status, because we can say status should equal you need MetaMask, and I don't know if that's the most friendliest message for someone, but anyway, you need MetaMask is there. This will work, but it will override all the state, and we want to kind of keep all the state that is there currently and then basically update it. How do we do that with using the state? So basically what you can do is in here we're going to extract all the state that was there before, and we can use the initial state in this instance. It will make sense in a second. I'm going to spread out the initial info state, put a comma, and this syntax basically says take all of this and only update the status. So it will spread it out, it will put all those variables and then update the last one. Perfect. That's all that we need for the negative case. Because if there's no MetaMask, we can't really carry on with our app, seeing that this is a fully decentralized app. Let's work on our positive use case. So if we do have MetaMask, we don't only want to console or change the state immediately. We actually want to go and get the accounts that the user is now connected to, and then the network ID. So let's go ahead and do that. So this is where the asynchronous kind of await comes in. So we need a new variable, and I'm going to call it accounts. Then I'm going to equal the accounts to await. And what are we awaiting for? Well, in this instance, we're going to check for the window.ethereum, okay? And then we need to send a request, like so. This request will take in an object. So we're going to create it like this, and the object will take in a method, like so, and then the method would be the request. Now there's different requests that we can use when it comes to MetaMask. Now the request that we are looking for is basically to see when we initialize the app, we want to get the accounts. Now that method looks like this. It says ETH and then request accounts, like so. And that's basically it. Now you'll see that this function will wait for the accounts to get grabbed from MetaMask and then put it into this variable. We can log this out by saying console.log accounts, and you'll see that this returns an array. We are going to use the first one of the array, but let's first check it out like this. Save your file, go back to the app, and here we can see is the array, and the very first variable is actually my address. Perfect. It means we successfully grabbed my account from MetaMask. We can at this point save this account basically underneath our variable, but we still need a few other variables before we want to save it. So let's go ahead and grab the next one that we'll need. The next one would be the network ID. So it's the network ID like so, and you can call it whatever you want to, but this is again going to follow the exact same structure as this. So we can just copy and paste that. The only thing that changes is basically the method, and this method is called net version, like so. Now we'll get the network version, basically returning back the chain ID. Ethereum is chain 1, and then for instance Polygon mainnet is 137. But this is basically what we need in order for us to connect to our contract on the blockchain. So the next thing that we want to do is basically check that we are indeed on this network. Because if we're not, we want to ask the user to switch to a different network. So what we can do is include another if statement, this time checking for the network ID if it's equal to either 1, which is the Ethereum mainnet, or 4, which is the Rinkeby test network. I'm going to choose 4 because we are going to be working with the test network, and I want to make sure that the person is on the test network. So if we are here, we can continue doing our stuff, connecting. Else, we actually want to inform the user through setting our status again. So I'm just going to simply copy and paste that and say You need to be on the Ethereum test net. That's perfect. All right. So I'm going to say you need to be on the Ethereum test network if this is not true. And if it is true, we can actually now go and continue, because now we know that we actually are on the right network. We know that we have MetaMask. So now it's time to actually create the connection to basically the Ethereum using our provider, and then connect and create an instance of our contract so we can interact with it. At this point, we are going to make use of these two imports that we have at the top. So inside of this if statement, we're going to create a new variable, and this time I'm going to call it web3 with a lowercase w. I'm going to equal it to a new web3 object, and this time pass it in a provider. Remember, our gateway to the blockchain is our Ethereum kind of node through MetaMask. So this is why we pass window.ethereum, basically passing MetaMask's provider, right? Let's set the info again, and this time we're going to basically do exactly the same. We can technically set it to the previous state by doing ... basically spreading it out, putting info over there, and then just updating the necessary variables, which would mainly be our contract that we need to define now. But I'm going to put it to the initial state because this is your initialization of the application, and we probably want to just clear everything out and connect the user. There's two things that I want to set. I want to set the account, and I also want to set the contract. So the account and the contract. Now remember, we do have the account via the accounts array on index 0. So let's just go ahead and set that. And then we're going to use our web3 instance to say that we need a new web3 contract. Now how you specify that is by saying web3.eth and then contract, like so. And how you initialize it, this needs two variables. Firstly, it needs the ABI and the address. Now remember that we created this contract.json, which contains basically the ABI and the address. This is where it comes in handy. So we're already importing it there. So I'm going to copy that, go all the way down, and firstly pass in contract.abi, then contract.address. And that's it. We are done. Now we should have a connection to our MetaMask, and we also should have the contract now saved inside our info object. We are logging it out, so let's go and verify it on the console. We can see that as the application spins up, I'm going to refresh, we can see that this object that we have has everything null and false for connected. Now obviously connected is still false, so basically let's also just set that. So connected is going to be equal to true. Let's jump back, let's refresh and see. Now everything is default, and then the next update, because it could connect, we get the account, which is indeed my account. If I verify this, it ends with the 240D. This ends with 240D. We are connected, and we have an instance of the contract. Here we go. This instance will have access to the methods that we can call when we query our app. Now, as well as this, we also have no status because nothing broke, okay? So everything is good. We have our connection, and now we should be able to read data from this contract. Something worth mentioning is what happens when someone switches their account. How do we reload this page? Well, we can actually listen for an event. So let's go and create this variable or another function basically, and let's call it init on changed, like so. This init on change basically is going to look for changes in our MetaMask activity, basically things like changing accounts and so on. The Ethereum object on the window does give us that functionality to listen for changes. Firstly, let's also just verify over here that we do indeed have the window.ethereum object, otherwise it will break if we don't. Then we can say window.ethereum.on, and the .on will listen to an event. The event we want to listen to is if the accounts change, like so. Now this will kick off a function, so we can pass in the function that we want it to kick off. And what would we like this function to basically do? Well, for simplicity's sake, you can do a bunch of stuff. But for now, let's go ahead and say window.location.reload. This will reload the page. But this is not the only listener we want. We also want to see if the chain changed. So not only if the account changed, but also the chain. So we can just do this and both will reload. Now, where would we like to call this event listeners, or where would we like this to kick off? Well, we can simply kick it off right here at the bottom where we have our use effect, where we initialize. We can also kick this off like so. Once we do this, check what will happen. I go into Chrome and let's reload the page, and there it reloaded. Now, if I reload, you can see it kicks off and does all these checks. But now if I go to MetaMask and I update my chain, and let's go to maybe the Polygon chain, check what happens. It reloads and it now says you need to be on the Ethereum testnet. And this is exactly what we want. So now if I go back to the Rinkeby test network, everything is fine and we have our connection. This is great. So this is all we need, and now we are ready. The next step is to actually load up some data inside of our contract. Remember, this is the contract that we created, the Hashlabs Hunter contract. Now, we've got some read and write functionality on this contract. I want to pass in some data with the right contract methods. Technically, we are going to do this through the dApp, but for now, I need to just pass in or add a drop at least, so I can see that I can read the data from my contract. If we go back to the contract, remember we had some test data that we commented down here? Well, I'm going to use this data. I'm going to copy this, go to my app and just simply paste it. Then I'm going to remove the comments just so I have some clean data to work with. Cut this out again, and now that I have it in my clipboard, I can go back and write to this contract. Now I need to make sure that I am on the Rinkeby test network, which I'm pretty sure I am, and then I can go ahead and connect. Let me connect through MetaMask, and I'm just going to say that's fine. We'll connect with this one. Just make very sure that you are connected to this site, otherwise it won't work. Now let's go and add a drop by pasting in this tuple. I'm going to specify my square brackets and then paste my data inside of it. So you have to wrap the data in square brackets, and let's say write. It's going to ask me for a transaction and I'm going to say yes. If we take a look at our transactions, we can see that our transaction is now gone through successfully. Now what we can do is actually read from the contract and check that data out. So if we go ahead and query the drops, we can see that boom, there's our image URI, and we need to, well, this is the actual struct, and we need to query. So let's query number 0. And if we call it, we can see there's all of our data. Perfect. Now we don't want to do the drops like this. We want to call this get drops, and this will actually return to us a list of tuples. So what does it say here? Test.png, this collection. So it actually returns to us the whole list in its own format. But this is something we will actually now use in our dApp. What I would like to do though is actually go back to writing to the contract and doing this again. This time not pasting that. Let's just go back here. Let me grab this data again, like so. And let me remove it. I'm just going to add one more because I want to see if we can pull in different data. So this is my my test 2, like so. Now we need to be connected. So let's connect. And now once we connected, let's just add it. and kick off this transaction. Now for the next part, and this is actually reading this data from the contract, not from Etherscan, but from our own dApp. And that would be easy to do. We already have our connection to our contract. So now let's set up a function that we can kick off and wait for the data to be returned so we can list them on our dApp. We at least need some valid data. I'm talking about the image. We at least need the image to be live hosted somewhere in order for it to render. So here you can see I've got under hashlips.online, I've got a test image. So let me go back to the program or the contract and let me go and update the drop. So now what I need to do is paste exactly the same data over here that I want to update, as well as the index. I have to stay on the owner of this drop, which I already am. Now before I update this, let me just grab the proper URI, which is this one. So I'm going to place it in there, like so, and then click write. Perfect. I've gone ahead and updated the other one as well. So now when we call the get drops, we get two tuples, which is basically our two drop structs. Now we're ready to pull this into the dApp. In order to read data from the blockchain, we can create a new function. So let's go ahead and remove this console.log and write const, and our function is going to be maybe get info, or we can call it something like get drops, which is also pretty cool. So now that we have the get drops method on our front end, we can go and specify a function. And then in this function, it's not going to take anything, but we are going to make it asynchronous. Again, we need to wait for the blockchain to return some data to us. Grabbing data from the blockchain after setting up a connection is fairly simple. All you need to do now is get access to your contract, which we already have, by going to the info.contract, saying methods.getDrops, because that is the method that we want to call. And then after that, you say call. This means that it's going to call it and then await for the data to being returned. Now you can put await before this, but what I'm going to do is I'm going to say then result, right? So we're going to take the result and then do something with the result. This time I'm going to just log it out. So let me log out the result, and let's also cater for if something goes wrong. So let's just catch it. So we need to say .catch, and then we can just simply do something with the error. For now, I'm also going to just log it out. You can gracefully handle errors like this. This is similar to using the await method like we've done here, where we basically await for a result to come back and wrap it in an if statement or a try catch block. But you can also do it like this. Now once we have it, we need to call the get drops. So down here in my divs, I'm just going to create a quick button for us to use. So I'm going to say this is get drops, and we're going to create a click handler, and the function that we want to call is actually our local get drops. Perfect. Let's hope for the best and see if we get those drops back. So if I go to my dApp now, there's my button, and if I click on it, there we go. Boom. There's our first one, and you can see it has all of the fields as well as my second one. We can see that this returns an array for us with some elements. Now I think it is time so that we can at least render this on the screen. So we're going to do a basic render of this, and let's see how we can do it using more state. So right here at the top, let's create a state variable, and let's call it maybe something like drops. So we are going to create a variable. This is going to be our drops. We're also going to have a set drops, and we're also going to say this is use state, like so. For the initial value, I'm going to have two variables. I'm going to have a loading, because whenever we get drops, I want this variable to be true. So on start, it's going to be false, and then we actually need the drops. So I'm going to actually call this the list, and this will be an empty array. Let's follow best practices like we are doing here at the top and create some initial state. I'm going to say this is the initial drop state, and we didn't do the state part here, which is fine. I just want to clearly define that this is state. But anyway, it's up to you. You can call this whatever you like. I am, however, going to take this whole object and cut it out and put it in here. Then we are going to initialize with our initial drop state. Now you can see that this list is empty and we want to populate it. So let's go and set the drops whenever we call getDrops, and instead of console.logging the result, we want to set the drops to a new object. We want to basically set this to the initial state, or let's think about this for a second. We probably want this to be the drop state, which is the current drops that we have, plus we want to update the list to be the result, like so. Now, this means that it will take in the current drop state. We also then need to make loading to false. So, therefore, we don't need that at all. If this fails, I would simply like to reset this to the initial state, and that's why I made it a state variable at the top. Awesome. Now, before we carry on, I would like to do one more state update, and this is going to happen before everything kicks off. Now, I'm going to do it like this, where I specify the previous state, like so, and then I want it to return to me an object. So I just need to get rid of all these things. Let's cut this out. Let's get rid of that. Let's add this in like so. And the reason why I'm doing this is so that we get to return this, but I want the previous state to be spread out first. The reason for that is so that, let's say there was already things loaded and we just want to refresh, we can then get the drops and it will show the previous list as well as the new list. So it would almost just merge them. Perfect. This is awesome. So now that we have this, we are saving it in state. And in React, when state updates, it re-renders, meaning that we can now take this data and render it on the screen. Now let me show you the true power of React. Inside here where the HTML is written, I'm going to create just a line break, and then we're going to try and render our list. But what we are going to do first is create a p tag like so. And the reason for this is for us just to say something is loading. Now, what I'm going to do is I'm going to specify my curly braces and say if my drops.loading, meaning that if the state is true, with a question mark, show this. Else, I'm simply going to say don't show anything. So I just want to show you this small example that if we alter the state, which this function does, it will then show the loading text. So let's go there, let's click on get drops, and you'll see that it should say loading. Now, the reason why it's not doing that is because let's just make sure that we're setting the loading to true up here, like so, and then go back and then click get drops. So you see it's a quick flash. That might be very quick, so I don't even know if that's necessary. That's super quick. We will leave it in there anyway, even though it is a bit fast. Now we have the option to, instead of returning null, we can do what we are going to be doing now. But I'm going to keep them in separate states so that you can just get the hang of using React. Now we're going to open and close another curly braces, and this time I'm going to focus on the drops, for this time the list. I'm going to map over the items, and then inside here I'm going to specify that we have the item. And what should we do with the item? Well, we first of all need to return something. So I'm going to say we need to return, and let's just return a p tag for now. P tag stands for paragraph, by the way. And let's just return hello. This is a simple example, but you'll see where I'm getting with this. So now if I say get drops, you can see there's two hellos. These hellos basically represent each of these items. So instead of saying hello, we can basically go and drill down and get this information. So let me just copy this for a brief second to paste it in the code as a comment so that we can see what we are dealing with. So I'm just going to comment this out so we can make use of these variables in our item. Check how cool this is. Because we have access to each item, what we can basically do now is, rather than just return that simple p tag, we can return a few. Okay, so I'm just going to return a few like this, and then we can save them like so. Let me just wrap this in a div. Perfect. And let's go ahead and do a few things. So I'm going to grab the description. I also want to grab the name. We can grab pre-sale. This is actually the time that the pre-sale starts. So let's group them together. What else do we need? We need this supply. I'm going to render the supply over there. And what else? The socials. So let's actually render the socials as well. So we need these. We don't need all of them for now, but I just want to show you how it's going to work. So I want to kind of just list them out so that we know also what they are. Like so. And then I'm going to put my curly braces and basically put whatever is in there over here. But I can't just say name. This time I have to say item.name, because we are referencing something that's coming back from the backend. So we're referencing this. We will see what's happening here in just a second. For now, just know that you need to say item.name, item.description, and so on. Okay, so I'm going to copy and paste this quickly in there. And then just update these. All right, perfect. Okay, so now we're ready to rock. Now, what this basically is doing is it's saying for each one of these drops in the list, map over it and basically return to me the list. But we are returning it over here, okay? And this is returning this data set. So if I save this, check what happens. If I reload my page, I can see that when I click on drops, I get back both of my tuples, or so-called drops. And this is the information that's needed to display to a user to tell them exactly when a drop is going to take place. So technically, we are halfway there in completing this DApp. The only thing that's really needed now is to kind of render the image, make it look nice, and then as well create a form for us to push more data to it. Like I said, we probably want to render the image. So you can just specify an image tag, give it some alt text if you want to, and specify and say this is drop image. And then the source is going to be coming from the item. And what did we specify this as? Image URI. So this is going to be the image URI, and then we can end it off. I'm also going to give it some style, because without style it's going to look quite big. So for now we're not going to focus on styling just yet, but let's just give it a style of like 40 by a height of 40 as well. Okay, and that's perfect. So now if we go back to our DApp, we'll get to this in just a second, but you can see there is our two images. Okay, and that is cool. The next step that we want to do, and I kind of pre-revealed it a bit, but that is looking at implementing a form. Now, forms in React is quite simple, but what simpler way is there than using a library? Now, this React hook form is a simple library for us to just hook up a form very easily. All you need to do is use this npm install script to install it. So let's go ahead and do that first. I'm going to click Command C to end my program and then install React hook form. You can basically use any form, any means to get data from the user so that we can add a drop to our contract. So after installing this, we're going to implement the simple form and just see if we can upload a drop from our site. After installing, I'm going to go ahead and read the documentation quickly. So they want us to basically include this form in the import, so we're going to do that. Going to put it there at the top. Then we're going to go back, and I see that they want us to basically create this as well as another constant on submit to do some error or some logging basically of the data. So let's go and copy these two things. Let's go up to our state. Let's add that state. And this is a function, so I'm not going to leave it up there, but I'll bring it down here, like so. This is what's going to happen when we submit our data. Then they have an example form for us over here, which I'm going to copy, but just that part, because I just need that. And then let's maybe paste it right after this. Like I said, we'll worry about styling in just a second. For now, let's try and render this out and see if it even works. So let's go back to our dApp and let's refresh. Remember to run npm run start for it to spin up the local server. And there we go. There's our form. So now it doesn't have labels, but I presume this is now my name and surname, and I think this is the age. So I'm going to say, okay, cool, I'm 29, and submit. We can see that we now get this object logged out, and we have the age, the first name, and last name. And if we can recall what we need to pass through whenever we upload something to our blockchain, especially when we go and check the write method, remember we need to pass in an array with all the values. So we can probably construct this from this, basically this object, after getting and collecting all the data that we need. So I've now gone ahead and completed this form. Now it's a very basic form, so I'm just going to slowly go down so that you can maybe pause the video and have a look at what I've done. But in essence, I've just added a label and focused on a single input. There is no validation kind of checks happening. That I'll leave up to you guys to, explore the app and make it a lot better. For me, the whole purpose is to just show you exactly how to pull data and push data to the blockchain via the connection, because that's essentially what a dApp is. But needless to say, this is our simple form, and it has all the fields that we need down here. Where I got this from was by going back to our contract and then looking at our drop and exactly what the order was. Now, this is how our form is going to kind of be set up, and this is how it looks. So far, it's very ugly, but we will make it pretty very soon. And the next thing that we need to do is kind of read all this data. If we submit this, we can see that indeed we get this object, which is now empty, but we get this object. So our first mission is to kind of take this object and reiterate or iterate over it and take all the values and put it into an array so that we can then call it and call our add drop function. This is great, but we see a problem. Not all of the values that we need to pass are strings. Some of them are numeric values. So we need to go and map this data before we push it to the blockchain. Let's focus on our onSubmit function and go and remove that. open curly braces. Let's create a new data variable, put the curly braces and paste in that over there. Now we can see that at least we have some sort of structure over here. I'm going to just add all the commas, and I got this data from Chrome's console, just like this. There we go. This should be the data that's kind of represented over here from our form. But we need to double check that it is indeed all the data that we got from our contract. We also need to make sure that it all falls in the same format. So down here, I'm going to have a look at this, and then we see that we need image URI at the top. Then we will need the name. So let's just put the image URI at the top. We're going to take the name, cut it out, put it there, then the description, put it there, and so on. I'm going to do this and then pause the video quickly. The data is now organized in the order that I want them. I also gone ahead and added the approve field because that's something that we need in our struct. Otherwise, the application will not accept this data. We can now technically get rid of this because this was just for reference. We still need to only get the values in an array. How can we do that? Well, we can use object.keys to get the keys, but we can also use object.values to get all the values in an array. The first thing that we need to do though is extract some of these elements or some of these variables in this order. So we need to now say data is going to be the image data, and then we get the name, which should be name, description, and so on. You get the point. But I am going to do this with you because I need to show you that some of these fields we need to actually change into numeric values, numbers. So I'm going to change this, then quickly just replace. And these are all strings, so they are fine. Even the supply, well, actually the supply starts to be numeric values. Now, what we need to do is let's wrap this and cast this as a number. Okay, number, like so. By doing this, we are telling JavaScript to take whatever this input is and create a number of it. So we have to make sure to input numeric values in our form. This is something to do with validation, but that's fine. We're not going to focus on that right now. Next, what we can do is, let me just console.log what we will have. So I'm going to say console.log the new data, but not only the new data. We want to say object.values, and then we want to pass the new data. When we save this, let's go back to the browser and click on submit, and now you can see that the array actually considers this to be numeric values, and it makes it a 0. There are numerous ways of doing things in JavaScript. This is one way how we can map it to the data that we need and then cast it into an array. Now, that being said, the last thing or the last step we need to do is basically post this to our blockchain and create a transaction. We can do that because we already have done this before. I'm going to copy this line of code in the getDrops function and paste it down here. Basically, we need to now change the getDrops to add drop, like so. We're going to change the call into send because this is a transaction, and we're going to put in curly braces and create a from field. The from field is basically going to be who is this from, and we have that because we have access to our account that the person's MetaMask is connected to. So we're going to do that, and that should be it. We need to remember to, in add drops, pass the variables, the array. So that's why I'm going to take this, cut it out, and paste it in there, and get rid of this console.log. So now that we have this, we can basically test this out. I've gone ahead and filled in some of the values in our form. I filled in all the Hashlab's details such as an image URI where it's living, the name, description, Twitter, Discord, website, as well as the price, supply, and now I'm busy with the pre-sale and sales variables. To get a timestamp, what you can do is go to this website, enter in a day, maybe say day 6, and then grab the milliseconds timestamp of that. This is how I'm doing it. Then for the chain, it's going to be on Ethereum. Let's just pretend it is, and we're going to say chain 1. Now let's go and submit. We will see that MetaMask wants us to create a transaction. And I'm going to go ahead and confirm this. We will see if this goes through and then query it again on our drops. So for now, let's go back to Etherscan. When we look at Etherscan, we can see that this indeed went through successfully. We can also click on the transaction and see what happened. Now we can see the data that was passed through over there and everything looks good. So if we click on Get Drops Now, we should get all of our data back. And indeed we do. Check it out. We get the first 2 that we've added manually on Etherscan, as well as the one that we've just added through our dApp, through the form. Now, this is cool and all the functionality is done, but this app looks ugly. So we need to now work a bit on styling, and that's what we are going to do. I'm going to show you how to do basic styling so that you can get used to working with CSS, JSX, how to style in React, and it's going to be super fun. So let's jump into that and let's give this page a bit more styling. We need to remember to remove these 2 state changes because we're not setting the drops, we're simply sending it. Remember, this is the send function. I forgot to remove them, but they're not needed, and if you leave them in there, it will break the app. So take them out, and we should be ready to style. Before we get into styling, I want to say thank you for watching this video to this point. Please leave a like, a comment, and subscribe if you haven't and you want to see more awesome content like this. Lastly, if you're struggling, you can go and visit our Discord channel, which is great. So if you go to the website, all the links are here. Let's continue with CSS. Let's take a look at how we can structure the data first. Now we can use routes, which is perfectly fine, but I want to show you React tabs. This is a cool library that we can use to organize the data into different tabs. We mainly want a main tab and a tab for us to add more drops. So copy this line, npm install, and let's go to our program, and then we're going to paste it in here at the bottom. Remember to exit the program in your terminal before doing this, and let's install it. We can see that this library will help assist in organizing into different tabs. This is important for the beginner level because you can basically build this out with routes like I mentioned. But let's go ahead and use this. I'm going to go and import all this into my program. So I'm going to go there and import it like so. Now that we have the tab, the tabs, tab list, and panels, and the CSS that they recommend for the tabs imported, we can see what's next. They want us to create a tab section like so. So let's go and do the same. We're going to go down to where our program is, and it's basically this part, and then I'm going to paste this in here at the very top. I need to organize this data, and the reason why it's breaking is because JSX allows you to only ever export one component. Technically, we're exporting more than one. So let's go and put these in the respective fields. Now, I'm going to take everything from here. Let's see. Let's put everything from this button in the first panel. Then the form itself will be in its own panel. So I'm going to copy the form or cut the form and put it in this panel. Conveniently, they already have two panels for us on the boilerplate. If we now jump back to our dApp and refresh, we should see that this works. Remember to first run your program by running npm run start. So once we run this program, it's going to implement all the changes and we should see some kind of tab happening. So there we go. we see that we've got our title 1 and title 2. Title 2 now houses our form, where title 1 is the get drops, and we can still load them. That's perfect. We just need to kind of center these a bit and change the styling of the tabs because they look quite plain. But we also need to remember to change the names. So a lot more to come. But we're going to do this section by section so that you truly understand how styling kind of works. I am going to do a course on CSS purely, and you'll get used to using CSS. For now, just enjoy what we are doing and play around as you code along. We will need a space to save all of our styles. For now, we can just create a new folder and call it styles. In there, let's create a new file and call it styles.css, like so. Now that we have this, let's go and import it in our app. So all we need to do is write import and then specify the path. So our path is going to be one back, then going to the styles, and then it's styles.css. To test if this worked, we can simply go to our styles and type in body, and let's give it a style for the whole body, and let's make the background color maybe aqua, and let's save it. Let's go back to the DApp. Let's refresh and see. Perfect. Our styles are hooked up, and now we can play with it. Remember, our main goal is to get something similar. We want this kind of background color to be dark, some text if we need to, some descriptive text, and then maybe a header. So instead of making the background aqua, let's go and choose a nice color. Let's choose like a deep blue, like so. Let's check it out. And this is going to be constantly going back and forth to check out our progress. That looks cool. Now let's create some kind of header section. So we can go back to our DApp and go to the HTML part. Let's see. Here at the very top, let's create a new div. So we're going to create a div and we're going to give it a style. So this div is going to have some text. For now, I'm just going to add some text. So let's just do this, and I'm going to say hello. We'll work out the text and what we need to put there in just a second. This whole thing though, I need to wrap in a div as well, otherwise it won't work. So that's the beginning, and then here's the very end. Let's save that, go back and verify. There it is. In the styles file, I'm going to specify a header class. You specify classes with a dot in front of the word. I basically want to make the width full screen or full length, so I'm going to make it 100%. I'm going to give it another height, and this time I think it should be 60 pixels, maybe a bit smaller even, maybe 45 pixels. Now also I'm going to add a background color. This time I want it kind of the same color as we have over here, just lighter. So I'm going to specify that, and then I'm going to see if I can change this color over here. Okay, perfect. So I'm going to make it a bit more lighter like that. I'm going to save it, and I need to go to my drop list and actually give it a class name. So I'm going to specify as this as header, like so. And now that it has the class on it, we can see it basically does what we need to, but we see this kind of weird padding. Now this is innate to HTML. It comes with this padding on the body and on the HTML. So let's go reset that. It's always a good practice to have a reset function, basically setting the margin and the padding to 0. So I'm going to also add the HTML in here because I don't mind the HTML also being that color, the background basically. But we also want to set the padding to 0, like so, and let's just make it 0 pixels. And then also we want to set the margin to 0 pixels. Now if we save that and go back, we'll see that there's no margin and padding on the sides, but there's still a little bit here on the top. For that reason, I'm going to remove this out of here and then go to the very top and specify an asterisk. This will allow us to put the style on everything basically. So I want everything not to have a margin and not to have a padding. Now if we go back, we can see that it's all cleared out. And that's perfect. Now we actually have our header and our two tabs. I want the header to have a little bit of padding, have white text, and maybe say something different like NFT Hunter. Let's go and do the changes. I'm firstly going to change this to an H1 or maybe an H3 will suffice. Then I'm going to say this is our NFT Hunter. Well, let's call it NFT Drop Hunter. And that's good. Let's now change the color to be white. And I'm actually going to choose this Alice Blue. That looks awesome. So let's go back. You can see it's white. Then we're going to go ahead, go back to Visual Studio Code in our styles and add some padding. We want to add padding because we don't want it to be too close to the side. So I'm going to add 10 pixels for the top and the bottom, and then 25 pixels for the left and the right. If I save that, go back, I can see that indeed we have some padding over there, which is bigger than the top and the bottom. But it's not centered, and we have this awkward size. So I've got two options here. I can either take away my height, save this, and it will collapse in on itself, which is good. But there's also a way where we can use flex direction. For now, I'm just going to leave it like that and make the padding control the height. So that's perfect. Now let's focus on this whole section over here. I'm going to go back to my drop list and then let's create a new div. See a div as a container, and you can use containers to containerize things. So we got our outer div, and then we get this extra div over here. This div is going to be the content, so I actually am going to give it a class name and call it content, like so. Then we're going to add the style maybe below the header. For the content, I also wanted to have some padding, but this time I'm going to add the padding 25 pixels all around. That way we actually get a nice alignment over there and we still get to see our things. I now want to go ahead and see if I can override the color to be this Alice Blue as well. I'm not sure if this is going to work, but it did. And the reason I wasn't sure before is because I was worried that the underlying styles of the tabs was going to overwrite it. But this looks good. When we click on Get Drops, we can see that it loads in our drops, and there they are. But they look extremely ugly. So let's go ahead and style it so that it's maybe organized in a row and see how that looks. We also need to make the image a bit better, and let's round the image even. I'm not sure what we're going to do, but we are going to make it look a bit better. All right, let's go ahead and do so. We need to start off by actually structuring the data or the actual content and how we want it to look inside of our HTML. So let's go and define the structure. We can take a look at how Rarity Tools structured theirs. I see that they have their name description over there, then the image, and then the data over here. So let's do the same. We have to create a container for this to save the name as well as the description and image, and then we need two more containers. So if we go back, let's start containerizing everything. So we need another div in our structure, which we're going to define as the image div basically. So we need the image, name, and description in here. We also need the name and the description to be on top of the image. And then let's take out the style completely and let's maybe give it a class name rather. We can say this is going to be our, I don't know, image or drop. I think drop image would be fine. We can go to our styles and in here just define what our drop image would be looking like. Let's specify a width and a height. So the width, maybe we can create it as 200 pixels for now. Let's save it and see how it looks. That looks a bit better. It's a bit bigger. We can get away with that, I think, for now. we want to keep the name here at the top and the description as well. Now, in our drop list, we see that we are defining them by name and description. We really don't need that, seeing that obviously people will just read what it is. We can maybe have stuff like the supply, but let's just call it total supply, like so, and then the sale date. Let's do this. So the sale date, and maybe for this one we'll have the pre-sale date. Perfect. But we still need to go ahead and we can't call this socials, so we can say this is our Twitter and this is our Discord. Like I said, we need more containers over here. So let's specify a new container with a div. And what do we need to put in here? Well, I would like to put in the 2 social medias in there, seeing that that is how Rarity Tools are doing it. Seeing that we just want to do basic styling and keep to what they have. They also have the total supply and then the start date and the pre-sale date. So pre-sale should probably come before start date, like so. Let's cut that out and also put it in a container. And that looks pretty cool. Now we need to structure it so that it all is structured in a row. So what we're going to do now is go to style, and this is the content. Let's call this the drop container, like so. In here, we're going to say this needs to display flex, and then because we are saying display flex, it would be automatically going into a row. So once we have this, I'll just show you. I can save this and put it as this class over here, class name. Specify this as the drop container. This should go and list these in a row, like so. And there you can see it is indeed doing that. There's our first container, second one, and third one. Let's go ahead and change the whole font family to something else as well. Now, anything would look better than the other one, so maybe this should work well. And then if it can't find Lucida Sans, and then it will check for the next one, then Vehendra. I actually like Vehendra the most, so I'm just going to specify Vehendra, and then for the rest, I'm pretty sure it's going to have Vehendra. So let's just go back, and we can see that the text looks way better. We also want the content to stretch the full length. So for this, we can basically create the width to 100% or flex it as 1, whichever you prefer. We're also going to maybe give it a different background color. So let's give it a background color. And again, I'm going to choose this because I want to use this shade all over the place. Then I'm going to specify maybe an even darker color for this. I'm also going to add a padding, and I can basically add a padding all around. That's awesome. And then for the flex, for the alignment of items, so this time we need to justify the content to space between, like so. Once we have this, you can see that already this is now space between, but it's not really aligned. To align the items, all we need to do is say align items center. I also want to create a text. Basically, let's call this the drop text. Now, the drop text, the only thing I need there basically is a margin bottom. So let's go and say margin bottom, and it's going to be about 5 pixels. The reason why I want this is so that it at least gives a little bit of space. We can do much more with this, but for now, let's go and do that. So I'm going to add it over here, and I also want this to be there, there, and there. Now, sometimes this is a bit more redundant, so you can just basically target the p tag in the div class, but let me just make it explicit. So if we go back, you can see that it is now a bit more spaced out. Let's make the text a bit smaller as well. Maybe a font size of 15 pixels will look a bit better. Then I want to darken this color even further because we can't really see it. I also give it a border radius of maybe 15 or 20 pixels, as well as my image. So the image is over here. So I'm going to do that as well. Let's save it and see. This looks way better. But now we can see that we need some spacing over here as well as between each one of these drops. How we can achieve this is by actually going, and I just want to make this a little bit lighter, is by actually going to this drop, and we can now either go ahead and create some space at the bottom or put a margin. So maybe let's put a margin bottom, and this time I'm going to say 50 pixels. Let's save it. Let's see. And there we go. Now we get some margin at the bottom. We still have this here at the top that is very close, but that is fine because we'll put something in there just now. Let's go back to our drop list markup, and then let's see this tab. So we got this loading, and then before everything starts, let's add another div. I'm just simply going to use this div as a spacer. So I'm going to give it some style, and this time I'm going to say it's going to have a height of 50 pixels, like so. I'm just going to say 50 in there. I also want to specify that there needs to be some kind of space between the description and the image. Probably doesn't have to be that big, but maybe 20 would be good. And there we go. This looks fine. Now let's go and have a look at if we can get away with calling the drops the whole time. I don't want to refresh and there's nothing there, and then I have to click on drops. How we can achieve this is basically by getting rid of this get drops. We also don't really need the loading for now because it loads super fast. Maybe we'll need it later again. And then what we want to do is, instead of just instantiating it like that, we want to create another use effect. This use effect is basically going to be there for us to check whether the contract is there. So if we can check if info, so let's put a if statement. If the info dot has a contract, meaning that we are basically connected to the blockchain, then go and get our drops. And this should happen every time that info updates. Perfect. So let's leave it like that. Let's go back to our site. Let's refresh, and you can see that immediately it goes and gets our drops. And that is basically it. A few things that we can still do is stuff like display the timestamp in a nice readable format, add a section for the admin to go ahead and approve some of these drops before they get displayed to the user, work on the actual form because that looks a bit ugly still, but it comes down to the gist of it. I'm not going to spend hours of doing CSS and making this video super long. I'll leave that up to you to experiment and try out. But I hope in this video I have explained it enough for you to get excited, and let me know in the comments if you would like to see me do a full-on CSS tutorial. That being said, I hope you got the gist of it of how to create a dApp with this whole series. So let me know in the comments. I do read them, and give this video a thumbs up if you enjoyed it. Subscribe to never miss a moment, and I want to say thank you to the 18,000 subscribers of my channel. You guys are awesome. If you are struggling with any of the content, like I said, go to my website and then go to Discord or Telegram. There's many devs that will help you out. Lastly,
hey everybody,
this is channel because something exciting is going to
deploy them and run them. And that's exactly what I'm going to use for this tutorial. You won't have to download anything on your computer. You won't have to install anything. You can just visit this website to use Remix, and we'll write the smart contracts that way. So in order to do that, I'm going to go over here to this browser folder. You can see the file browser over here. This is some basic smart contracts that come preloaded inside of this IDE. I'm just going to create a new one here. I think I can just create a new file. This will be a Solidity file. We'll call it My Contract, and we're going to write a smart contract inside of here. I'll do this by first declaring the version of Solidity that we want to use. We just do that like this. We say pragma Solidity, and I'm going to use a caret to specify a version greater than the one we want to use. And I'm going to say version 0.4.24. And I'm going to end each line like this with a semicolon. And next, I'm actually going to declare the smart contract. So before I do that, I'll explain a little bit more about what a smart contract is. Smart contract is code that gets executed on the blockchain. In this case, this is going to be the Ethereum blockchain, since we're using Solidity for this Ethereum smart contract. And this smart contract is kind of like a microservice out on the web. It's going to be accessible to everyone on the blockchain. They'll be able to see this smart contract. They'll be able to use it. They'll be able to read and write data with it and actually execute any code that we write inside of here. So it's going to be public. And that's kind of why I call it like a microservice. It's more than just a class, like in an object-oriented system or something like that. It's actually something that's publicly accessible. So it's going to look something like a class, though, because that's how we're going to actually, keep all the code inside of here. So I'll show you how to do that. We'll start by saying contract. We'll say my contract. And I'm going to open this with some curly braces, and it'll notice that the editor closes this automatically for us, which is really nice. And what I'm going to do first is just show you how to read and write a value from a variable inside of here. Now, like I said earlier, Solidity is a statically typed language, so we're going to actually have to declare the type, the data type of the variable we want to store. So in this case, we're just going to store a string. And we'll declare a string, and we'll say value. Now let me explain something about this value. This value is going to represent a variable that belongs to this entire smart contract. So this isn't like a local variable. It's actually a variable that this entire contract will know about. And what that means with a smart contract is that data is actually going to get stored on the blockchain in storage. So if we set this value, we're actually going to be writing data to the blockchain. That's different from a local variable that I might just set inside of a function that would be local to that function scope and would disappear instantly once that function is called. Instead, this value is actually going to be stored on the blockchain. So let's create a way to just read this value. So I can do this by writing a function in Solidity like this. We just start with the function keyword. And I say, I'm just going to call the function get. It's going to get this value. And we'll just open the braces for now. I'm going to write some more code here in a second. We can see some warnings coming up, but I'll fill this out more. We'll say just return value. Okay? And that's a really basic way to do this. I'm going to add some more to this. I'm going to say this is also public. All right? Which basically is setting the visibility of this function. That's what that's called in Solidity, is setting the visibility. So that knows that this function can be called by anyone who has access to the smart contract on the blockchain, not just inside this contract. So I'm also going to set a return value, say returns string. All right, that makes our warning disappear down here. And that just tells our function that we're always going to return a string data type. And we know that's the same data type as value because we declared it here. Now I'm also going to look at this warning down here which says this function state mutability can be restricted. So basically what this is saying is in Solidity now, in this newest version, since we're not actually changing this value, we're not changing anything inside this function, we want to add an additional modifier here which just says view. All right, and that makes that warning go away. So now I'm going to set a new function or write a new function that's called set. Let's say function. It's going to allow us to set this value. I'll say set and say string. I'll say value. All right. And I'm also going to, set the visibility of this function. I'm going to call it public, which means that anyone will be able to set this value on the blockchain. And I'll say value equals this value that we're passing in. All right. Let me explain that. I'm using value as an underscore here because I want to differentiate between this value that's getting passed in and the value that's referenced here. Now inside of here, this value without an underscore is referencing this, state variable that we set up earlier. that's actually getting stored to the blockchain. And this value, Solidity knows that it's just a local variable because I passed it in and I prepended it with an underscore like this. And also notice that I declared the data type of the function argument. We need that inside Solidity because it needs to know the type of the data that's getting passed in. All right, and now we have a way to actually read this value and set it. The next thing I'm going to show you is how to set this value whenever we deploy the smart contract or whenever it's generated for the first time. And I'm going to do this with a constructor function. So if you're familiar with other programming languages where you might write, classes or something like that, you might be familiar with a constructor function, which is basically a function that's called whenever this contract is instantiated, or in this case, it's going to be whenever the contract is created or whenever the smart contract is deployed to the blockchain. And in the newer versions of Solidity, we do that like this. We say constructor, and we just say it's public. And we can write code inside of this constructor that gets called whenever this contract is created. And we'll say value. We'll just set it as my value. All right, there we go. So that's a complete smart contract that sets this value whenever it's deployed, so it will have some sort of default value, and then we'll have some functions that allow us to read that value from the blockchain, and then we'll have a function that allows us to create that value as well. So now I can go to this tab over here in Remix, and I can compile it. We can select the compiler version, and I'm going to say, let's see here, 0.4.25. We'll start to compile it and see what happens. All right. And now what I'm going to do is actually run the smart contract. You'll see some options over here. I'm just going to say JavaScript virtual machine, which basically what that's going to do is give us a test blockchain in the browser. So we don't have to connect to a blockchain of any kind. We can just, compile this and run it and deploy it inside of our browser, which is pretty cool. And it's going to give us some, free Ethereum accounts over here. Now, don't worry if you don't quite understand what all these values mean just yet. That's okay. I can explain those more. But for now, we're going to just keep my contract and we're going to deploy it. All right, there we go. It's deployed. So now what I can do is click on this little down arrow here, and we can see the functions that are available to us in the smart contract. We can see the set function and the get function. These are the functions that we created over here. The set function is going to allow us to update it, and the get functions allow us to get it. So I'll click get, and we should probably see the value that we created inside the constructor. We set it here. So let's get it. All right, there we go. It's my value. And we can see some activity in this log down here. We can see that there's a call to mycontract.get. And now let's set it. So I'm going to enter the quotations for the string, and I'm going to say new value. All right, let's click set. All right, and we can see that worked. So you can see the transaction history over here. Let's look at the value. All right, it's new value. There we go. That's a complete smart contract that allows you to get and set a value on the blockchain. Now let me explain what's going on here. This is a list of transactions that are occurring on the Ethereum blockchain. So the Ethereum blockchain is made up of bundles of records that are chained together into blocks that make up the blockchain. And the basic unit of all those blocks are these transactions. So we can see transaction receipts. We can actually click the down arrows here. We can see all the details of those transaction receipts. And I've got other videos on this channel that kind of talk about that in detail. If you want to know more about that, just feel free to look for those. All right, that's it, guys. That's how you can write your first smart contract in the Solidity programming language. Again, that's supposed to be just a high-level overview of Solidity and how to get started writing your first smart contracts and using the programming language itself and using the Remix IDE in your browser to get started easily without having to download any tools or anything like that. The first thing I want to do in this video is actually update the smart contract code that we wrote in the last video to support the newest version of the Solidity programming language, which is 0.5.1, I believe. You can actually see the compiler version over here has changed. And in the last video, we wrote this smart contract, and there's some compilation errors you can see over here on the right. So you have to update this code to support the newest version of the Solidity programming language. And I wanted to go ahead and do this. I wanted to go ahead and support the new version of Solidity so that when I make more videos in this series, they'll be up to date and you'll have the newest version. So let's see what we need to do. We can read the error. It says basically the data location must be memory. And that's actually the error in both cases. So all we need to do in this case is actually just return memory here. And then whenever we're passing in the value string, we actually need to put memory here as well. All right. Actually, that needs to be before value, my fault. And now the errors go away. So we will select the newest compiler version. We'll say, let's do the latest complete version, 0.5.1. Start to compile. And hopefully the compilation will work. Yep, it worked. So let's go to run, and we'll deploy. And let's see if it worked. So get the value. Yep, it worked. Awesome. Now let's move on to the next part of this tutorial where we'll actually cover the content for this video, which is going to be, the basic data types and data structures in Solidity and how you can use them when you're developing your own smart contracts. So I will change some values in here to kind of show you what that is. The first thing I want to talk about are, the different ways we can work with these state variables, right? So the first thing I want to mention is, we had this string value here that we had declared, and we set it here inside this set function, and we had this getter function where we read that value, right? So Solidity has a shortcut where I don't even need this function. I can actually just read this string value for free. I can actually get this function for free. I can take this out and just declare this public. And that's declaring the visibility of the state variable here. Actually, public goes before. So I'll save that and I'll compile it. And I'll run it. And we'll see that a getter function called value, the same name as the state variable, was exposed to us by the smart contract. And we can see it works just the same way as that other function did. So that's a really nice way to save yourself from writing extra code. You can just get that function for free exposed to the public interface of the smart contract whenever you store your state variables that way. Okay, so the next thing I want to talk about inside of here is actually, we could set this as a default value. We don't necessarily have to put, my value here in the constructor. We could just say this, right? We could take this away. Oops. Take this away. And we will run that again. Let's just clear this out. Deploy. All right. And we can, actually, sorry, we need to compile it first. Deploy it again. Get the value. And we can see it's my value. We can also set this value as a constant if we don't want it to change. If we don't want to allow a user to set this value, if we want it to stay the same, we can just say constant. All right, that actually declares a constant. We have to remove this function. We can't update this value at all. Solidity won't let us do that. So we could just do that. I'll deploy this again, and we can still see our values here as my value. So yeah, that's how you would add a constant to your state variables or make your state variables a constant. Now let's look at some other data types in Solidity. Let's just change this name. We'll call this like string value. All right, let's just deploy that. We can see this instance here again. String value, all right, it's my value. Now let's explore some other data types. We can say a Boolean type. We'll say bool, public is equal to, I'm going to remove this constant for now. My bool equals true, all right? So this just accepts true or false. We can deploy that. See this, my bool, right? It's true. String value is my value. Say, or my string, just save that, just for fun. And we can also see that, we support data types like integers. So integers can be signed or unsigned. So what does that mean? Well, we can do a default int which would be public myInt equals 1, right? So we can deploy this and see. Let's actually just clear this out. Sorry, deploy this and see myInt is equal to 1. So the difference between an int and a uint, or an unsigned integer, is that an integer can be signed in a, an integer can be signed and a uint can be unsigned. So what does that mean? Well, basically an int can be negative. So I can do -1, all right, and deploy that. That's a signed integer. It has a sign in front of it. It can be positive or negative, and a uint can't. So we'll deploy that, clear these out, and see myUint, all right, and myInt, all right. Yeah, so -1 can work for an int, and they can't do negatives on unsigned integers. You can also specify the amount of bytes or bits in an integer. So we can say uint 8 equals myUint 8. Sorry. Equals all right. Oops. Let's do a small number. And we can see myUint 8. All right. And so if we do uint here, it defaults to 256, I believe. Uint 256, public, myUint. Okay. So that gives you a basic overview of all those basic data types. I don't want to bore you with all the pedantic details of this kind of stuff, but this is helpful to know, I feel like. The next thing I want to show you is an enum. So what is an enum and how do you use it? Well, an enum is basically an enumerated list that's going to allow us to keep track of a set list of things in our contract. So I'll show you what that means. So basically, I can declare an enum like this. I'll say enum state, and I'll give it some options here. I'll say waiting, ready, active, all right? And this is going to allow us to keep a list of these 3 states inside the smart contract. We'll be able to reference this to see what the current state is, and it'll give us some options whenever we're updating the state and checking against this. So I'll show you an example. We'll actually store this like this. We'll declare state, public, state, like this, all right? So basically, this is going to give us a public, we're going to be able to access this publicly with that getter. So inside of here, I'll do a constructor. I'll say constructor, I'll say public, I'll say state equals state active. All right, so I'll go ahead and set the default state to active, right? So actually, let's do this. Let's do waiting. And then I'll create a function to activate it. And I'll say activate. And I'll say public state equals state dot active. So we can actually choose, we can choose this value out of this enum list and update the state to that value. All right. So whenever we call this function, it'll change the state to the active state. And let's get a function that checks to see if the state is active. We'll say function is active. And we'll say public view returns bool. All right, we'll say return state equal to state.active. So that's what we'll do inside here. We'll just check to see if the state currently is active. All right, so let's see if we have any errors. Looks good. I will compile this. All right, we'll go run, deploy. And all right, let's check the state. So is the state active? All right, no, it's false. So that's true. It's not active. It's in waiting. So let's actually check the state. So state is 0. So 0 corresponds to the first item in this list, 0, which is waiting. And I'll click activate. All right. So I actually call the activate function, which updates the state to active. Let's see if it's active. Yep, it's true. And let's check the state. So now the state is 2, which is 0, 1, 2. All right, so that's an idea of how you use enums. Let's look at the next concept that I want to show you. The next concept I want to show you is let's do structs. So structs are basically a way for you to define your own data structures inside Solidity. We'll do that like this. we'll say, we'll create a struct right here. We'll call it person. So struct person. And we'll give it some characteristics. We'll say string first name and string last name. Okay. So basically what's going on here is this allows us to basically model, our own sort of arbitrary data. I'm just going to model a person with this struct that's going to have a few attributes. It's going to have a first name attribute that's going to be a string and a last name attribute that's also going to be a string. And we can put these structs inside of like arrays and mappings and things like that. I'll show you that here in a minute inside this video. But for now, just know that we declare that we've defined this new data type person inside the smart contract with a struct that's going to have a first name and a last name. Okay, so let's actually create a function that allows us to instantiate a new person, create a new one, and we'll actually keep track of a bunch of these person structs inside of a people array. All right. So let's do that like this. Let's say, let's keep track of a bunch of different persons so that we can create new ones. We'll say person. This will be an array, public, people. All right. So let's see what's happening here. People is a state variable here, and it's public, so we can read it outside the smart contract. And it's an array here of these data type person, right? So we declare the data type first, which is person, which we defined here with struct. It's an array that contains these person structs. It's public, and it's stored with the people state variable. So we can add people to this array, or person structs to this array like this. So create a function. Say function add person. It's a string. This is a Solidity 5 update. Memory, or 0.5, sorry. First name. And then we'll say string, memory, last name. We'll say public. And we'll do this inside here. We'll say people. Push. So push is a function we can call in arrays to add a new item at to the array, and we'll push a new instance of this person struct. So we can create a new instance like this. We just call person, right? And we pass in these attributes. So we say first name. Oops, sorry. Name and last name. All right. And what we can do here is, well, yeah, we've added it. Let's go ahead and do it. So let's just compile this and run it. We'll deploy this. All right. So let's see what happens. So people, let's go ahead and add the person. Add person. Oops, sorry. Let's do the first name. So first name will be DAP. Last name will be university. We'll add person. Okay. Awesome. So that didn't give us any errors. Now, how do we read this person out of here? That's a good question. So we added this person to an array, but this function, whenever we call this person, this people function, it's not going to return the entire array of people. That's because this is we don't know the size of this array is in Solidity. And we have an array of unknown size. It's not going to return the entire array. So basically, we need to reference the person by ID. So whenever we get this function, it expects an argument, which is going to be the index of the person inside this array. So for example, we know we added one person in there. So we will add people. We'll say 0. All right, there you go. DAP University. So what happens if we reference, a person that doesn't exist? Say person, like 1. People. It's going to give us an error. It's an invalid opcode error. That's because there's no one in there at position 1. So how do we fix that problem? Let's keep track of that like this. So basically, we would keep an internal count of the people. We'd say something like this: uint 256 people count. Okay. And that's going to basically give us a counter cache that will increment every time a person's added. So we can say something like people count plus equals 1. All right. And we can do that after, I guess. All right, save that, deploy. And now we can, actually, let's make this public. Oops, sorry, it's before. Let's try it again. So now we can add the person, DAP University. Add person. And we can see people count is 1. So we would do 1 minus that. People. All right, DAP University. We do 1 minus that because it's a 0-based index, which means the first item, is at index 0, and the second one's at index 1, etc., etc. The next thing I want to show you is how to do a similar concept here, but model it a little differently. So instead of using an array, we're actually going to use a mapping. So what is a mapping? A mapping is basically like an associative array. So instead of having, just an array, and we know each index of the item in the array, we can actually associate it to a value. So that's like a hash table or a hash map or a hash. And other programming languages that you might be familiar with, where basically you can reference things by, a key value. It's key value pair. So instead of having people like this, instead of it being an array, I'm going to change it down here. I'm going to say this is going to be mapping. Mapping uint person. Okay. So uint is going to be the key, and the person is going to be a value. So this mapping is, like I said, an associative array that's going to take a key value pair. The key is going to be an unsigned integer. We'll treat this like an ID. So it'd be kind of like our database lookup, where we have an ID and then a record. So this is going to return kind of like a record, like a person record, or a person struct in this case. And it'll be public, and it'll be people. And it is kind of a fair comparison to compare this to a database, because, blockchain kind of is a big database, and these structs are, getting stored in storage on the blockchain with this mapping. All right, so person, string, first name, last name, and we'll do add person. So we'll need to modify this function. We'll still take the first name, we'll still take the last name, but we're going to put this in the mapping instead of the array. So I'm going to move this people count back up here. We're going to want to keep track of this, just like we did earlier, so we know how many people are in this mapping. But we'll add it to the mapping like this. We'll say people, people count. This will be our ID. So if it starts at 0, which it will, do this. All right, people count plus equals 1. That'll be the new ID of the person that's going to go in here. So this will be person number 1 the first time we add this. We'll say this is going to be a new person. And be we'll give this an ID. We'll say uint ID, okay? People count. And then we'll say first name. And then last name. All right, and we'll take this out. All right, let's see if that worked. Clear this out. Deploy the contract. So we'll do first name is DAP University. Add person. Okay, so let's see, people count is 1 now, and we'll go to people. This time it won't be based on the array index, it'll actually be on the ID, so we can actually reference person 1. All right, we'll do people 1. There we go, DAP University. So let me explain a couple more things about structs while we're here. We need to keep track of this people count because there's no way to know the size of this mapping in Solidity. Basically, any key that doesn't have a value set for it's going to turn a default value, which is going to be like an empty struct here. So if I do like, person, 10 or like 9999 people, it's just going to return default values. So what are the default values for the struct person? ID for uint is going to be 0. And then these blank strings for first name and last name. So that's why we need to have a person count. So if you were going to use this like as a data storage, and you wanted to like show all the people or all the persons in your people mapping in your app or something like that, reading from the smart contract, you want to know how many are actually in there, and you want to do that with a counter cache. So that way, if you wanted to basically like, the same thing with those variable size arrays. Like if you wanted to get all the items, you need to first make a call to find out how many there are. That's what you use the counter cache for. And then you basically create a loop to read out each one by one. So yeah, it can be kind of a pain, but that's sort of just the state of things and what you have to do. I'm going to go ahead and pick up where we left off in the last video. I'm going to use this, my contract that we built where we added a person struct to this mapping of people. So if you haven't seen that last video, go ahead and check that out. It's not necessary, but you can probably follow along with this video if you want to. What I'm going to do now is show you a little more about these modifiers like public and things like that. I think we talked about that in the first video, but I'm going to go just a little further. So what I can do is, show you another modifier, which is basically like internal. So that's different from public. Public is a function that can be called, on the public interface of the smart contract. You can see, the public functions listed here on the side. So I'll go ahead and create a private function, or an internal function, excuse me. I'll say function. We're just going to take this people count and wrap it in its own function to show you how that works. We'll say increment count. We'll just make this a function, and we can call it internal. That's a different modifier. We'll just take this people count, and we'll paste it inside of here. All right, and we'll just say increment count. Call that function, and we'll run it. See the smart contract, we'll add the person. We'll say dap university. And I'll click add person. And there we go. It incremented the count. You can see the people count has been changed. You can say Joe Blow. And the count's changed. So that's a way that you can, use other functions that are going to be internal. And we can see this increment count function isn't added to this list over here. It's not exposed to, things outside of the smart contract. External callers can't use it. So that's an example of, other, types of visibility of functions in Solidity. Let's talk about function modifiers. So we can add, more, words and terms to the end of this function to change how it behaves. And I'll show you an example. So we're going to create our own custom modifier actually inside of this smart contract so that only certain people can call this add person function. All right. So what I'm going to do is basically, make this smart contract have an owner or like an admin. And we're going to say that only the owner can call this add person function, and any other account connected to the network, whenever they try to, add a person, they won't be able to. And that'll show you how we can add an extra modifier to this function to make that happen. Basically, we'll just add a modifier that says that only the owner of this smart contract can do that. So first, we need to, well, actually, that'll just look like this. We'll say only owner. That's what the modifier will look like. Now, this only owner modifier doesn't exist yet, so let's go ahead and create it. All right, so we'll do that like this. First, we need to keep track of an owner. We'll say the owner is, address. I'm not sure if we talked about this in the data types video, but, an address is a data type inside of Solidity. Like an address that's on the network, an account. So this will be the address. We're just going to declare it here. We're not going to set it just yet. We can set it like this. We can do it inside the constructor. Well, actually, not something to do that just yet. So that will be the owner. We basically just create a modifier like this. We say modifier. Say only owner. It's like a function. And what we'll do inside of here is write the logic that makes sure that, whoever's, calling the smart contract is the owner. So that's what we're defining here. Only owner and only owner. So how do we do that? How do we say the person who's calling this function is the owner of this smart contract? Well, we're going to compare it to this owner right here. But how do we know who's calling the function? Well, Solidity has a global keyword called MSG, which basically stands for the function metadata that's passed in. And we're not actually going to pass in any metadata here. It's going to be implied. So basically, we have access to msg.sender. And this is basically a special thing inside of Solidity that tells us the account, this address, who called the function. And basically, we can just say, is this person the owner? We can just, compare equality of the person who's calling the function with this owner that we're going to store here in a second. All right. And if they're not, we actually want to throw an error. All right. So this is going to show you another concept in Solidity about error handling. So we can throw an error in Solidity, like, I think earlier we had some errors happen, like here's an error. We actually want to trigger an error if this person, is not the owner. We want to revert the transaction. And we can do that like this. We say require, msg.sender is equal to the owner. So basically anything inside of this require, if it evaluates to true, then this passes. If it evaluates to false, then this will throw an error. We basically are saying require that whatever you put inside of here is true. All right. And then after this, we can basically just do this. All right. And now our only owner modifier is complete. So basically now we have this modifier that's defined here, and we add it here. And basically we say if the person who is calling this function is the owner, then we can actually run this function, and if they're not, we're going to create a failure. We're going to revert the transaction, and also whoever's doing this, whatever, like this code won't run, so they won't pay this gas fee. All right, so now we need to set the owner, and I'm just going to do that inside of constructor. We'll use msg.sender as well. Say function constructor. And we'll just open this curly braces, and we'll say owner equals to msg.sender. Sorry, we don't need the function keyword here. And we also need to make this public. All right. So I'll save that. So whenever you deploy the smart contract, like this constructor gets run, and the msg.sender is actually the account that deploys the smart contract, and they're going to get set to this owner state variable. Right? It's address owner. And basically that same, address is the only person that's going to be able to call this add person function. All right. And if they, this code will run and we will add a person. And if we switch accounts to some other account over here, then it won't work. So let's just try that. I deploy this. We will, deploy with this account. So let's change to that account. We'll add the person. Actually, I don't know if it deployed that account or not. Let's try it again. So make sure on the first account, we'll deploy. All right. We'll add a person. We'll say DAP University. We'll add the person. All right, let's see here. All right, it worked. The people count is 1. Now we'll say, Joe Blow, and we'll change accounts to this one. And we'll try to call it again. We'll add a person, and we see it has failed, and the people count has not changed at all. So it worked. So we've kept track of the owner, and we say only the owner can do it. Now while we're here, I'm going to show you a little code formatting that I like to do sometimes. This is getting kind of long, and sometimes, if you're like me and you have a text editor with a whole bunch of panes open, I like to keep my columns kind of short sometimes, especially with Solidity, and it kind of makes it easier to maintain these functions when the arguments start getting long and you're using get and things like that. Sometimes I will just break these up like this. All right, and then I'll actually put the modifiers. If you have a bunch of modifiers, sometimes this makes it easier to read. And also when I'm writing my own Solidity source code, I only use 2 spaces. I don't use 4. But yeah, that's sometimes how I break these functions up. So I can see the function name and then the arguments. Then I can see the modifiers, and then I can actually see the code that gets executed inside of here. And it can make your smart contract kind of long, but it can be, sometimes this will catch you. If you have too many, if you have 3 visibility and modifiers on here, sometimes it can be kind of tricky. So I like doing this. All right. So next, I'm going to show you how to work with time in Solidity. Okay. So what we can do is basically compare time in Solidity. And instead of this saying only owner can do this, let's say that you can only call this function if a certain time has passed. So let's pretend like, this is a contract that is only open at a certain time. So we'll say instead of only owner, we'll say only while open. Only while open. All right. And this opening state is going to be determined by a time. So once we've passed a certain time in history in the future, then we'll let you call this function. If it's before that, we won't do it. So that's really useful if like you're building a crowd sale or something like that has an opening time, like an ICO smart contract, and you say, hey, we can only let you contribute Ether like after, the first of the month. Well, you just figure out what time that is and say, hey, if you make a contribution before then, we'll throw an error. So I'll say only while open, all right? And instead of requiring that MSG, that sender is the owner, right? We're actually going to just take this out. We're going to say, we're going to make sure that the current time is in the future, beyond a certain opening time. So let's do uint 256 opening time. All right. So how do we do this? Well, we need to set this opening time somehow. All right. So the opening time is actually expressed in seconds, inside Solidity, or these timestamps are expressed in seconds inside Solidity. And seconds of what? Well, it's epoch time, which if you're not familiar with that, it's a concept in computer science that's like the epoch is a specific time. I can't remember the actual date. It's like a date in the 60s or 70s or something like that. And basically, we just add seconds since that point in time in history. So this is the current epoch timestamp, is this many seconds since the epoch time. And I guess there's probably a link here where you can read more about that. Yeah, the Unix epoch clock. I'm sure you can get on Wikipedia and figure all that out, but basically, this is the current epoch time, and it's changing. So we use these seconds values. So this is like the current, epoch timestamp. We'll say this. All right. So this is how we could set this. And it's, uint 256 is going to store this big number of seconds since that timestamp. And that's going to be our opening time. And so how do we compare that to now? So how do you get now in Solidity? Well, there's no perfect way to do it, but the best way is to get the current block's timestamp. All right. So how do we do that? Well, just like MSG, there's a global variable in Solidity called block dot. And we can say block.timestamp. All right. And we can say, is the block.timestamp, is it greater than or equal to the opening time? All right. So basically, if it's after the opening time, we're going to let you call this function. And if it's not, then we won't. All right. So let's give this a try. I'm going to update this timestamp. Let's refresh it. Let's see. This is the current one. I'll paste this in here. So 15. I'm going to add 60 seconds, so a minute. So I'm going to deploy this, and it will be... it shouldn't work right now, so we can try to call add person. We'll try to add DAP University. Okay, we'll add person, and we'll see that it reverted. Okay. And now we can check the timestamp. We're not there yet, so I'll just pause the video and wait for this to pass 75. I think that's the actual time. Yeah, 75. All right. I'll pause the video. Pause the video, giving us plenty of time. We're past the timestamp. You can see it's 793, and we're at 775. So let's deploy it again. Or actually, let's not deploy it again. Let's just do Joe Blow, add a person, and it worked. So that's how you can use time in Solidity. You can get the current time and set a time value with seconds. And so that's what I'm going to call today, guys. I hope you all like this video. Let me know how you're enjoying these Solidity videos. Let me know if I've missed anything, or if there's something you want to learn, or if you're just not liking them, that's okay too. Just let me know down in the comment section below. Let's use the same My Contract example that we've been using throughout this tutorial series. And you don't necessarily have to have been following along with every video in this series. You can kind of just pick back up with this one probably. So yeah, let's go ahead and jump in and start programming. What I'm going to show you first is how to write a function that accepts Ether. So basically, how can we send Ether in when we call a function and do stuff with it? So I'll show you how to do that. First, we'll create a function called buy token. Say buy token. And this function is going to kind of emulate what happens in an ICO, like a crowd sale or a pre-sale or something like that on Ethereum, where you're buying ERC20 tokens. I'm not going to like code out an entire ERC20 token smart contract right here, or code out a crowd sale smart contract. I've got several other tutorials that show you how to code your own cryptocurrency on Ethereum with build an ERC20 token step by step and a real world crowd sale, things like that. So you can check out those other videos if you're interested. But what we're going to do is basically create this function called buy token that's going to simulate what happens. It's not going to do everything, but it'll at least give you an idea of how that works. So we'll call this buy token. And inside here, what we basically want to do is buy a token. And we also want to send Ether to the wallet. So what's going to happen is someone's going to call this function, and they're going to send Ether when they call this function. And when they do, we're going to issue them a token. And then the wallet is actually going to receive the Ether that they sent in when they call this function. So I'll show you how to do that. First, I'm going to create a way to track the tokens. And basically all this is going to do is track this person's balance. So we'll use a mapping for that. We'll say mapping. And again, if you didn't check out the other videos, the mapping is like an associative array where we have key value pairs. So we'll say address will be the key and the value will be an unsigned integer. All right, and this will be public. All right, this will give us a function for free that allows us to read this value, and we'll just call this balances. So what we'll do, and when we buy a token, we'll basically just say balances of whoever called this function. So if you'll remember from the last videos in this series, we get that value with msg.sender. This is the account that's calling this function. And we will just increment this count by 1. Now, this is not really fancy. We're basically just saying whenever you call this function, you're going to buy 1 token. We're not using a rate of redemption or anything like that. This is just to kind of show you how this works. This is not very sophisticated. But basically, that'll just increment your balance, inside this token contract by 1. Whenever we do that, we want to transfer funds that are sent in with this smart contract to a wallet. All right. So how do we do that? Well, first we keep track of a wallet. We'll just declare a state variable here. We'll say address wallet. And we want to send funds to this wallet. Okay. And we do that like this. And I'm actually going to show you something in a minute that's going to be a Solidity 0.5 update. So if you've been using previous version of Solidity, we have to make a change here. I'll go back to that in a minute. But anyways, let's transfer funds to this wallet. We'll do that like this. So we'll say wallet, transfer. And we want to transfer in the funds that are sent by this function. Transfer the funds that are sent in by this function to this wallet. So how do we do that? Well, how do we actually know what the value is that's getting sent in? Well, just like msg.sender, MSG has another property called value. So we can say msg.value. All right. And that's going to tell us exactly how much Ether or Whey is sent in by the person who's sending this function. So I'll show you how that works. So what that's going to do is take the Ether that's sent in with this function call and transfer it to this wallet right here. Now this is not complete. There's a lot of things that actually need to change in order for this to work properly. You can see these X's over here, these compiler errors. So the first thing we need to do is set a wallet. Let's do that inside a constructor. We'll do that whenever we deploy the smart contract. So we'll say constructor. We'll say address, wallet. We'll say public. And we'll say wallet is just equal to the wallet we pass in. All right, so we're still getting errors. Now let's see what they are. The first thing we need to do in order to make this function accept Ether, well, actually, first we need to make it public so that people can call it. We say public. All right. So now people will actually be able to call this function and send Ether in and stuff like that. And in order for this to accept Ether, we have to add another modifier here, which is payable. All right. And if we don't do that, this won't allow us to send Ether in with the transaction. So this is how we declare that this function will accept Ether, okay? Now here's a new Solidity update. It requires explicitness whenever you're declaring an address that can accept Ether inside of a smart contract. And we do that like this. We say address payable wallet, all right? And then likewise, we say address payable wallet whenever we pass this function into the constructor. All right, so that should be a working implementation of what we want to see. So let's deploy the smart contract and try it out. I will take one of these addresses, and we'll take the second address here in the list, and we'll use that as the wallet. We'll actually check its balance here in a second. So we'll deploy the smart contract. We need to pass in a wallet whenever we deploy. Just paste this in, click deploy. All right, looks like it was successful. Let's try to do the buy token function, okay? It's just going to buy one token for us. So we'll make sure we've got the first account in the list selected. We'll buy token. All right, looks like it was successful. Let's check the balance of this. Oops, I actually pasted in the wrong address. Pasted in the second address. So let's try the balance again. All right, it's 1. All right, now all that did was actually transfer, all that did was buy a token. It didn't actually transfer Ether to the wallet, and that's what we want to show. So in order to send Ether in and actually transfer funds to the wallet, we would do that like this. We'd change this to Ether. I'm going to send 1 Ether in with this transaction whenever we call the buy tokens function. We'll do that from this account, and we'll click buy token. All right, boom. So let's check the balance again. All right, the balance is 2. Now, let's see what happened. We can see that the Ether value decreased here from 99.9 to 98.9. It actually took Ether out of our wallet because we sent it in with the transaction. And we can see that the second account on the list, which I used as the wallet whenever we deployed, has been credited with that Ether. So our smart contract worked. It actually sent, the value that we sent in with this to that account. All right, so the next thing I want to show you is how you can create basically a fallback function in Solidity. I guess is what it's called. At least that's what I've seen it called. I'm not sure what the official name is. But basically, it's going to be like a default function that you can wrap this in so that whenever you just send Ether to the smart contract, it executes a function. And you'll see that a lot in ICOs where they have an address posted and they say, hey, send Ether to that smart contract, and it'll actually buy the tokens for you. Now, this is just a kind of pseudocode implementation, again, of a purchase function. A real ICO functionality would be much more complex than this, but you get the idea. So to do this fallback function, we'll do like this. We'll just say function, all right, and we'll say external payable, and we'll just wrap this with the buy token function. All right. So here's a new modifier I don't think we've used yet, which is external. So that's different from public because public can be called, inside of our smart contract as well as outside, but external can only be called outside. So we don't want to call this, inside the smart contract somehow. So now if we just compile this again and deploy, I'm going to paste the wallet in here, deploy. We'll see you have a new function just called fallback. And we can basically just do that like this. So we'll just send 1 Ether from account number 1, call the fallback, and it worked. We can see our account balance went down, this went up, and the balance of first account should be 1. Yep, it's 1. So now I want to show you events inside of Solidity. So what do we use events for? So events are a way for external consumers to kind of listen for things that happen on a smart contract. So basically, external consumers can subscribe to events on a smart contract and wait for something to happen. So what we'll do inside of this buy token function, we'll actually trigger an event that lets anyone connected to the blockchain really to know that a token has been purchased from the smart contract if they were to listen for it. So I'll create an event like this. Load up here. We'll say event purchase. And I'll just say, I'll break this line right here. Oops. I'll say address, buyer, and I'll say uint 256 amount. Okay. So that's how we declare an event, just like that. And inside of this function, whenever the token is purchased, we'll trigger it. And we trigger the event like this. We say emit purchase, and we pass in the buyer, and we pass in the amount. So the buyer in this case is msg.sender, the account that's calling this function. And the value in this case is just 1. Semicolon. All right, so there you go. Now, another thing you can do with these events, you can create an index like this, indexed, okay? And that will allow you to filter events that are only from certain buyers. So basically, like if you wanted to only listen to events from the smart contract that a certain person did, a certain account, or maybe even just you could subscribe based on a specific address. So I'll show you how that works. All right, let's compile this and run it. I'm going to take the wallet, paste it in here, deploy. All right, now we'll call the buy tokens function. We'll send in 1 ether. Oops. All right, it worked. Now, how do we know the event worked? So we can look inside of this transaction here, you can see the log. And we can see right here, here's the log. And inside this log, we have some messages. And this basically is the event. We can see the buyer listed here and the amount. See, the buyer was this address, and here's the amount. So what are events for, really? There's 2 kind of main use cases for events. Because of the asynchronous nature of the blockchain, if you're building an application that if you're building an application that talks to the smart contract, you might call a function like buy token. Like if you're writing a JavaScript application, you might call this function, and then your application would just know that you called this function, but you might want to actually wait for this to finish and execute, wait for this event to be emitted. So you can basically wait for that and subscribe to this event, and filter for only ones that are applicable to you. And whenever that happens, you can wait for that to happen, and then reload your application state whenever that event's been triggered. So that's one popular use case. Another use case is you can get the entire event stream from a smart contract like this. So you could basically see all of the purchase events because they're listed in these logs. They're actually listed in the transactions, that are contained in the blocks of the blockchain. And that's a way to see all the purchases that have ever happened inside a smart contract like this. I'll go ahead and use the smart contract that we were working on in the last video as the basis for this one. So in this video, we're going to be talking about how to use multiple smart contracts in the Solidity programming language. 2 different Ethereum smart contracts, one that will talk to the other. And I'll also show you how to write parent-child relationships with smart contracts. So we'll have, we'll talk about inheritance, a contract that inherits from another one. So I'm going to go ahead and clear out some of this code from the last video to kind of get it where we want it to be. The first thing I'll do is, let's see here. Basically what we'll do is we'll go ahead with this scenario where we're still going to buy a token, but instead of, keeping track of the balance inside this smart contract, we'll actually move it to a token contract to, kind of separate concerns a little bit. So actually, tell you what, let's go ahead and create the token smart contract like this. And again, this is going to be a really just basic, it's kind of almost like pseudocode example. It's not going to be a full ERC20 token, but this will just give you an idea of what's going to happen when 2 smart contracts call one another in a very simple example. So we'll say contract. ERC20 token. And again, if you want to see more, videos about ERC20 tokens, I've got plenty on my channel. So I say string name. So we're going to just have a state variable that keeps track of the name here. Let's actually make this public. And we'll do a mapping. We'll just basically move this balances mapping up here. We'll take it out of this contract. And we're going to extract this balances increment here and put it into its own function. So we'll just call this function mint. Say function mint. We'll make this public. And inside of here, we're just going to do this. We'll take this balances and increment it here, just like that. And also, we can rewrite this just to say plus plus, which will increment by 1. Refactor that a little bit, make it a little nicer, a little cleaner. All right. And now we should be able to clean up this a little bit, take these comments out. Let's see here. Let's actually simplify this. We'll take this purchase event out. We don't need all this. That was mostly to show you how events worked in the last video. I just want to simplify the code a little bit so that it's easier to follow along with. All right. So inside of here, we want to mint tokens inside of this contract. So you want to call the ERC20 token from this buy token function. So how do we do that? Well, we created this smart contract in the same file. So because this is in the same file, this contract knows that this contract is here before we compile it and deploy it. So in the source code, this one will know about this one. So we can basically be explicit and tell this contract that we want to mint tokens in this contract. So in order to do that, there's a couple things that we need. We need to know the address of this contract once it's deployed, because this will get deployed and then this will get deployed, and we'll have two separate addresses. And then my contract needs to know about the ERC20 token contract where it is, and then we'll basically just reference that smart contract with the address, and we'll basically get an instance of it, kind of, and then we'll just call the mint function on it. All right. So there's a two-step process. The first is we need this contract's address, and then we need to instantiate this contract. And then I guess really the third step is we call the mint function. So first, we'll get access to this token address. We'll just say address token. All right, we'll make that public. So we'll just say token is equal to token that we pass in. And we will keep track of it here. Say address token. All right, we can also make this public if we wanted to. So now that we have the address, we need to basically get a instance of it. So we can do that like this. Like I said, this contract source code knows about this ERC20 token here. So basically what I'll do is say, I'll create a new one. So I can say ERC20 token. All right, and we're going to basically instantiate it. And we do that by passing in the token address that we've kept track of here. So it can be explicit, which I think Solidity 0.5 requires us to be explicit. So I'll say address, and I'll say token. All right. So that will reference this ERC20 token that's actually deployed. It knows about this source code, and then it's going to get the deployed token from the blockchain like this. And now we can use this token to call the mint function. So I'll show you a couple ways of doing this. The first one is we can store this to a variable like this. When we create variables in Solidity, or whenever we declare them, we must specify the type first. So the type is going to be ERC20 token contract. And this is a local variable. It's not a state variable. So I'm going to prepend it with an underscore, just kind of a convention. Token. It's not necessary for Solidity, but I do this a lot. You'll see this, all over the place. And now we can mint the token like this. We just say token.mint. All right. So now we can call this buy token function from this smart contract, and it will, use this call the mint function from this smart contract. So let's check it out. All right, we'll run it. So first, we have to deploy this in 2 steps since there's 2 smart contracts in this file. We'll deploy the ERC20 token contract first. We'll deploy it. Oh, sorry. I'm actually going to use the JavaScript VM. We'll deploy it. All right. And now we can just copy the address of the smart contract that was deployed down here from the transaction receipt. We'll say contract address. And then now we'll go to my contract and deploy it. So it's asking for a wallet and a token address. Let's paste in the token address, the second argument. In the first argument, I'll just get the wallet. So I'll just copy the basically the second account from here. So we'll do this account. All right. And deploy. Okay. And now we'll call the buy token function. Boom. We can also see the token address here. And now we'll say, we'll take the balance of our current address that we're connected with to see if it worked. All right, so why is that? Why is it 0? Well, I'll show you why. Well, first, this was successful. The buy tokens function worked. It actually did call the mint function here. But it's confusing because our balance from the account that we did it with is wrong. So I'll show you what's right. All right. So let's go. I'm gonna let you guess as to why this might be wrong. Well, instead of leaving a suspense, it's got to do with msg.sender here. Okay. So this can be a real gotcha when you're programming in Solidity and you want to call, a smart contract function from another smart contract. So earlier when we built this, we call this mint function directly. Like if we go here and click mint, right? And now I click balance, it goes up by 1. But if we do it from here, we can click it again, buy token. Let me see it's working. But our balance doesn't increase at all. But if I do mint here, it does increase. That's because msg.sender in this case is the address of the contract that called the function, not who sent it. Okay? Now that's kind of tricky. So we can actually get the address of the person who sent the initial transaction. Instead of MSG sender, we also have access to tx.origin. All right, and that will actually mint functions for whoever initiated this transaction. So if we call mint function directly on the smart contract, it'll increment our balance. And if we call it from the smart contract, it'll also increment the balance of the person who called this buy token function. So that's a real gotcha when you're programming with multiple smart contracts in Solidity that I wanted you to know about. Now I'll show you how this works. So I'll deploy the token first. We'll deploy it. All right, and I'm going to deploy my contract next. Say my contract, and we'll paste in the address. Okay, it'll be the wallet address, and we'll also paste in the smart contract address like this. All right, we'll deploy it. Now, let's try to buy tokens again. We'll do a buy token. All right, it worked. So now let's go look at balances of this account we're connected to. Account 33C. This is account 33C. We'll do balance, and it's 1. And if we mint tokens here as well, it also increases. So that's how TX origin works. It's different from msg.sender. It's always the person who originated the transaction, even if a smart contract is calling the function. So I wanted y'all to know that because it definitely can be a gotcha whenever you are programming smart contracts that talk to one another. All right. So I'll show you one other thing before we move on. There's a shorthand here. So whenever we mint this token, we can do this. We don't have to store this token as a variable. We can just say ERC20 token, and then just call the mint function on it directly like this. And that would be the exact same thing. So I don't want to walk you through all that, but I just wanted to show you that that's also a nice, clean, shorthand, valid way of writing this in one line instead of two. Okay, so now I do want to talk about the next topic, which is how to inherit smart contracts. So inheritance, so having a parent and a child relationship. Now we'll create a token that inherits from this basic, ERC20 token to do two things. So we'll keep this functionality the same, and what we'll do is basically give this token, a second token down here. We'll give it its own characteristics. So we'll give it its own name, and we'll also override some of the minting functions to wire up some of our own behavior in our own sort of pseudo token that we're going to create. So I'll say my token. All right, so that's what this will be. And this my token will inherit from this one. And we do basic inheritance just like this. We just say is ERC20 token. So let's customize this token. I mean, the first thing we could do is basically override the name. We could say string public name. We could set it to something, default, like my token, right? And that would technically override this, right? That would be basic inheritance, because if we define it a second time, it would override whatever's in this parent class or parent contract. And that shows you how that works, but it doesn't really give us a whole lot of extra functionality. So let's show you how this works in a different way. So I'll set the name inside this parent contract like this. We'll say constructor. Let's say string memory name. Say public. And I'll say name equals name, right? So basically, we'll just have a constructor function that's run when this contract is deployed, and we'll take a name and we'll set it to the state variable here. So we can actually override this whenever we deploy our own smart contract like this. We can say, instead of just having the hard value, we can also inherit that. We do like this: constructor string memory. Let's see, name, and I can say ERC20 token name, and that'll pass the name in from this constructor along to this, all right? And let's say public. Let's say we also wanted our token to have a symbol. Just say string memory, symbol. Okay, and we'll just say symbol equals to symbol. And we'll say string public symbol. All right, so that's a way for us to accept our own, argument into our own constructor, but still take constructor parameters from the parent contract. And I'm going to break this up like this to make it a little easier to read. I do this a lot in my, production smart contracts. I break up the lines like this so it's easier to read. All right. So that's how you, override constructors like that. Now inside of here, let's override this mint function as well, okay? Let's basically add some extra behavior. We want to preserve this mint function. We still want to keep track of the balance, but we also want to just do some extra stuff. Let's keep track of the people who actually own the tokens. So first we'll keep an array of owners. We'll say address. This will be an array of addresses. Say public owners. All right. And then we'll keep a counter cache of the people who own the tokens. So say uint 256 owner count. All right. And now we will update these values in our own mint function. So we're going to create a mint function that basically preserves the functionality of this, but adds some additional behavior. So we say that is going to be function mint. So we're going to override it. Say public. Okay. So first thing we want to do is call this mint function so that this behavior is preserved. We just say super mint. All right. And now we say owner count plus plus. We say owners push msg.sender. Okay. And that is basically going to call the mint function, the parent contract, to update the balances. Then it'll increment the number of people who own the token right here, and it will add them to the array of owners. Okay? All right. So now let's just compile it and run it. And so when we do this, we don't have to deploy 2 smart contracts. All we have to do is deploy this one. So you can say ERC20 token. Let's see the string. Actually, let's do this. Let's do my token. So string name will be my token. And symbol will be MTK. Deploy. All right. So let's call the mint function. All right, it worked. So let's see the balances of the current address that we're connected with. We'll say balance is this. Okay, all right. We'll do the name, my token, and the owners of the first person in the list is our address and the symbol. Okay, all right. And we could also make this public if you want to read the owner count. All right, guys, so that's how you inherit smart contracts in Solidity. I'm going to be talking about 2 different topics in this video that are somewhat related. The first topic is libraries, how to use them in Solidity. And the second topic is math, how to do math in the Solidity programming language. And these are somewhat related because, we use libraries to manage math functions all the time in Solidity. It's a really common use case. So I figured I would just record both of those in the same video. So, what is a library if you're not familiar? Library is basically a way to organize code that can be reused in multiple places inside your project. So that's one of the main reasons we use libraries, essentially to dry code up. So if you're not familiar with dry, D-R-Y, that's an acronym for don't repeat yourself, right? So basically, if we have a function that we want to use in multiple smart contracts, we could define it inside of a library and then use that library to use that function. And that way, if that function ever changes, the change is absorbed by any place that we use it. So how do we declare a library in Solidity? Well, like this. First, we use the library keyword, say library. And I'm going to call this library just math. Okay. So in the earlier videos, I said that smart contracts are the main way that we organize code inside of Solidity. It's called a contract-oriented language, and that's true. But we also have libraries where we can define functions inside of here and store variables and things like that. And that's another way to organize code inside Solidity. But really, at the end of the day, a library belongs, inside of a smart contract so it can get called and used. Libraries don't have the full behavior of a smart contract. They don't really have storage in and of themselves. They don't, you can't inherit from a library, things like that. So it's not really like a smart contract. At the end of the day, it's meant to be used inside of a smart contract. So we can define a function inside a library like this. I'm going to create my own divide function. Say function divide. All right. I'll just leave this here for a second. So why would we want to use a divide function? Well, I'll show you. Let's create an example inside of my contract where we would, basically just do some math. First of all, we'll declare a value. We'll say uint 256. We'll say public value. We'll just store the value here. And now we'll actually store this value, but we'll compute it. So we'll say function, I'll say calculate. And we'll take a value, we'll say uint, we'll say value 1, we'll say uint value 2, we'll say public. And inside of here, we'll basically just set the value to whatever the calculated value is. We'll say value 1 divided by value 2. Now, this is a basic way to do division inside of Solidity. We just use this operator here. It's the division operator. So why might we want to use a library for this? Well, you might notice a problem. is value 2. What if value 2 is 0, right? There'd be a problem with this. We would get some sort of exception because, we can't divide by 0. And that's a really common use case for a library. Basically, we can write some code inside of here that prevents this divide by 0 error, and we can actually stop the function before that happens. So basically, we could do like this. We could define this function and say divide is equal to the input. Let's say uint 256. Let's just say A. Uint 256 B. We'll say internal pure returns uint 256, and we'll do the division inside of here. So say require that B is greater than 0. That's the first thing we'll do. We'll take the denominator and make sure the denominator is greater than 0 so that we don't divide by 0. Then we'll actually create a return value of C, which is C divided by B, or the numerator divided by the denominator, and we'll just return that value. Return C. Sorry, this is supposed to be A. So now we can actually use this divide instead of this divide here as a safer way to do division inside of Solidity. That's a really common use case for a library. So how do we do that? How do we take this function out of this library and use it inside this calculate function like this? Well, we can say math.divide and then just pass in value 1 and value 2. And we store the output to value, just like that. All right, now I'll erase this. All right, now let's try to run this code. So whenever we deploy this, I'm going to select my contract instead of math. And whenever this is compiled and deployed, it knows that my contract depends upon math, so it's already going to get compiled and deployed automatically. We don't have to deploy this first and then this. In the whole compilation process of this file, the math library, at least the part that gets used, is going to get compiled because it's dependent upon right here. So let's try this. First, we can see the value is 0, and we'll say value 1 is, say, 100, and value 2 is 10. All right. Okay, that was successful. We see the value is 10. Now what happens if we try to divide by 0, calculate, and we get an error, just as we expect. We can also do some other values just to make sure it works. Say 144 divided by 12 should also be 12. Yep. All right. So that's how you, that's a basic example of how you import a math function from a library. Now, there are a few other ways we can do this. Instead of having this library just at the top of a file here, we can actually move it to another file and import it inside of this file. So we can clean this up, and we're only looking at one, sort of unit at a time. We don't have to look at the smart contract. We don't have to look at this library. So I'll show you how to do that. We'll go over here to our browser, and we'll create a new file. We'll call this math.sol. All right. Now we'll just copy the math library from here. We'll actually just copy it with the Solidity programming language declaration, and we'll paste it in here. Save. Now we can require the file just like this. We say import. We use double quotes, math. All right, and notice I use the dot to indicate the current directory / then the file name, which is math.sol, followed by semicolon. All right, that'll do the same thing. So we can go back to here and deploy this. Say math. Go to my contract and deploy. And we'll see. Say 188 and 9. All right, there we go. That's doing integer division. That's why it's has no remainder. Okay. So that's how you import a library from another file in Solidity. Now I'll show you one more thing. I want to introduce you to a really common library, which is called Safe Math, which is put out by OpenZeppelin. You can go to that repository here if you want to read more about it. But basically, it implements a lot of helpful functions that I use a lot when developing smart contracts and doing math. They've, they've solved a lot of problems like guarding from overflow and things like that. And so I use this library a lot. So it's a really common use case for me. And I'm going to show you how to use that library inside of here because it works a little bit differently than how we implemented our math library. So I'm going to delete this file and create a new one, say safe math. And I'm just going to copy the code here from GitHub, click edit, and go to, not edit, I want to do raw. I'm just going to copy all that, go back to Remix and paste this in here. All right. Let's actually change the Solidity programming language version. Let's go 0.5.1. I think it should probably be up to date. Oops. Yep, looks good. All right. So let's save that. Go back to my contract. Instead of importing math, we'll do safe math. All right. And instead of, calling a library like this, we're going to do a different way. All right. And this is pretty cool. So we can take all these functions in here like multiply and divide and subtract and add. We can actually call them on unsigned integers directly. All right. And we do that like this. We can say using safe math for uint 256. All right. Now that's pretty cool. I'll show you what that does. Instead of doing this, we can basically say value 1, div, value 2. There you go. That's pretty slick. So let's try that. Go to my contract, we'll deploy. Click this. So value 1 will be 144. Value 2 is 12. All right, the value is 12. There we go. Say 133. 33 divided by 11. Yep. 100 divided by 10. There we go. Awesome. All right, so that's all I got for this video today, guys. Again, you can find all the code examples of this on my website over at dappuniversity.com/article/Solidity tutorial. I'll put a link to that down in the description below. And again, if you're serious about becoming a blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.
Any art concept as well. I'm going to take an example and let me jump over to Photoshop. Your very first process would most probably be creating a cool kind of NFT concept and then separating the elements in layers such as these. You can see that by separating them into layers such as the eye shine over here, you can kind of hide them and put them on. And it creates every time a different look and feel. For instance, you can have a small eye, you can have a cat's eye, you can have a different color eye. And by doing these things, you'll see that it kind of changes the image and the outcome of what you're busy creating. Now, this is the very same concept that we will be using for our program. Our program will be able to take all your layers that you've created, you split them up, you export them, and then you go and apply this to the Node program that I've written, and then you run it in order to create thousands of different artworks. The more layers that you have for your collections, the more possibilities and the more artworks you'll be able to create. I said this video is going to be a full explanation, and indeed it is. I'm going to show you your very first tip regarding Photoshop. If you have all your layers visibly selected by putting on this eye icon, you can simply go to File, Export, Layers to Files. Then go and browse and select a place and a destination to save this. I'm not going to put a prefix. I'm going to keep this as PNG. The layers is going to be only the visible ones, and I'm not going to trim the layers. That's very important. When I run this, you will see that it runs through my collection and exports each individual layer in its own file. This is very important because this is exactly what you'll need for the program to make use of it. This is way better than doing it manually. That's just an extra tip, and I hope you like that because it saved me a lot when I did not know this back in the day. So knowing this now, I always use this. So let's look at the next step after you have exported all of your layers. Once you have exported all of your layers, what you basically want to do is split them up into different folders. These folder names are very important. What I mean by that is if we refer back to OpenSea, your folder names would eventually, with my program, be the property names like this: nerd, purple shirt, coder, and so on. So, therefore, it is very important to have the folder names exactly how you would want it to appear on OpenSea. What you do with the folders are you split up the layers that basically goes to that folder, right? So for instance, the eyeballs inside the eyeball folder. For the eye color, I do the same, and so on. Once I have all my different layers split up in folders, I'm ready to go and I can now pull this into the program. Something that I should mention at this point is that if you open a layer and you give your layers each a name, like I said, spell them how you would like to see it on OpenSea, maybe with an underscore if there's a space in the name. But the most important thing is that there's a hashtag and then followed by a number. Keep this in mind. If your program breaks, it's usually because this hashtag and the number is not there. You will see that all the hashtag and numbers are hashtag 10. I'll talk about the rarity when we're in the program itself, but just make sure that all of your files have a hashtag with a number. I usually create them all as 10, and that way it's easier for me to work out rarities later on. Now go ahead and open Visual Studio Code. You can go and say open over there and open the folder that has all those programs in it that we've downloaded in the beginning. You can see that we have the Hashlips Art Engine over there, which is 1.0.6. So I'm going to open this one. Simply just click on this folder, double click on it to open it up. You'll see that it's going to ask you to trust it. This is Visual Studio. And then we can see our folder structure over there. Perfect. Let's quickly import our layers that we've now created in Photoshop, our collection, into this program. So the very first step that you'll need to do is pull in all your folders. So let's go to this layer folder over there. If you open it, you can see that there's already a bunch of layers in there. I'm just going to simply select all of those layers and delete them. Then I'm going to take all my layers and you are going to take your layers and drop it inside the layers folder. Make sure that it's in the layers folder and not outside of it or some other place. So you should have your layers folder with all your different layers, and inside of them you have your attributes, your items. And that's it. That's the very beginning. Keep in mind, like I said, maybe start off with a hashtag 10 or some solid number, because we will change it later on if we want to make some of these items more rare. Now, if you want to understand this program fully, you can go ahead and watch that purple series that I was talking about in the beginning. But to just get up and running and set up your collection, all you need to do is go here at the top where it says terminal. You have to say new terminal up there, and then you'll get a new terminal in your Visual Studio Code IDE. Once you have that, because you have installed Node in the beginning, you can now simply run npm install, like so. If you type npm install in your terminal and you click enter, it would start installing the dependencies for this project. Dependencies are programs and different libraries that we'll be making use of when we run this program for it to run successfully and build out your own collection. The dependencies might take a bit of time to install, but please remember you only have to install the dependencies once. So you only ever have to run npm install once to get this node modules folder in your project, and then you're good to go. After that, we'll just be running a single node index.js command every time we want to rebuild our collection. So give this some time to install, and then we'll continue going forward. Once the node packages have installed, you'll see something like this. It won't look exactly the same. For instance, this is my computer's name. That's a query pops up, so don't worry about this. Your name might be here for your computer, but if it's done installing, you'll see something like this. All right, perfect. So the next thing we need to do is have a look at make this run and work to test it out. Open this source directory and go to the config.js file. In this config.js file is the place where you will do little bits of changes, and this is the only place that you really need to change to build out your collection. The main place that you'll be changing is this layer configuration file. Each layer configuration exists of an object. If I close it over there with this little arrow, you can see that between these two curly braces, this is all of the object's content. So for each layer configuration, and you can have as many as you want, you have a grow edition to size, right? A grow edition size 2 basically. How many NFTs or artworks do you want to create? And what is the order layer? So in what order is this program going to generate these images? Okay. So for instance, this program will render a folder called background first, then an eyeball, then an eye color, iris, shine, and bottom and top lids. You have to make sure that in your layers folder that you have the corresponding, you don't have to have all these layers in this layer order, but if you include one of these folders, the spelling of this name, background, needs to be exactly the same as background. If it's in your case something else like mountain, it needs to be the same spelling and same mountain. All right. It's just very important because that's how the program picks up which one of these folders to grab next, if it makes sense. Okay. The other important thing here is to make sure that you organize these in the correct order, starting from the top to the bottom, taking in consideration that the first layer over here will be firstly laid down on the canvas, then the second and the third, and so on. Let me go and add my layers that I've imported. These ones are the default that comes with the program. I've got a bottom lid, I've got an eyeball that I want to render, the iris, the shine, the top lid, and the bottom lid are here. But I've got these extra ones, dark and gold. And the thing is, my top and bottom lid, if I look in the folder structures, I can see that they are purple. But if I look at the bottom lid gold, these ones are gold. Now, I'm first going to run this collection to show you how it looks when I run using this basic configuration. And then I'll adapt it to show you how you can make very unique kind of different races, if you want to put it like that. But in order for you to run a successful program, sometimes you need to have one of these layer configurations. One is enough. You can make a whole 10,000 collection if you really want to from one layer configuration if you have enough folders and files inside of those folders. I'm simply going to render 10 images. So every time you make a change file, please save this file in order for this program to pick up the new configuration. Next, what you want to do, and this is only after you have ran npm install, remember you have to install the dependencies, you can in the terminal now run the command node space index.js. When you run this command, and remember it is JS, not JX or something, it's index.js. It is this file over here, this one's name that we are basically going to run. If you press enter, you'll see that the program thinks a little bit for the first time, and then it will start off immediately creating the different layers. It's very cool to see, and if you get to this point where you can make it run for the first time, you're in a very good space to kind of create the rest of your collection successfully. Here you can see that we 2, 3, 4, 5 all the way to 10 images that's being created. You'll see that it has an edition size and a DNA. It's just to inform us which ones have been created. They are now located in this new build folder. They are separated by images and its corresponding JSON. I just briefly want to show you what the metadata standards are for creating. Why is it necessary? You can see that on marketplaces such as OpenSea, metadata is the information about a particular image, and this metadata can tell us things like the name, the rarity, the properties, and so forth. It looks something like this, and it's in the format of a JSON object. That's why when I say that it creates a JSON folder, each one of these images, for instance image 1, which looks pretty cool by the way, has a metadata.json1.json. This is that image's kind of information. This is automatically generated by the app for you, and you can see that it has attributes, and these are the attributes that show up on OpenSea. You notice that it's the same name as the folder and the file that it selected. For instance, eyeball was selected, and if we go to our layers, there's eyeball, the name, and white was selected. It actually takes off that hashtag for you. So don't worry about the hashtag and the number being included inside of your traits. Next, it has a few different things. It has DNA. The DNA is built up by the different kind of layers that it contains in this image, and it checks that against each other to ensure that there's a uniqueness. It has a name that shows up on OpenSea, a description that also shows up, an image which points to an image location. I will show you later in the series how we upload this to IPFS and how we have to replace this image location. Then we have edition size, date, and the attributes. That's about it for our JSON file. There is one more _JSON metadata file, and this file is simply the whole collection in one. But this is usually to keep as a backup. We generally don't use it. Now let's carry on creating our collection. I can close this folder off, and every time I run node space index.js, a new build folder will be created for us. I have got a problem, like I said. I want my images to sometimes have the golden lids, but I can't really put a golden lid just inside the layer configuration over there. Let's see what will happen if I do. Let me add the gold at the end here, meaning that it would use this layer. I'm going to save it, and let me recreate this collection by running node index.js in the terminal again. After it's created my images, I see that this looks pretty cool, but it's not the desired effect, because now I've got these gold lids and they're not fitting with the purple ones. So there is a little bit of a way around this. You can go ahead and keep it as it was and create a new layer configuration. If you want to do that, you can copy everything from that curly brace to there and then paste it right below it. Keep in mind there needs to be a trailing comma between each object. Then in this one I can decide to have the gold one over there, and I want the gold here, meaning that I want to run a collection which is purple, which has the purple lids, and one that has the golden lids. If I do that, I can try and run it, but there will be an issue. This is some of the issues that people find that they have. They might run the program typing node index.js. Then it says, okay, cool, creating, and then starts saying, it just breaks, it stops, right? So let's change this to 5. Let me show you, let me run it again. It doesn't create the 20 that I really want to. Now it creates 5 and then undefined. It means because this is grow edition size 2. the first one should be 10. And then this one, if I want another 10 to be rendered, I need to make this 20. And so on. If I had a third one and I really wanted this collection to be maybe out of 100, then I would make this last one 100, meaning that every time it grows, so it grows first, does 10, then it grows to the next 10, which is 20, and then from 20 it will grow to 100. And that's how you do it. I'm going to remove this last one. Save your file, 20 different NFTs. So you can see that they are busy being generated, and take note that it's running in a chronological order from number 1. I'll open the images. The first ones are pretty cool, and they are all the purple ones. But as soon as I go to 11, 12, 13, and so on, you can see that they are now using the golden lids. And that's some layer configuration that you can play around with and be creative. I also want to just quickly briefly talk about the layer order. If I simply remove this eyeball and put it maybe above everything, you'll see that if I run this collection right now, and if I check inside of these files, the eyeball's on the top. So it's very important files. Let me undo that action. One problem that I want to discuss with everyone is sometimes they find an error in the code down here. And that is usually, let's say I had a layer and I didn't put a hashtag. Just do that and it's black 1. And then if I run this collection, you'll see that there's this error popping up. This error explicitly says cannot read property split of undefined. It means that you have forgotten a hashtag in front of the number. Alright. And this number is to do with your rarity. Let's talk about rarities. How can we make some attributes more rare than others? Well, it's very easy. Let me open one folder and do it to one folder structure, and then you'll see what I mean. I'm going to choose the eyeball. Let's say that I have a golden eyeball, a purple, a red, and a white one. How the rarities work is it calculates, adds these all up together. So for instance, if I had, I'm just going to cancel that and let me actually create here. Let's work with the calculator and work out the rarities of this eyeball layer. If all of them are 10, I can simply go 10 plus 10 plus 10, right? You add them all up like that, plus 10, which is 40. Now, 40 is the overall weight that this eyeball will carry. But the golden one would be 10 out of 40, right? And the purple one, 10 out of 40. And then red, 10 out of 40, and so on. It means that these 4 layers carry exactly the same weight, meaning that the chance of them being selected is all the same. And that's why I suggest making everything 10, and then you can go and choose which ones are your rarest ones. Let's make some of these attributes a bit more rare. I want this gold one to be very rare, so I'm going to give it the attribute number or the rarity weight number of 2. I also consider the purple one to be quite rare, so I'm going to make this a 5. And let's say that the white one is pretty common, and I'm going to make it 20. Now all of these carry different weights. Let's bring up the calculator again and just work it out. So you're going to say 2 plus 5 plus 10 plus 20. The total weight that this layer carries is 37. So you can see that 2 out of 37 is quite low, meaning that the chance of the golden eyeball being selected is very slim, making it way more rare. Now, why is this important? Well, if you go to OpenSea and we look at the attribute, you see that OpenSea actually gives percentages to the attributes that it carries. And that's kind of how you can roughly work it out and add these attribute weights and the rarities to your collection. I also want to show you how you can work out the actual percentage of what the golden eyeball would be out of 37. So in order to work out the golden eyeball's weight out of 100%, you can simply say 2 divided by 37, which is the cumulative sum of all these layers of the eye. Then that is 0.05. And then you can multiply it by 100 to get a percentage out of 100, which is 5.4%. Now, that's how you kind of work out the rarities, keeping in mind that if you have different layer configurations where you include layers that's not existing in this layer configuration, your attribute might be a slight bit off because obviously you're not introducing all of the layers. This method only simply works super accurate if you have one layer configuration that contains all the layers, or if you have more than one layer configuration but they all carry the same attributes but are simply in different orders. Anyway, that being said, it is still a great way of working attributes to be. A simple guide that I usually do is I open something like, let's say, the eye color, and I simply say to myself that this one looks cool because it's the rare one, and if everything is 10, then I want to make this one too. The same goes for the one here at the orange and blue and purple. I want to have this one as 2, meaning that in itself, these 2 will be more rare than all of these. And there's a nice utility that you can use to work out kind of how rare these would be, but that's generally what I do. Now that you have worked out all your rare weights and you know how rare your collection will be, let me show you a cool trick how we can mix the collection up. Because you don't want to have a collection where all your elements, if we run this again, where all your elements are from 1 to 20 and they go in chronological order, meaning that they will go and run through these layer configurations, because that is kind of predictable on what the person would mint. The utilities that I'm talking about can be found in the utils folder over here. Each one has a very unique ability. For instance, if you've ran your collection and there are some files in your build folder like so, you can in the terminal run the following command. You can say node space utils like so /, meaning that we are pointing to this file, and then you can say rarity data.js. Once you have that, you can run it, and this will simply work out for each layer. You can see there's the bottomlet gold, what the chances were, and kind of what their percentages are out of 100%. Now, like I said, this doesn't accumulate to 100% because these gold layers aren't in this config. But if you select a layer such as the shine, you'll see that this all adds up to 100%, and this would be the true kind of chance of it occurring, because this is the actual occurrence that it's found. All right, and this is done for each one of these layers. That is a nice util to use. Another util is to create basically a preview collage. You can simply run the same command here at the bottom, utils /, but this time run create preview collage, and if you hit enter, you'll see that in your builds directory, a preview image is created for you of the existing images that was created. Keep in mind, these utils can only be called after you have created a collection. Seeing that I'm busy with utils, let me explain another utility. Let's say you have deleted for some reason the main _metadata file. Now, this will not work if you've deleted any of the other ones, only if you've deleted the main one, which I'm not sure what the use case might be, but it is there. What you can run is node / regenerate metadata file, and what it will do is it will calculate all of these for you. This can be handy if that's accidentally deleted. I don't know if you guys can hear the storm in the background, but in show business, the show must go on, right? So let's carry on and look at the final and most important utility function. It's called the update base URI. Now, it has to do with the metadata file. So if you look at all these metadata files, and imagine there are thousands of them now. We have created thousands of artworks. Well, you will see that each one has an image attribute, and it is appended with the edition number at the end .png. So you can see each one is different with the different edition number. Well, we need to sometimes change what this points to, because this needs to point to some kind of place on IPFS. How do we change all of these files? Well, there's a utility that we can use for that. How you use it is you go to the config.js file, and if you want to update the base URI, let's just do this, update without a /, okay? So we're going to put it in just like so. And then you save the file down here in your console. You can now run node space utils / update base URI. Once you do that, you'll notice that all of our JSON files now have this new update as the image base URI. Plus, it also has the basically the image files. You have to make sure in the config.js not to include that /, that trailing /, because it's automatically added once it's here in your JSON file. You cannot have two / here at the end. It is okay here at the front, but not at the end, okay? That is a mistake that a lot of people make that. So these are the utility features. They do absolutely nothing to your collection. They're just there to help you out. Now let's carry on and make this collection super cool. So carrying on with the collection, we need to make sure that our description here is replaced. Our description is the description that will show up on OpenSea. So make sure that you have replaced this line with your own description. I say here, remember to replace this. So let's just type something in. Let me say the coolest NFTs, right? The coolest NFTs, that's my description, but you can make a long description if you want to. I'm going to leave the base as is because we will update this once we upload to IPFS. Next, ensure all of your layer configurations and everything is running successfully. If you run node space index.js and your collection successfully like this, you know that you have done this correctly. So just play around until you get it right and that your collection runs successfully. If you get stuck, like I said, head over to the Discord community. All right. Now, like I mentioned, we have a problem. All of these ones are in chronological order, so this is the order that they will get minted in. But what if I want to mix a bit of the in a chronological order? Because what if you have alien races, zombie races, and so on? You might want them to be mixed up. You can do that. So in the config.js file, if you scroll a bit down, there's this attribute called shuffle layer configurations, and you can simply turn this to true. Once you do that and you save your file and you run the collection again by running node space index.js, you'll notice that it renders in a random format. So it first rendered 3, 20, 19, 17 down here and so on till it's done. Now you'll see that they pretty mixed up, and that's awesome. A way that you can add rarity into this is by saying, let's use a lower number, and I'm just using lower numbers to test. You can use as big as numbers as you want to. You can use 1,000 images that you want to output. But let me say I wanted to create 10 of these and only 2 golden ones. I'm going to then make this 12 because I want to add only 2 to the 10, and then I want to render it. This way, I even create rarities within the folders themselves, well, within the layer configurations themselves. So only 2 will be gold, and there they are. And that way, you can hype up a community by maybe making sure or telling them that there's a rare golden one or a rare special NFT in your collection. So carrying on through the config.js, like I said, there's a few extra things that you can play around with. One is the debug logs. If you turn this to true and you run your collection again, you simply get more information on your collection's rendering. This is sometimes useful if you just want to see everything working, look at the DNA, look at the metadata as it's being outputted. But it's generally not necessary to have this to true, so it's by default false. Your output size, you can change to whatever you want to have it. You can make a width if you want to have portrait, landscape. I always work in squares, but you can make it any size you want to. We can make a bit of a bigger images as well. Just remember to save the config.js file every time you make a change. So there I'm rendering a bit bigger images. So now you can see they will be bigger and higher quality. Next, a lot of people ask what this background is. Well, let's say I didn't have backgrounds at all, which is in my case simply, if I look at my layers, it's simply a black image. But let's say I didn't have them, so I removed them out of my layer configurations and I turn this background to true. This simply generates a random pastel color which you can set the brightness of by changing this parameter. So if that's set to true, it will be a random color as a base image. So if I open the images now, you can see that there's a blue background. This one is green, this one is blue, purple, green, and so on. Okay, orange, and it just carries on, yellow. All right, and that's basically what that attribute does. It's mainly for people who don't have background images and wants to just simply render them out like that. I don't really want this to render, but I'm going to leave it on as true anyway. It won't make a difference seeing that I have a background layer that covers it all before it starts. Then you can basically go and add extra metadata. If I had extra metadata to add, such as the artist, so I can write artist, and artist was Daniel, right? I can also say maybe I want a surname which is my surname. All right, let's just say for some reason I want this. I can save this file and then run node index.js again, and then when I look at my JSON files, these two attributes will be added on each one of these files. So keep in mind this will be added to each one of these files, and you have to have it in a format of a key and a value pair. The key is always generally good to have in lowercase. That is an exception that you can include. I don't really need that. Then we have the rarity delimiter. That is basically to do with, if you look at your layers, if you want a different delimiter, so if you don't want your rarity weight, you can change it over here. I generally leave it as a hashtag as well. Then the unique DNA tolerance, this is basically just set for your program to fail if you don't have enough layers to create enough images. For instance, if I have layers at all to complete a cool collection like so, and I save it and I run this program, it will soon run out of DNA exist, and if there's 1,000 DNA exists, like so, it will throw an error saying that you need more layers to grow to this 10 artworks. Okay, that's basically what this is. It's the tolerance of how many layers it can find and then replace, find and replace. And if there's 1,000 of these occurrences, it means that you probably don't have enough layers. Let me undo this action. Perfect. Then the preview is basically to do with the preview set that you've seen in the utility. So you don't really have to change these things at all. The only thing that you really need to worry about are the layer configurations. Like I said, make sure that you're happy with your collection, and then once you are happy, you can go ahead and render it. So the most important part is your description, your base URI, but that we change afterwards, and then your layer configurations, how many you want to create. So let's say I wanted to create a simple collection. I also have the dark lids over here, so I want to include that as well. So I'm going to start off by having one layer configuration, which is the normal one. Then I have got one with the dark lids. So I'm going to have the dark like so. And then I'm going to have the golden ones. So let's say I want a collection that consists out of 50. I'm going to grow the first collection to, let's say, maybe 25. 25 is fine. Then this one, I want to grow maybe to 45. And then lastly, I only want about 5 of the golden ones, so I need to make it 50 to end my collection at 50, meaning that there's 5 and 25, and then you minus 25 from this, which is 20 of these ones, and then 5 of the golden ones. And that's basically how you can set up layer configurations. But like I mentioned, most collections only consist of 1, and you can put this to maybe 5,000 images and render it. Okay, I'm going to undo that because I want these different configurations. I am happy with my collection, and I hope you guys came right with this program, because at this point we are ready to move on to the next step. All we need to do now is go to the terminal and for the last time place noindex.js. This is our final render, and at this point you can be proud of yourself because you've achieved finally rendering multiple different artworks from your layers. So once this is done, we're going to go ahead and upload it to IPFS. For our next step, we need to upload our NFTs to some place where it's hosted. Now, IPFS is a great hosting service which is decentralized. There are many ways of uploading data to IPFS, and using a service such as Pinata is a great tool to use. Now, you can go into pricing, and then you can see that it starts from a zero plan, which allows you up to 1 GB of storage, which is more than enough for my use case. But even if you have more, their plans are extremely cheap and it's there forever. So go and subscribe or just use the free plan, but once you have, you'll get to a dashboard looking like this. Here you can see that I've already uploaded the Nerdy Coder Clones collections, and they are on Pinata and on IPFS and will live forever. Now let's go ahead and upload the data that we've just created. If we look in our DApp that we have in the build folder, we've got all of our images in here, and we also have all of our JSON files. We cannot upload the JSON files at the moment, and I'll explain why. But you can go ahead and upload all the images so long, because we need a CID from Pinata to tell us the unique folder that it's going to live in. Let me explain. Now simply click on Upload Folder and click on the folder that we've created in our build file, Images. We want to upload the whole folder like so. Once you say Upload, you can give it a name. At this stage, it's good to call it the collection name that you're going to host it as. It's just basically a reference. It doesn't have to be anything fancy. But I'm just going to refer to this as eyes, and let's call it images, like so. So these are my eye images, and it's going to upload them. Once this is done uploading, what you want to do is copy the unique CID, and then we're going to update all the metadata. Let me wait for this to upload, and I'll show you what I'm talking about. And there we go. All of our images have now been uploaded, and this is our unique CID. It's identified by starting with a QM. And you can go and view this data if you click on that eye icon, and it will simply load the IPFS through a gateway. And the gateway that it's choosing is this Pinata Cloud IPFS. But this is actually where your data is located. So in theory, when you render your metadata from the contract, or when your contract returns metadata, in theory you want it to point to something like 1.png. And this will actually show us that image. And this is the metadata that we want to save. So that's why you need to copy this CID. If we briefly go and have a look at the metadata structure that OpenSea provides for us, you can see that they prefer that we give it a format such as this. It doesn't have the gateway in the front over here. For instance, here you can see this is the gateway, everything from here to there. But if we see OpenSea's documentation, they just want us to put this and then our CID to the folder, and then they will find it for us. They will basically show the NFT metadata to us. Well, the image in that case, because remember, we now only have uploaded our images. But let's go ahead and copy this, and I'll show you what I mean by changing the metadata. We now have to go back to our program. And remember what I said, go to your config.js and replace this update part. It still needs the IPFS : / and then that CID, okay, with no / at the end. Once you have this, save your file, go down, and please do not run node index.js at this point. What you want to run is node utils update base URI. Once you've done that, like I said, it updates all the JSON files to have these extensions. So now you can see if I copy everything here to there, it includes the /5 because it's now pointing to number 5. So we can verify that by replacing everything from here to the QM. If we run this, we can see that we get a different image, and that's what we want. So now that we have that, go back to Pinata and then click on upload again, upload folder, select a folder, but this time we're going to select all the metadata, so the JSON, like so. Click on update or upload, and then you'll see it needs a new name. So this time we're also going to say I, but how about we say metadata? Now this will take quick. It's just a few files, and once all of those files are on, now we actually do have the CID that we are going to link to the contract later on. It will pop up here once it's uploaded, so I'm just going to maybe hit refresh and let's see. But basically we have completed our first part. Now there we go, there's the metadata. So in essence, if we look at the documentation again, OpenSea wants us to return this metadata for it. And how do we achieve that? Well, because we have the metadata, we can now click on this icon, and then once it's loaded through the gateway, let's look at number 30. If we look at number 30, well, we have to say 30.json. If we look at number 30.json, we can see this is the metadata. And indeed, there is our IPFS link like OpenSea wants us to point to the image. Even though the JSON is its own IPFS link, this points to the image alone. And that's all you need to do. Now, a lot of the NFT projects have hidden images. How do we accommodate for that? Well, that's pretty simple. What do I mean by saying hidden? Well, a lot of NFT projects kind of reveal the images only after the pre-sale or some kind of sale has ended, and that's when you can reveal the images, the real metadata, and that kind of creates some kind of excitement. How can we achieve that as well? Well, we have our real metadata and images up already, so now it's time to kind of emulate one that's hidden. So what you can do, maybe open up the Minter that we were busy with, the build folder. Let's go and copy a JSON file, anyone will be good, and we need an image. Now, I do have an image over there. It's called hidden, so I'm just going to drop this in there as well. And I'm going to make a folder for each one. I'm going to say this is going to be the hidden image. And I'm also going to say, yeah, hidden is probably a good name for this. So this is the hidden metadata. All right. Now you can drop your hidden image. It looks like this inside the hidden image folder. And then for our JSON, I'm just going to rename this as hidden as well. Okay. And then drop that in our hidden metadata file. Now I'm going to open the hidden.json file, and I'm going to get rid of all these attributes. It doesn't need these attributes. So I'm going to remove that, and I'm going to remove the date, the edition, the image I'm going to leave, the description I can leave, right? And the DNA can go. So I only need really these attributes. We also don't need the compiler. So this is all that we really need. Here I'm going to write this image is hidden, right? And then we are going to change this once we know what that image URL is. So I'm just going to save this for now. I'm going to keep this file open, okay? Then let's go to Pinata. I keep on saying Pinata, Pinata. I don't know how to say it. Is it Pinata, Pinata, Pinata? Perfect. Go ahead and click Upload, Folder, select. And now the folder that we want to select is this hidden image folder. Say upload, and this time I'm going to say I_hidden_image. Okay. Going to upload it like that. And then once this is uploaded, once this has refreshed, I'll be able to copy that CID. Make sure it's the hidden image that you've uploaded, CID. So then I can go back and populate this. But this time, I need to say hidden.png. And to test this out, you first copy this. Okay, everything from the queue to that part. You copy this, and you go back and you click on this eye icon, and you go and replace everything. Once you have the gateway here, just replace it and call it. And there you can see we do get that image. So our metadata is pointing to the correct endpoint. So save this metadata file. Now you can go back to Pinata and upload another folder. This time it's going to be our hidden metadata folder. So it's going to be hidden metadata. We're going to call it I, hidden, and then metadata. And once that is done, we are all set up and ready to rock. We've got a few uploads. We've got the metadata and their corresponding images. And that's all we need. And now we can have a look at the next step in the process. I want to show you what you can do if you have made a mistake. So let's say you are testing your hidden metadata JSON, and for some reason you go there and you see that you have your URI/hidden.json, right? And you see that everything is perfect, but the name is still that. You don't want it to be #1. Well, there's a simple way that you can fix this. You can simply go ahead and click on More, and you can delete the file. Now, deleting that file will remove it, and if it hasn't been on long enough and pinned, it won't be shared to all the different nodes. So that's perfectly fine. So we can go back to where we want to change that. We can make an update, and we can just say this is the purple eyes, right? Let's do it like this. The purple eye. Save that. Go and do the same process again. And because this CID is the same for the hidden image, you can simply just upload that folder again. This is something people didn't understand, and when they made mistakes, they panicked and they didn't know what to do. You can just simply follow the same step. All right, I'm going to upload this again. And then once we have that hidden metadata, we can go and view it again and then append it with the hidden.json, and we can see it's now fixed. That's just something I wanted you to test, and it's also a good idea to always test the endpoints before you upload them to the contract. Now for the next part. In this part, we will focus on deploying the contract to the blockchain. It's very simple to do, and all you have to do is open up Visual Studio Code again, Then say open and find the place where you have downloaded the Hashtabs NFT contract. Open this folder, and in this folder you'll see there's another folder called contract, and the contract that we are going to be focusing on is the NFT, the simple NFT _flat. Now the flat part means that all the dependencies have been imported into this big contract. The actual contract that we are going to work with is here at the very bottom. But there's also a copy of it over here. You'll see that it's a simple contract that has a few parameters that we are going to play around with, and then it has a minting function which only takes in one parameter that allows you to mint how many NFTs you specify. At the end of it all, you can then also withdraw the ether after a lot of people have minted, set up a bunch of parameter changes with the only owner modifier selected, and there's a bunch of stuff that you can do with this. It's a very simple smart contract, but it does have the revealed functionality in it. Let me show you how you can make use of this contract and where you can deploy it. Now, there are numerous ways of deploying smart contracts, but a simple and effective way is using Remix, which is an online Solidity compiler, and by using MetaMask, you can deploy to test networks and main networks easily. The first thing that you want to do is select the NFT, the simple NFT _flat.sol. Copy all the contents in this file. After you have copied it, you can go to your browser and type in remix.ethereum.org. Once you're on Remix, you'll see that this is the starting screen. What you can go ahead and do is click on this plus icon over there, and let's call it the I, right? I'm just going to call it I. This is my workspace. Remix gives us these three files, which really are only starter files. It is mini smart contracts that they give to us as examples. And you see if you click on them, it starts creating artifacts. Just go ahead and remove everything. So after you've removed everything, you can just close all these folders and your contract should be empty. Next, right click and create a new file. This file is going to be our final NFT. So I'm going to call it I. I'm just going to call this I, right? There might be numerous I's out there. So maybe let me call it purple I. By convention, it's good to start with a capital letter and use Pascal case for creating the smart contract name. So purple I, where purple is capitalized and I is capitalized too. This is now our smart contract file. What we can do now is paste all of the content that we have copied from our contract. You'll see that a lot of artifacts get created. This is because all the dependencies have now been created in this one single file. Everything is in here. If you scroll to the very bottom, you'll see that starting from line, let me just go a bit up, starting from line 1, 2, 3, 5 is our smart contract. It's just called NFT. This is the very first thing that we are going to change. So if you are not used to Remix yet, maybe go and watch other tutorials where I'm working with Remix, where I have much more extensive explanations on Remix as a whole. I'm just going to show you the brief explanation of how to change the necessary things to have a successful collection launch. Go ahead and make the necessary changes. Starting with the name, I think we can change the name of the contract to Purple Eye, and it's also good convention to call the contract the same as what it's called in the file. So I'm going to stick with Purple Eye. Then in this section over here, these variables, this is kind of mostly where you need to update and customize this NFT contract to your needs. For instance, I do not have to touch the base URI, this base extension really, and the cost I do need to change. So cost is basically how much it's going to be for someone to mint one of your NFTs. Now, Keep in mind that we will be deploying on Polygon and Ethereum. So we would probably change the cost because the value of these two currencies are very different. But Ether will stay the same. Ether is simply a nicer way of appending a million zeros to convert Ether to Wei, okay? But Ether basically just makes it a nice readable way for us to write how much Ether this is going to be. I'm going to say that my eyes are going to be 0.0241. So I'm going to make that the price in Ether. And if I deploy on Polygon, which we will do, it's going to probably be a little bit higher. I'll probably make it like 5 Polygon, but we'll get there. So I'm going to leave this at 0.02, and we have minted 50 NFTs. If we go back to Pinata, we can see that in our metadata, if we go and open this eye, we have only 50 NFTs that's listed in here. They're not listed in order, but there's about 50 of them. So obviously, I want to keep my collection to 50. So this is the max supply, which I'll change to 50. Now, if you have a big collection, like obviously 50 is a quite small collection, this max mint amount is the maximum amount that a person can mint per session. For instance, if they call the mint function, they can mint up to 20 NFTs if it's left at 20. But seeing that I only have a max supply of 50, I'm going to say people can mint a maximum of 2. That sounds reasonable. Now, this paused variable determines if your contract is paused. If a contract is paused, not the owner or anyone else can mint. But if someone has already minted, they can freely still use the contract, send the NFTs around because it's their NFT. It simply just pauses the minting functionality. Usually you would start off by having pause set to true. And the reason for that is because you might want to deploy your contract and only set it to true once you have maybe made the announcement that everyone can start minting. So maybe a good idea is to set this to true from the start. Then, should it be revealed? Now, revealed should be false because we want to first display our hidden image, and then later on, once the collection is sold out, we will then reveal all of our NFTs to the world. Okay, and then we have the not revealed URI, which stays like that. That's all we have to change. So once these changes have been made, you should see this green tick here on the Solidity compiler section. By the way, how Solidity works is it has a file system where all your files lives, a Solidity compiler section which has all the compiler details. A good rule of thumb for me is always to put on enable optimization over here. Then we also get the deploy and run transaction section. All right, perfect. But let's go quickly to the Solidity compiler section. Something that you need to make sure of is this pragma line. Just make sure that your Solidity compiler is in between these two specified versions of the compiler, and indeed it is. It also will select it automatically. If your contract doesn't compile yet, if it doesn't do it automatically, you can tick on the automatic compile, and it will do it every time there's a change in your smart contract. Once you are happy with all your parameters that you've set up, go to the deploy and run transaction section. You can find it here on this Ethereum looking icon. The environments that Remix provides us is in-browser blockchains. These are the virtual machines. These are great for testing. So if you want to test these smart contracts, you just select one of these, and then you go ahead and do exactly the same. And this won't deploy to a real blockchain. Instead, it will deploy to the browser blockchain. But seeing that this is how to deploy on the testnet and then onto the main network, we have to follow the injected Web3 provider one, like this one, okay? So make sure that you are on the injected Web3. Now, this is where you need to pay attention. Currently, it says that you are on the main 1 network. This is the Ethereum main network. If you try and deploy now your smart contract, it's going to try and deploy on the real main network. So, in order to avoid that, go to your MetaMask and go and switch the network over here on your RPC. If you click here and let's select a different network, now the Rinkeby and the Gurley and all these other networks are test networks. Let's select the Rinkeby network. If we've selected the Rinkeby network, you can see that I've got some test ether in here. You can get test ether from a faucet. There's numerous videos on that. But I can now be sure that I'm on the Rinkeby test network and also see that over here it says Rinkeby network 4, which is great. When I deploy to the Rinkeby test network, this will actually deploy onto the Ethereum network, and we can test it on the test OpenSea, which is perfect for our use case because we want to do that to test that everything is functioning before we deploy on the main network, which is network number 1. On a side note, a lot of people have asked me how can they deploy this smart contract on Polygon. Well, that's very simple. Again, you'll go to MetaMask and select which network you want to deploy it to. I do not have the Polygon test network, but I do have the Polygon main network here. All you have to do to get the Polygon main network on your MetaMask is Google RPC Polygon main network, and it will give you the details to set up this RPC. But once you're on that, you'll see that the custom network ID is 137. Keep this in mind because I'll show you this later on in the video when we create the dApp. Anyway, let's get going and let's actually deploy on the Rinkeby test network. So I'm going to go to MetaMask. I'm going to go to Rinkeby test network, and you'll need some test ether for this. If you don't have test ether yet, you can simply test the stuff out on the virtual JavaScript virtual machine, but then it won't show up on OpenSea because it's not really on a hosted test network like Rinkeby is. So let's go and test this out. What you can do is you can go down on the deploy section. You don't really have to change any of these. You have to make sure that you have some test ether in there. And then you can go and select your smart contract. So make sure that in this contract section, you have selected your smart contract. If you select anything else, you'll be deploying a different smart contract. These are all the dependencies that our one has. Once you have done that, you'll see there's a deploy section where we now have to fill in a bunch of details for us to deploy this. So, to make it easy to fill in all these details, you can click on this drop-down arrow. You'll see that it gives us a list of things to fill in. I've just placed a lot of T's in there. But the first variable is the name, and you can see that in our constructor function. By the way, a constructor is a function that only runs once, and once the contract is deployed, it will never run again. So on startup, we pass it a name, a symbol, an initial base URI, and the initial not revealed URI. All right. How do we get these details, and how do we actually fill these in? Well, let's think of a cool name for our contract. We want to call this the purple eye, right? So we're going to call this purple eye. Our symbol is going to be PE. And this is just an abbreviation of purple eye. Then we need the initial base URI. Now, we need to go back to Pinata. And I also want to show you that on OpenSea's metadata standards, remember what they said, they want the format like this. So, you can go ahead and first type in IPFS : //. I'm going to simply copy this because at this point, we don't want to make mistakes. Even though this is the test network, we need to act as if it's the real one. So go and paste in IPFS : //. Okay, then go to Pinata. Once we're in Pinata, this URL is the actual metadata, the real metadata URL. So I'm going to click on I_metadata. This is not the hidden one. Open it up. And then once I'm here, I need to basically copy all of this. But this is now where there's an important thing to remember. You need to have a / when you deploy the smart contract over there. So at the end, add your /. Please remember that. Add the /. I'm going to say it again, add the / because 99.9% everyone forgets that. So add the / at the end and then copy everything up to the QM. Then yours might look different, obviously. Then go back to Remix. And then after this IPFS : // you paste what you've just copied. So your URI would look something like this. I'm going to go back to where we were, and I'm just going to paste it in there. So your IPFS will look, your URL that you put in there will look exactly like this. So make sure that it looks like this. Obviously your CID would be different, but the format should stay the same. Let's go back into Remix. Now we need to provide it the actual hidden URI metadata. So back to Pinata, and let's go hidden metadata. Click on the eye icon, and let's do exactly the same. So I'm going to wait for it to load, and while I'm doing that, I'm going to head back to the OpenSea documentation. Make sure that I copy the IPFS : // The only reason why I'm copying it always is to make sure that I don't make mistakes. You don't want to make mistakes. Of course, you can update it using the update functions that I've placed in the smart contract, but it's unnecessary to use them after a smart contract has been deployed. But it can be rectified. Anyway, let's go and see if this has loaded up. So there it is. I'm going to copy everything from the QM, but before I do that, I need to put a / and this time say hidden.json, like so. I need to now copy everything from hidden.json because this, from everything from the end, hidden.json included, up until the QM, this is only for the hidden metadata. So you're going to paste it after the IPFS : // You're going to paste it there, and it has to have all of that data in there, including the / hidden.json. The top one doesn't have that, it just has the /. I hope that is very clear. All right. Next, what you need to do, and this is super important. I cannot stress how important this is, this next step. Before you forget, go and click on this little button, and this is after you filled in the details exactly as you are going to deploy this contract. Before you click on Transact, you click on this little icon which copies the bytecode. Now you can go back to Visual Studio, maybe create a new folder and call this Info. I'm going to create a folder and call it Info, and then I'm going to create two files. I'm going to create a polygon.txt, and I'm also going to create a new file, and I'm just going to call it ethereum.txt. I don't think txt works on Mac, so I'm just going to call it Ethereum, and I'm going to rename this to just that. So it can just be a text file. But seeing that this is the Ethereum test network, right? Because these are test networks, so maybe it's a good idea to append test because it's not the main one. I'm going to put this there. I'm going to paste everything that I've just copied. Now, once you've saved this, I think when you close the file and open it again, it would have rearranged all the bytecode for you, like so. Just have this saved, because this is needed when you need to verify your contract. Okay, perfect. Let's now go back to the browser where Remix is waiting and ready for us to deploy. Once you've copied that, You can now freely press transact, make sure that you are on the Rinkeby test network. You can verify that, like I said, on MetaMask here at the top, as well as that you have some test ether. This is not real Ethereum. This is, you can get this from a faucet. There's a lot of videos on that, like I said. Once you are sure everything is correct, you can hit transact on this button. It's going to ask you to do a transaction. And this is emulating what will happen if you deploy on the real main network. So just hit confirm. And just a side note, please review the code before you deploy your own smart contracts. And then you can see after the contract has been mined on the blockchain, you'll see it pop up here at the bottom. You can expand this, and at this point it's a very good idea to kind of look at all these functions that the smart contract provides. There are a lot of smart contract features and functions, but the main one is this mint feature. I can now go ahead and, as the owner, because I'm on the owner's address over here, I can now go ahead and try and mint. The function will not work if I try and mint one. Why? If I say transact, it says this transaction might fail. And the reason for that is because our smart contract is still paused. You can check the status of your smart contract by clicking on some of these blue buttons. You can see that our base extension is JSON, our cost is that much in way, and then we can also see the max supply. We can see the max mint amount at each given time, the name, the not revealed URI, which is the hidden one. We can also see who's the owner of the smart contract, if it's paused or not, and indeed it is. And then you can see if it's revealed or not. It's still false, and you can also see the symbol. These blue buttons are basically call functions, so they don't cost any Ethereum or gas. They do cost a little bit of gas, but you don't pay it. But it's basically just reading from the smart contract. As we can see, we have a paused contract. So how do we unpause it? Well, there is a actual function that we need to use, and this is now a transaction, a send function, where we need to transact. So in this pause function, you can now open up your contract. So let's say pause is now going to be false. If I type false and I click on pause, it's going to ask us to do a MetaMask confirmation. And once I do, it's going to mint on the blockchain saying that we need to change the status from paused to false. If I now try and transact and I click transact, you can see that it's trying to mint. It's going to tell me the gas that it wants me to use. I'm going to confirm it. And then it will actually mint one on my address that I have specified over here. After the transaction is successful, let's just wait for it over there. We can also keep track of it if we go to MetaMask and see there is the mint and it's being minted. Keep in mind that this is all happening on the test network, but it is really on the test network, and I'll show you now that it shows up on OpenSea. We've got a successful mint. So now I can see if I click on total supply on the call functions that it's 1. I can go ahead and actually try and mint on someone else's address as well. Let me see if I have an account that has more test ether. This one also has some test Ethereum. So I can go ahead and connect it, and this will change. And then I can also go and try and mint one over here. So instead of trying to mint 1, I'm going to try and mint 3, just to show you that because we've set our maximum mint amount to 2, if I try and transact, it's going to tell me it's going to fail. This won't happen in the real world. It will fail. But Remix is nice enough to let us know. Try and mint 2 at a time. I can transact, and it says the gas estimation error occurred because it can't really estimate how much gas it's going to need to actually complete a successful mint. And that's these days a problem, that you need to kind of specify the amount of gas that you need to put through, but also have the correct parameters. So what are the reasons why this would fail? Well, if you see here, it requires, if a person is not the owner, that they need to pay for it. And we know that we need to give it some way or Ethereum, right, into the smart contract to mint one NFT. And one NFT costs us 0.02 Ethereum. So how much way is that? Well, we can go down and see the cost in way over there. So I'm going to copy this cost. I'm going to go up and put it here in the value parameter. Once I've done that, this is for one NFT. So I will be able to mint one, but not two. So I need to kind of up the value to maybe 4, just so that I can mint 2. So once I've done this, I can say transact, and there you see it's now going and making a transaction, sending 0.04. If I confirm this, it would start minting my NFT. Now that we have successfully minted another 2, we can go and double check it on the total supply. It should now be 3. So if you click on total supply, it should be 3. You can also take the address that you've now used to mint these and place it in functions such as the wallet of the owner. And if we do that, so let's go and get this address that we minted with. If we do that, we can see that this owner now owns the ID number 2 and 3. We can also add whichever token ID we want to, and we can get returned our token URI. This is the URI that OpenSea uses to go and grab the metadata. And here you can see it's still hidden because our contract is not revealed yet. I'm sorry for the thunder in the back, but it's beautiful. I love the nature, so we're just going to keep on going with the tutorial. I hope you guys can still clearly hear me. Anyway, we also got some interesting functions on our smart contract, such as the token of owner by index. This is an array of the token owner's personal index. So if we set index 0 of what the owner of this contract owns is number 2, and indeed it is. That's the ID because it starts at 0. If we were to put the owner's address and put 0, it would be 1 because that's their array, right? Then we have token by index. So if we query token index by 0, this should be 1. If we do 1, it should be 2. This is just how it works. It runs 1 ahead because we start minting from 1. Then we also have this function which is to do with the standards of the contract and the owner of the token ID. So if I say who's the owner of token ID 3, then I can see that it's this address that we've minted it from. And there are numerous of cool features that you can play around with. We can also check the balance, and you can see the balance is 2 of this address and so forth. Then some of the more complex features of this contract, but very cool, is you can actually set a new cost, a new base URI, a new base extension. You can safe transfer your NFT to someone else. Then you can also reveal the smart contract by just clicking on it. And a very dangerous button is the renounce ownership. Do not click on that if you do not really want to give the ownership away. Then you have this pause that we have tried, and obviously the mint and approve. Approval basically just approves someone else or another contract in order for them to interact with that NFT. And that's usually why you see a lot of approvals when you interact with OpenSea. Lastly, we get the withdraw button. Now, as you know, we have sent some ether to this contract when we minted with this last person. Go and try and call withdraw, but let's stay on this person's address and see what happens. It's going to fail, and the reason for that is because we are not on the original owner's account. Let me switch back to the original owner and then call this. Before I call this, I want to verify how much ether I have in my account, and this is 9.51. If I click withdraw, it's going to kick off a transaction, and once it's successful, we should see the total 9.51 change, and indeed it did, and I withdrew all the funds from this contract that people have paid to mint, right? And you can call this over and over and over again. Something very important to do at this stage is to, at the top here, copy your contract address by clicking on that copy button. Head over back to our Visual Studio, and because we have this file that we've created, let's add a few spaces and put our contract address in there for our test contract. This is the contract address that we can find on the test network scanner, right? This is just information you want to keep, and I'll show you the reasons why in a second. But if we go back, you now see that this is your control panel to work with your smart contract that's live on the actual blockchain. Although this is the Rinkeby test network, we can still see that this is live and it's interacting with the smart contract that's existing on this blockchain. Now, in order to see our work, we can head over to OpenSea. Well, not the real OpenSea. The real OpenSea will only show your artworks in your collection if you have deployed to the network with ID 1, with a real main network. And therefore, because we have deployed on the Rinkeby test network, not the top one here, the main network, which will cost us real Ethereum, we can still test it on OpenSea, but we have to go to the test net. So we have to type in test network. So you also will see OpenSea will actually kind of suggest it over here. So I'm just going to click on it over there. And the test network URL looks like this. So once we're on the test network, we can go ahead and go to our profile like normal, and we will actually see, big reveal, there's actually the Purple Eye collection is live. Now, because you own this collection, you can actually go to this collection yourself, and on the Purple Eye collection, you can click on it, and you'll see there should be 3 items, because remember, I minted one, and then on another address, I minted another 2. So there they are, and they're not revealed yet. And you can go and edit your collection. If you want to put a new image over there and a background image, you can click on the edit button at the top, edit your collection, and you can go and fill in all these details. Something important is that you can set the percentage of your royalty fee here. So you can maybe set it to 2.5. And then you set a wallet address that you want this to be paid to. Now that's all, and you can hit submit and update. But because this is on the test network, I feel there's no need of doing this. Simply we want to test our smart contracts, and then once we're happy, you deploy to the proper network. If you are happy with your smart contract and it's working fine, you will then go the step further and go and deploy it on the real main network. But we haven't stopped testing our smart contracts. Let's say our sale has ended and we want to reveal the smart contract. We want to reveal these images. Well, let's click on the collection and just have it open like this. Let's go back to the Remix control panel, and if you haven't closed this yet, you can still work with it on your browser. You can keep this open for as long as you want. I will show you a way, however, to get this back if you accidentally close down Remix. Alright, so next we can also see that if we click on this reveal button, making sure that we are on the owner's account, we can say confirm, and once we have done this, it will take a transaction, and once the transaction is complete, then our collection will be revealed on OpenSea. Let's wait for this transaction to finish. We can see that it might take a few seconds. There it is, it completed, reveal. And if we go back to OpenSea now and we refresh this page, we can see that if we go down below, it's not refreshed the metadata yet. And if that happens, all you need to do is go onto your collection and click on refresh metadata up here. This tells OpenSea that there's new metadata that it needs to pull in, and it will go and do so, and then once you get back to this image, it will actually show up. If you have bigger collections, it's better to go and call OpenSea. Otherwise, you can just tell the community to hit refresh metadata. That's why this button is there. Users can also freeze their metadata, and do whatever they want to. But let's refresh and see if it actually pulled in. We can see that it's not there yet. We can, however, go to Remix, and inside of this function, or on this function token URI, if we call it again, I'm not going to change the parameters. This hidden should change to the proper URI, and indeed it does. So we can expect this to work. We can also just verify and test this by copying what is being returned and pasting it in our Pinata test case that we've used. So we can see if we call this, there's our metadata. So OpenSea will update this as soon as you have clicked refresh. Let's give it a second or so. While we are waiting for this to update the metadata and for them to reveal the NFT data, I'm just going to hit refresh again. And on this one over there, also maybe going to hit refresh metadata. It says this item is queued and will update in a minute or so. Once we are waiting for, while we are waiting basically, let me just go back to Remix and show you what you have to change to deploy this on the main network. You basically have to change nothing. All you'll need to do is change your MetaMask and where it's pointing to. So once you're happy with everything, you have tested it, you can simply go to the Ethereum main network like so, make sure you have some Ethereum in there, and then once you have these already filled in, if you change something in the contract, it's going to go away. You need to redo this and you need to recopy everything like I showed you. But if we hit transact, it's going to say that this is going to be the cost. And if I say confirm, it's going to say this is going to cost me $414 plus the gas. So then you can hit confirm. There's no funds in this account, so I can't do this. But I will show you how I can deploy on the Polygon network. So let me go and show you how I can deploy on the Polygon network and actually follow the verification steps as well. Now, let's just double check on OpenSea. Maybe they've updated it. So, I have to be on the Rinkeby test network though. Let's go Rinkeby. Perfect. Now you can see that the metadata actually has updated. And how can I see that? Well, it now says #1, which is the actual name of this NFT. We can also see that it says the coolest NFTs, meaning that it is pulling in the right metadata. It's just not refreshing the image. So that might take some time, but give it some time for the metadata to pull it in. If you are really stressed about it, you can always verify it. Like I said, you can always go ahead and test it out. So if you want to go to your Remix again and you want to say owner of token URI, you can go and duplicate all of this up until the QM, go and find that Pinata link, just try it out like so. And then you can basically double check and make sure that this says IPFS : and then you simply replace that here at the top, like so. Once you've done that, the image shows up, and how lucky are we? This is actually a golden one. You are quite assured that this will update, okay? So just give OpenSea its time to do that. Now, we can also see that this one still says purple Ike, and this one says #2, #1, and this one still needs to, update the metadata. But let's go ahead and deploy on Polygon, because a lot of people have asked me, how do I deploy on the real Polygon network as well? Just so by the way, as soon as I went back to OpenSea, it's now pulled in the images as well. And now you can see that they are revealed. And how cool is that? So let's get going. Let's do the Polygon version this time. So all you need to do is go back to Remix, okay? And we can actually now get rid of this smart contract. But this is not the flow that I usually follow. I never get rid of a smart contract before I verify it. But seeing that this is on the test network, I really do not care about this smart contract. I usually do the following steps only for the mainnet contract. Okay, so this is the real deal. This is where we either deploy to Polygon or Ethereum, and each one will work. And the reason why I say that is because I just proved that I deployed on the Rinkeby test network for Ethereum. I'm not going to deploy to the real Ethereum network. That is very expensive to just make a tutorial on, and I don't want to put messy content on that network, right? But Polygon is affordable enough, and I can really dive into doing it on the real network and test it out and actually show you guys how to do it properly on Polygon and Ethereum. But all you have to do, and the only change you need to do, both for Ethereum mainnet and Polygon mainnet, is simply go to your MetaMask. Go and make sure that you're on the network that you want to deploy to. So if it's Ethereum, you'll select Ethereum. You'll go and make sure all these details are correct, the correct contract. All these things are in there as it should be. You copy the encoded bytecode and you transact. And then you go and confirm, and you pay the gas fees and everything that you want to deploy for. This is quite high. But anyway, that's how you deploy on the Polygon mainnet, on the Ethereum mainnet, sorry. When we get to the Polygon mainnet, I have already set up my RPC on MetaMask, which means it's just pointing to the main network. So I'm going to switch to the Polygon main network, and once I am sure everything is fine, you see, it's exactly the same process. You copy the bytecode, like I said, this is for real, so we're going to copy the bytecode first. We're going to go and do our best practice of pasting this somewhere so we keep track of it. Remember, we did the same with our test network, but this is now the Polygon one. So if we go back, we can go ahead and make sure we are happy with everything. I do have to mention that 0.02 Polygon or Matic is quite cheap, but I'm going to just keep it like that. Usually when you work with Polygon, you can make this in the 1, 2, 3, 4, 5, 6. It's not Ether, but I'm going to leave it like that because as soon as you change the smart contract now, you'll have to retype in all these details. But go ahead and make sure you configure it to your needs. So now that I click on transact, I will get the pop-up and I'm going to be saying confirm. Now what happens is exactly the same process that happened when we were deploying to the test network on Ethereum. But now this is actually doing the transaction on the real main network of Polygon. And you'll see it pop up on the real mainnet, and we can go to the real OpenSea, and I'm going to really reveal it. So let's wait for this to finish. In the meantime, when this transaction is finished and it comes in here, or if it gets finished and you find it on the scanner, you need to copy that address and also follow the best practices where we can actually then copy the address and put it in our file that we are saving all of our details to. I'm going to go ahead and speed this transaction up. Okay, it wasn't necessary. It's done. Means that it shows up here at the bottom. There's the address. I'm going to copy it immediately, the address, and going to Visual Studio and just going to make a few spaces and paste it. This is now our main network's address, and you can actually scan this and it will be live there. So the next thing that I need to do is I can go back over to my remix. So the next thing that I need to do is just open it and make sure everything is fine. Maybe I want to mint one. So what I'm going to do is I'm going to unpause my contract. So I'm going to say this should not be paused because I want to actually, I want to interact with my smart contract. So let's kick that off so long so that the contract starts running and it's done. And I want to mint a few. So I'm going to actually mint 5 for myself. And it says gas is not going to work. Why is that? Let's see why. Is it still paused? So let me go and see if it's paused. It's not paused, so I don't know why it would do that. So let me just quickly check. Oh, because we cannot mint more than 2 at a time. Fine. So let's mint 2. So I'm going to mint 2. It's going to pop up MetaMask, and I'm minting 2. And this is how you can do it from your little control panel, so to speak. Okay? Now, the other stuff that we need to now go and copy, which is very important for the smart contract, and I'll show you in a second, is the ABI of this contract, because this is what we'll use when we create the dApp. Okay, it looks like our transaction is successful. If we look at the MetaMask over there, it's gone through. So that is pretty cool. So the next stuff that you need to copy is the ABI. So what you can do is go to the Solidity compiler, make sure that you have the exact same smart contract that you use to deploy your contract in here. And then down here where it says contract, go and select your contract. Once you've done that, you can go ahead and copy the ABI. Okay. Then go back to Visual Studio, and I'm going to make a bunch of spaces and paste the ABI. So I'm just pasting in all the information that I need, right? I'm keeping track of everything, and I'm going to show you how useful this is later on. I'm going to make another, basically another file. So in the info, I'm going to say create new file, and I'm going to say Polygon contract. And this is going to be the Polygon contract that I used. Basically everything in here. So I'm going to press Command A to select the whole contract, copy it, go back and paste it in here. The reason why I do that is for if we lose the ability to actually salvage our remix. When I do that, you'll see that there's a way that I can re-upload this contract onto our remix platform, meaning that I'll have access to this beautiful control panel again. Otherwise, I will have to make use of the Polygon scans methods to kind of execute everything on there. But I can only use Polygon scan, for instance, Polygon scan over here, and Etherscan, if you have deployed this to the Etherscan or to the Ethereum network, if the smart contract is verified. How do we verify a smart contract? Well, at this point, this is why we have copied all this information. Let's go ahead and actually verify the real smart contract that we have just made for the Polygon network. All right. Here we have all the details. We have all the ABI constructor functions. We've got our ABI contract functions over here, the JSON format. And then also we have our contract address. So go ahead and copy the contract address that you have saved. Go back to your browser and go and search for it. You're going to basically search for this now either on Etherscan, on Polygon, or Polygon Scan, based on which blockchain you have deployed to. Now, I can see that here's my smart contract, and here is the Purple Eye PE smart contract, and there's already 2 minted, right? And 1 address owning it, because we just minted 2. So I can see that there's 2 mints. How cool is that? Your smart contract is live, and it's pretty cool. So technically, if I now go to OpenSea, let me go to OpenSea and check it out. So if I go to my profile, I should see that there's 2 new items in here, which are these eyes. So how cool is that? It is pretty cool. Now, I noticed that they are on the Polygon network over there, but I'm not seeing the actual images. But I do see that it says Purple IV2, Purple IV2. And that is because like someone actually have created this before. So if we search for Purple Eye, there's actually a collection that exists that's called Purple Eye. I didn't know that. But now I've also got a collection, but it's V2. So that was an accident. But yeah, if there's a contract with the exact same name, it will show up like that. Now, I don't see the image yet, and I think it's just because OpenSea is a bit slow with this. So if I maybe refresh the metadata, I do know it is pulling in metadata. And the reason why I know this is because it says purple eye there, and in the description, remember, we typed in this image is hidden. So it is pulling it in. I think it just takes a bit of time for it to, fully populate because it's a new NFT or something like that. But we can go ahead and test it. Like I said, if you want to always go and test and make sure everything is fine, just go and query that token URI. So maybe we can query number 1. We can see that this is the JSON. And again, we can just go and replace it in there. Once we have it, we can see our image is located at this endpoint. So we can then replace that. And if we hit enter, there's our image. So OpenSea just takes a little bit of a while. It also did this just now on the test network, so nothing to be worried about. All right, so that's what we have for our purple eye now. And I'm also going to just go in here. I'm going to try and refresh that metadata just so that if we come back here, that this will already be showing. So, all right, we will have to wait for that to reload. While we wait for that, like I said, we basically have our contract now set up in place. Now, the important part here is to verify the contract for us to, on a later stage, either interact with it directly on Polygon Scan or Etherscan. Like I said, this is a contract that can be deployed to both networks. You can see that we have a read and a write, but there is no ABI and someone needs to verify the source code. Because you are the owner, it's very advisable that you do it. So we're going to click on verify our source code. And this process is very simple. So let's fill in the details to verify. What we can do is make sure that this is our smart contract address. So we can verify that by going to the details that we've copied, and indeed it is. So the next thing is we need to select a compiler. To find that out, we can go back to Remix, go to our compiler section, and see that we used 0.8.7. So when we go back to Polygon Scan, we can select, well, first we need to select a single file because we didn't use multiple files, we used a single file. And then we select our compiler, which was 0.8.7. And then lastly here it says if there was a license. To find out the license, again, you can go to Remix and scroll all the way to the top of the contract and go and find our license, which is a MIT license. So we can just say this is MIT. And then we hit continue. After that, Polygon Scan is now going to ask us a few more questions. And the first question is going to ask us, was this optimized? And yes, we did turn on optimization. Remember when I said turn on enable optimization over here? That's the only thing it refers to basically. Then what we can do is we need to paste our entire file in here. Now I already told you to go and copy your contract. You can either copy it again from Remix or copy it from your contract that you've saved it now as your info files. Let's go back. Let's paste the contract in here. Lastly, it's going to ask you for this ABI, encoded ABI, constructor arguments. This is only needed if you passed in constructor arguments when you deploy a contract. And indeed, we did, because we filled in all this information. That's why it was very crucial to copy this. If you haven't done that, it's very difficult to go and verify it afterwards. Remove everything in this file, then go to Visual Studio Code, go to this Polygon file that we have we have copied and pasted, and then go and check this last bit of the bytecode, right? And select everything up until the last trailing 0. So your bytecode might look a bit different, but you'll see that it all looks kind of the same with a bunch of zeros. So you'll see that there's a line of zero, line of zero, line of zero, and then there is the last line of zero here at the top. You can see it ends at the 2 and then it starts with 0 and it has a long trailing 0 piece. Take everything from that 0 all the way to the last 0. Copy this and then head over back to Polygon Scan, paste it in there and say that you're not a bot. And once they have verified you're not a bot, you can click on verify and publish, and it should go through on the very first try. A lot of people are struggling with that, and the reason for that is because they didn't copy the ABI encoded data when they deployed the smart contract. So this should take a few seconds, and then our smart contract should be verified. Let's see. Perfect. So it says successful. Everything worked out. There's our smart contract. There's all the bytecode, and it's looking good. So from now on, we can basically go back to our smart contract. And by the way, we should be able to search for it. Let me just go back. We should be able to search for it here in the search bar. So if we type in purple eye, there we go. That is our smart contract. So you can even search for it like that. But that being said, if we now click on the contract over there, you'll see that it's verified, meaning that we can actually query everything in here. And this is very good, because now technically we do not even need Remix. But that being said, there's a bunch of stuff we can query, but we can also write. So when you read contract and write contract, reading and writing are two different concepts. Where I told you about reading a contract is the free kind of functions of the contract calls, where writing actually takes some gas that you need to provide. It's the same concept as looking at these orange buttons as writing plus the red one, and the blue ones as the reading. Okay, so you can also withdraw from your smart contract when you are doing this from Remix or from Polygon Scan or Ether Scan. What you do is you can go to the right contract and you need to just verify and log in with your MetaMask wallet. So let it just load. You can see it asks you to connect over there through Web3. So I'm going to connect. Then you can go down and alter everything in your smart contract. You can reveal, you can pause the smart contract, everything you want to that you are able to do in Remix, but this is only after you have verified your contract. And that's why it's very important to follow the steps. But let's say you want to withdraw. Now this was very confusing for a lot of people. This withdraw method all of a sudden has this field, right? And it's strange because on Remix, it doesn't. It is just a withdraw. Well, on Polygon Scan, that field is basically the value field. And that's why it's there. So please, if you withdraw, do not put a value in there. You will only be sending money to your smart contract. So if you want to call the withdraw, put a 0 because you don't need to send money. You're just withdrawing because you are the owner. And you can simply call it. All right, and that's all how it works. Basically, from Polygon Scan or Ether Scan, the verification steps are the same. The way you call smart contracts are the same. Everything is the same. And there you have it. Now you are done, and you have a successful contract on the blockchain, which is verified too. Let me quickly show you some nuances and tips and tricks with Remix. Let's say you got back to Remix and for some reason your contract was gone. You closed the browser, you don't know what to do. Don't panic. All you need to do is head to the file where your smart contract was saved, go and copy that, go back to your browser, paste it in there, wait for it to get a green tick over here on the left hand side, then go to the deploy and run transaction section. Make sure that you are on the environment injected Web3 and that your MetaMask is pointing on the same network that that contract was deployed to. Next, go back to Visual Studio or wherever you have saved your contract address if you've lost it, and you can copy that, go back to your browser, and then you need to paste it in here, address, right? Do not go and deploy this. You need to also make sure that you're on the right contract. So make sure that you're on Purple Eye contract. Even though this looks tempting to go and enter these details again, do not do that, because all you'll be doing is deploying another instance of your contract on the blockchain, and that you don't want. You want to interact with the same instance if you want to do it through Remix. Otherwise, you can just carry on interacting with your smart contract on Polygon Scan or Etherscan if it was Ethereum. Okay, but that being said, if I click Add Address, you can see that I've got the address back. And how magical is that? Now, if I click on Total Supply, it should be 2, because it is 2, and it is reading from the right contract. Just so by the way, it took about 10 minutes for OpenSea to realize our metadata is there, and the 2 images are now live and you can see them. Let me go and show you how you can now reveal the metadata from Polygon Scan or Etherscan. Like I said, you click on contract, you connect your wallet, and once you are connected and go to the right, you can just say reveal. Once you do it from here, it is just the same as if you were to do it in Remix. And that's why this is a cool thing to know, so that you don't always have to depend on Remix, because everything can be done from Polygon or Etherscan. Let's wait for that transaction to finish, and then we're going to just refresh the metadata. I'm going to maybe speed this transaction up a little bit so it happens a bit quicker. As we can see, the reveal is successful. So now let's go back to OpenSea, and then once users are on their NFT, they can just hit refresh metadata, like I said. Let's go back to the collection. Let's hit refresh on the other one. And if you want to do this in bulk, I think you can contact OpenSea and just tell them to refresh all your metadata for the whole collection. But that being said, as soon as one is refreshed, I think it triggers something in OpenSea that tells it to go and automatically refresh all the other ones. If we refresh this page now, or maybe give it a minute or so, you'll start seeing that the actual names get populated. For instance, we still have Purple Eye over there and Purple Eye over there. If we open the NFT, it should start saying maybe this is #1, and the description should change along with the image, and it would have properties. So let's give that a second. I'm not going to wait for too long, because I want to actually show you the next part and the final part, and that is actually hooking this contract up that is now live on the blockchain, again, Polygon or Ethereum, to the minting dApp. For the third and final step, you have now downloaded in the previous tutorials, remember the Hashlips minting dApp, this one. So go ahead onto your Visual Studio Code and double click on that folder. You will now see that it has a React.js-like structure, and it's very simple to start this up. All you need to do is start a new terminal. So click on terminal here at the top, say new, so that you have a terminal down here. And we follow the same process as we did with the creation part. So we first have to run npm install. So type that in the terminal and hit enter. This will install all the dependencies that we need to run the dApp, and we only have to make a few different variations, changes inside the config.js or JSON file. And then once we have changed the config file, it should automatically update to our minting dApp. And I'll show you how you can customize this to your needs, and then you can simply go and publish this on a shared hosted service. You can host it on GitHub Pages. It is simply a web page. Let me show you how easy it is to actually run this application. Now that you have installed all the dependencies, all you have to do is run npm run start at the bottom of your terminal. Once you do that, it's going to start up an application and most probably open up a localhost server on your browser. This is very cool because this is how you get to test it out before you actually need to build it. So let it run. It's busy running at the background now. It's just opened up on localhost port 3000, which means it's running locally on your machine. You can just check the progress by going back to Visual Studio, and you see that the server is busy starting up. Once the server is up and running, it's local, so it can just be viewed on your local machine here. So what you will need to do is, after you are happy with your changes, and I can see that it's now running. So if we go in here, you can see the local dApp running on your machine. But basically, after you're happy, we're going to do a build, and I'm going to upload it to a shared hosted service. Let's see how we can customize it. But let's first talk about what is happening over here. So firstly, this is a dApp that you can reuse. And there's a few nuances that you need to know about configuring this dApp, but once you are used to it, you will be able to make multiple projects using this dApp. What you can do is it will be connected to your smart contract, and it will have your details, and everything is customizable. If you click on Connect, you'll see that there's buttons popping up where users can actually decide to mint more than one NFT. And if they go and mint, it will actually go and try and mint 4 NFTs. How do we customize it to our needs? Let's take a look. So the place where you want to go and customize this dApp is mostly in the public folder. There is, however, a small exception for what I did. I made the minting limit 2, so I might need to go and change something in the source folder, but I'll show you how to do that as well. So let's take a look at the files that you can quickly replace to create your own minting dApp. You can open the public folder, and you'll notice there's a config file in here. Inside the config file, there's your images. Now, you can go into your images, and you can see that there's a background, a GIF, and a logo. Now, I've already prepared those files in here where I have a GIF, I've got a background, and I've got a logo. Now, all you need to do is you basically take those images and place it inside of that images file or folder. So you go and replace it, and once it's replaced, you can simply go back to your dApp, and you can see that my logo is updated. There's a new background at the back, and I've got this cool GIF of this eye. So these eyes look freaking cool. It actually looks creepy, but anyway, you get the idea. We can go back, and after you've replaced your images, we can have a look at the theme. So in the theme.file.css, I've made it so that you can choose your colors. Now you'll notice that there's a primary, secondary, and accent color. The primary color is the color that's most visible on the screen, but also it has a primary text. For a good design, always choose a contrasting color for your primary text, or your secondary text, or your accent text. For example, if I were to select this purple, I can see here at the top that white text works best. If I go lighter, darker text starts working better. If I drag it around, you can see there at the top. But I'm going to choose purple, maybe that purple, and then I'm going to leave my white or my primary text as white. Next, what goes good with purple? Well, if you look at color schemes, yellow generally goes good with purple, but I'm going to make it blue rather, like this blue. I like this cyan kind of blue. I can see that a darker color works with that, so I'm going to try and make a darker color over there. And this accent is usually the box. Now, maybe the box we can leave as white with some black text. Let's see just by doing these few layer configuration changes, how different the dApp starts looking. This is pretty cool, but it's not hooked up to our smart contract yet. So the only thing that you will need to do to hook this up to your actual smart contract, and keep in mind this is for Polygon and Ethereum, both will work, you just have to configure the settings. Go back to Visual Studio and click on the config.json file. You'll see that it requires a few different fields that you need to update. So basically the smart contract over here is simple. So we can go to Polygon scan. Let's go and copy that. We go back to Visual Studio Code. We're going to paste it in there. If you want the scanner link, you can simply just call maybe this. And let's just click on the contract address itself to get a scan link. So I'm going to copy that. I'm going to paste that as my scan link. Then I have a network. Now I want you to notice something. If I change this to Ethereum and I change that to ETH, because that's the symbol, and I change that to 1, I want you to see what happens to the dApp when I save it. So I'm going to save this dApp and then I need to jump back to it. There we go. So this dApp now is configured to work with Ethereum. You can see that it's charging ETH and it's also saying connect to the Ethereum mainnet. If I say connect, it's going to say change network to Ethereum. So I actually have to go and make that change in my MetaMask because this is very cool. It's automatically updating and realizing that we need to connect to the Ethereum network. So that's just what I wanted to mention over there. But seeing that we are working with a Polygon smart contract now, that's why I'm going to leave it as Polygon. So Polygon's main network is 137, Matic is the symbol, and then also Polygon is just the name that I'm going to use. We're going to change this name now to be Purple Eyes, but let's put a space. So Purple Eyes, my symbol is going to be PE, and then the max supply is 50. Now the cost, we need to work this out. I know that I said that we are going to sell this for 0.02, remember? So I need to put this in here. Please be aware that this is the display cost. You need to copy this and take it into some kind of converter. So a good converter is this website where you can put your ETH in there. And even though this is Matic, you still work with decimals of 18. So you can put your ETH in there, just pretend this is your Matic, and then copy the way amount. Go back to the configuration and put your way amount in there. Then the marketplace is going to be OpenSea, but if we want the actual link, we can go to our OpenSea link and check. It's updated the metadata, guys. How cool is that? Our Purple Eye collection is live, and it is actually so live that you guys can actually go and buy them. They are really cheap, 0.02 Matic. But anyway, what I just wanted to show while we are here, you can see that all these traits have been pulled in, and these will get percentages as people start buying the collection, and it's busy growing. So that's pretty cool. But anyway, let's go and copy our marketplace link, which is that one, and we can go back to our dApp. We replace it over there, and then there's an optional parameter. You can notice that on our current dApp over there, there's a background. You can simply switch that off by changing this value to false, like so. If you do that, you'll see that there's no background. But I like the background, so I'm going to leave it in there. Perfect. You are basically done, but there are a few changes that you still need to make. You need to basically go and put your ABI that you have copied into this file over here. You need to replace it, otherwise it won't have the correct ABI settings that it needs to use. Theoretically, it should be the same ABI because I've used the same contract. So let's try this out. But in a safe way and making sure that it will always work, like I said, you can get your ABI if you go to your remix and you go and select your contract. Remember, like so. Just make sure you have the right contract and then copy the ABI. That's why we've saved it before for this purpose as well. But going back to this file over here, the abi.json, we can select all, and I'm going to paste it in, and then I'm going to hit save. Perfect. So now everything is hooked up. The only few changes that you can make is in the index.html page. If you want your title to be different, you can change it over here, and you can just maybe type the purple I and new mint your PE NFT, right? And that's pretty cool. So you can change it there. And then what you need to do is you need to add a logo that is 192 pixels by 192, as well as a 512 by 512 and a fav icon. And that you can just simply create these images and replace them. In your manifest file, which is the last file you would like to change, you'll see that there's a short name and a name. This is basically if the app is basically saved offline. So it's good practice to just change that out too. So I'm going to do that. Like so. So now that we have the purple eye and everything is set up, I can go back actually to my browser and check out the dApp. You can see that indeed we have 0 out of 50 minted because we're not connected yet. If I try and connect, it says change to Polygon because our contract's on Polygon. So I'm going to swap it out. I'm going to say go to Polygon. Perfect. Then I'm going to connect. It says we can buy. There's already 2 out of 50. I'm going to try and buy one. One caveat that I just want to share is remember that in our smart contract, we made the minting amount very, very low. Now, the problem with that is our dApp will allow us to go over that and it won't allow the person to mint. If you want to rectify this, you can simply go into the program, go into the source directory in app.js and scroll down to the part where it is controlling this increment part. There it goes and decrements and increments to 10, and that is what the limit is set to, but you can change it, and I'm going to make it 2. I will create, however, a nice configuration for that. I just didn't think of it at the time. I'm just going to save that anyway, but you probably don't need that if you have bigger minting amounts than 10. So just going back, I'm just going to refresh my app. I'm going to connect, and now you see I can't go higher than 2 or lower than 1. I'm going to try and buy one. So I'm going to click on buy. It's going to pop up my MetaMask, and it's going to tell me that I'm about to mint one. I'm going to pay 0.02 Matic, which is perfect. And if I click on edit, I can see that 285,000 gas is being sent. And the reason for that is because in our configuration.json, this is the gas limit. This is usually a safe gas limit to put for 1 mint. However, the app works if you increase the buy. The app works in a way where it multiplies that by the amount of NFTs that you're going to mint. Generally, this is more than enough and actually a little bit too much, but it's better to be safe than sorry. So if you are working with the Ethereum network, you might want to change these parameters a little bit, but for Matic it's fine. It allows for enough gas to fully mint the NFTs that's needed. And keep in mind, the gas that's not used will be sent back. So we can just reject this. I only want to mint 1. So actually I'll mint 3. So I'll mint 1. Let's confirm the transaction. It will say, and you can see that everything is updated. Purple eyes, it says mint 1 PE cost 0.02 Matic. excluding gas fees, minting your purple eyes, ... and it's now busy doing stuff, right? And these buttons are also frozen. You can't do anything. We have a disclaimer, which is always good to have on your apps, that this is a reversible action. Then you can also click on this link over here. So I'm going to open it in a new page so you can see it goes to our contract address. And if we click on it, I can see that if I go and refresh, let me just see, it's supposed to have a new transaction taking place there, which it's not. So I just want to see why. I'm going to go into my transactions, and it is saying that it is, well, it is minting. It should show up on our contract. So I'm just going to click on this contract. And let me just see what's happening. So we've only minted these, which is fine. I do have the right configuration. So you need to make sure that it is the right configuration. And that is fine. That seems like it should be just working perfectly. But you never know. So let's just double check. Reveal. It's doing that. I'm not seeing the transaction taking place, and I'm not sure if that's because it's still busy working on a transaction over here. I'm going to try and just speed this up, not by that much. I'm just going to speed it up a bit because I want to show you this live process, right? So I'm just speeding up the transaction. Maybe that's why it's not reflecting on the contract itself yet. But it should. So I'm going to just refresh. Oh, there we go. It did mint 11 seconds ago. Perfect. So if we go back to our dApp now and we refresh and we connect, it should say there's 3. And indeed there is. So I'm going to mint 2 now because I want to see this live update. And I'm going to say confirm. But I actually want to just edit my gas price to be, let's make it 20. So that it just happens a bit faster. You also notice that it increased the amount being sent to 0.04. So now, after this mint is successful, this should update and be 5. So let's check it out. I'm just going to open MetaMask and see the transaction taking place over there. And while we wait, guys, I really appreciate you sticking around for this big tutorial. I'm sure that this is going to be a very long one and has been, but in essence, this tutorial will help you so much to understand all the little things that you might have gotten wrong in the past, and I hope it really does. I hope it really does help you guys. It's been successfully minted, so it hasn't updated yet, but if I refresh and connect, it should be 5. Perfect. And there you can see that 5 has been minted. We can go ahead and check the contract. We can refresh the contract and see that there was another one and another one minted. This one came through. So if we go there, we can see all the tokens being minted here successfully. How cool is that? So the last step, in order for you to host this somewhere, you can simply buy a shared hosted service to put this dApp that you have over here onto. But you can't just simply put this whole folder. You need to build it first. The last piece of the puzzle is simply running npm down here in the terminal, run build. So npm run build. When you hit enter, the application will simply bundle up everything and build it in a build directory over there. Wait for it to complete. So once it's done, all you need to do is right click on the build, reveal in Finder, or if you're using Windows, just go and find the build folder. All this content over here you can now upload to a static shared hosted service. So the very last part is to actually select all those files in the build folder, compress them, go to a shared hosted service. You can choose any shared hosted service. I'm using my local country's services because I'm living in South Africa. But if you're living overseas, maybe a service like Ionos might be good. It can be a very cheap service. It doesn't have to be something exclusive and powerful, because it's simply a place for us to host our DApp. Now I'm going to say upload, and I'm going to upload this archive file. Now, while this is uploading, basically I'm just going to simply extract it, and then once everything is uploaded and extracted, I can access this DApp by going to the Nerdy Coder Clones collection. I am actually uploading this quickly in place of the Nerdy Coder Clones just to show you guys how to do this. But after this tutorial, I'll take it off and you guys can mint your Nerdy Coder Clones again. So there's the zip file. I'm going to extract it over here. And there we go, it's extracted. So now, if I go to the Nerdy Coder Clones, I should see my new DApp. And there we have it. If I go to the Nerdy Coder Clones.online, I've now simply replaced my Coder Clones DApp with this one, and I can still connect. It has 5, it is hooked up, it's ready to rock, and I hope you guys can do the same. If you have uploaded your DApp and your images aren't showing, for example, these GIFs aren't showing as well as the background image, well, go back to your hosting service and find where the images are located. Then go and see that they all have at least 0644 permissions. So I'm going to change that to 644 and this one as well. Once you've done that, you can also give them a higher permission like 775, but at least 644 is necessary. So when you refresh, your images will show up. I really hope this tutorial helped you guys. I just want to mention that if you get stuck, please go and ask on the Discord channels, which Discord is very organized. There's frequently asked questions and a community that's willing to help. So go on there and ask your questions. You can also go onto Telegram and keep an eye out on our YouTube channel for more awesome content. I really hope that you guys create awesome, cool dApps like these. And if you want to go and buy a Nerdy Coder clone and support the channel, by all means, go and do that. You can go to nerdycoderclones.online, buy one, it's 100 Matic, and come and join the Discord and show it off. But that being said, I also just want to thank each and every one of you for being a part of this community, helping each other out, and always giving me the most positive feedback that anyone can ask for. I am really proud to make these videos for you guys, and I hope this long video deserved a thumbs up or at least a subscribe. So till next time, guys, I'll see you on the code side. Cheers for now.
Oh, we're going to learn some cutting-edge NFT building techniques today. Hi all, this is going to be an end-to-end NFT creation tutorial, and we're going to use an especially special technique introduced to me by the OniChain NFT project. They have this insanely cool way to use Chainlink VRF to generate programmatically random, truly random images on-chain, 100% on-chain, and we're going to give to you this superpower. So in this video, we're going to do a quick rundown of what an NFT is and tell you the differences between this video and my last long video on NFTs. Do a quick start of the repo and the code that I've already built for this tutorial. Then we're going to build this entire NFT project from scratch, explaining you, along the way of course, how we're doing everything. Then we're going to deploy this to a testnet blockchain and see what these images and these NFTs would look like on OpenSea. And then we will deploy to a real live blockchain because so many people have been asking how to do that. And then of course, if we wanted to, we could start selling it on OpenSea. And for those of you who have been like, Patrick, where you been, man? Like we've been missing you. Stick around to the end, I got an update for you. So let's do the quick NFT refresher here. If you're new to NFTs and these acronyms are kind of giving you nightmares in this cryptocurrency blockchain space, definitely go check out my glorious guide to NFTs video. There's a link in the description. It'll give you everything you need to know to watch this video. And it's a lot of fun, and I think my jokes are pretty good. Now, I also have another tutorial that goes over how to deploy, create, and sell NFTs. And it's got so many views, I'm so proud of it! But this one is going to be a lot different in a number of ways. First off, we're going to be hosting our metadata right on the blockchain instead of on IPFS. We're also going to be using Hardhat in JavaScript instead of Brownie in Python. And we're going to randomize our NFT art 100% with on-chain interaction. Now, a few notes on these points. If you're looking at this first point saying metadata, IPFS, what is he talking about? Don't worry, we'll explain metadata as we go along. But go watch my glorious guide video and explain it in there. God. For number 2, yes, I know, I did the unthinkable. I coded in JavaScript. I think I'm going to be sick. And as much as I hate JavaScript, I think the Hardhat tool is pretty phenomenal, and the team has done an amazing job to make this tool really usable, even in the disgusting swamp JavaScript is. And number 3, well, you'll see. For those of you who like Python and want to see a little bit more of the traditional way that these NFTs are hosted and generated, definitely go watch my other tutorial. That other tutorial uses Brownie, it uses IPFS. It is an absolutely fantastic tutorial. We are going to go into the pros and cons of using the method we're going to use here and the method we used over there in this video. But in any case, I think both of these techniques are fantastic for creating your NFTs. Per usual, first we're going to go into the quick start showing you how to use the repo that I've already created and showing you exactly what we're looking to build. And then we're going to jump in to building the code and everything 100% from scratch, explaining along the way everything that we're doing. So, are you feeling froggy? Let's jump in. You can find everything that we're looking to work with on my GitHub. There will be a link in the description for how to work with and how to build everything on here. There's a README you can follow along with. Now, to get this repo into our VS Code, again, I'm working with Visual Studio Code, but you can use whatever text editor that you want. We're first going to need to have Git installed, so we can check that with git -- version. I do indeed have Git installed. We'll then want to come to my GitHub here. Again, the link for this is in the description. And in here, we'll do git clone, paste that in. We'll cd all on-chain generated NFT, and all of our code will be in here. Now, we'll also need Yarn. We can check to see if we have that installed with yarn -- version. We also need Node.js -- version or Node -- version. Again, in the README, it'll teach you how to install all these. We'll also need Hardhat installed. Again, README to do that as well. And we'll just download everything in here with Yarn. And then I also have this Hardhat shorthand autocomplete. You can install with npm i-g Hardhat shorthand, or you can do yarn add global Hardhat shorthand. I already have it installed, so I'm not going to run that. You'll know you've done it right if you can do hh -- help. This shorthand is literally the exact same thing as just doing npx hardhat -- help. So we have 2 contracts that we're going to be working with: random svg.sol and svgnft.sol. Random svg.sol gives us a randomized image that's built within SVG, and SVG NFT is the more simple one that we're going to start with first, that creates an NFT based off of the SVG that we go ahead and give it. So what is this SVG thing that we're talking about here? SVG stands for Scalar Vector Graphics, and it's just the type of image that we're going to be working with. As we dig deeper into the code, you'll see why we're using an SVG here. SVG code is a way to programmatically command something to draw what an image looks like. So for example, all this code over here defines what this frog on the right should look like. And to get started, we're going to go ahead and deploy them onto a local blockchain of our own. But to deploy this to a local chain, we'll do hardhat deploy, or npx hardhat deploy, and it'll spit out all this stuff. So this is simulating as if we ran this on a real blockchain. The first thing that we do is we deploy an NFT, an SVG NFT. This is kind of the simpler one to a blockchain, and it gives us this token URI. And if we paste this first token URI into our browser here, we'll get the metadata for this object. And again, all this metadata is being stored directly on chain. A quick refresher here. Metadata has a name, a description, some attributes, and then it has the image URI, which defines what this image looks like. You'll see this is very different from like an HTTPS URL, right? We have this data image, SVG plus XML, base 64, and then a whole bunch of random stuff. So this URL defines what this image looks like. And if I paste that in the browser, I get a blue circle, right? This is a really simple NFT generated with this SVG. So that's the first bit. The second bit that we can see is our randomized SVG. So what this will do is it actually will deploy an NFT that was generated programmatically on chain and with randomness. So again, we have this little output here. This is the token URI for this NFT. We can paste it in and we get this massive metadata piece here. And I'll grab this image URI, copy, paste it in, and we can see this is the image that was randomly generated. Obviously, it's just a bunch of lines and doesn't really look like anything, but that's because we said, hey, randomness, go have fun, go be random. And that's what we get. Now we can go ahead, deploy this to something like Rinkeby by doing hard hat deploy -- network Rinkeby. And of course, to deploy this to Rinkeby, there are a couple of requirements. Yeah, npm yarn. We also need a couple environment variables, a Rinkeby RPC URL, basically a way to connect to Rinkeby. Excuse me, a private key that has both Chainlink and ETH in it, ETH and link. You can always find the most up-to-date faucets by going to link token contracts. Just search that. Come to here and look up Rinkeby. You can always find the most up-to-date faucets on this page to get it into your MetaMask here. And then we'll just go ahead and hit enter and deploy this to Rinkeby. I should spell network right. And what this will do, it'll deploy both of these contracts to the Rinkeby testnet, and then it will also mint an NFT. So these NFT contracts are factory contracts that create our collections, right? The main contract defines the collection, and every time we hit mint, we mint an NFT of that collection. We also get this nice little verify with. So while this transaction is going through, which of course we're gonna have to wait a little bit, I'm gonna create a new terminal. I'm gonna paste this verify script. I'm gonna go ahead and hit enter, and we're gonna go ahead and verify this. Now, I've already verified this code a couple of times, and Etherscan is smart enough to recognize that this code's already been verified, so it'll already automatically be verified. But in order for you to verify it, make sure you have your Etherscan API key, and there's a little link in the README if you're learning how to get that. So let's go back to this. Cool. We've made our first NFT. So if we go to this contract address in Rinkeby now, Rinkeby Etherscan, paste it in. You can indeed see there's a contract here called SVG NFT. We go check out the token URI, that's 0 with 1, and we see that exact same thing. Now what we can do is we can grab this address, go to Rinkeby OpenSea, and depending on how fast OpenSea is here, we can paste that address in here, and we do indeed see that there's an item in here called SVG NFT2, and one of these NFTs is minted, and boom, we can see exactly what this NFT looks like, and it's that blue circle that we minted, right? The reason that it's this blue circle is because in our code here, we're minting this small enough .svg, and if you look in here, it's exactly that. A really simple SVG code saying, hey, we're gonna have height and width of 500. It's gonna be a circle. Here are kind of the parameters to define a circle, and that's it. And that's exactly what got minted. So that one went through. Now the random SVG is being minted. The random SVG probably already also got verified, but let's grab this verify function, and we'll paste it, and we'll see if we can verify this as well. Cool, we're gonna go ahead and start verifying this contract, which we can go back to Rinkeby Etherscan. We'll paste it in. We'll see it'll get verified once that verification completes. But we're gonna run a couple of different functions here. So first, we deployed it, of course. Then we just verified it. Now we're gonna create an NFT calling the create function after we sent this contract some Chainlink token. And we will have to wait a little bit of time, probably a few minutes actually, because we're doing a number of transactions here. So this is your time to maybe go grab a cup of coffee or something. And so after a few minutes, I know there was definitely a few minutes there that we had to wait, we'll get an output that looks like this. So we created our NFT contract, and we created an NFT, and whoops, this should just be 0. I should fix that later. We waited for the Chainlink VRF to respond to randomly mint our NFT. Then we called a finish mint function to finish minting the function. Now again, we get an output like this. You can take this, pop it in to a browser, and then we'll grab this image URI to see what this random thing looks like. And boom, this is what we got. We just got a couple random green lines. Perfect. That's random. It doesn't look very creative here, but it'll show you the power of all the different things that you can do. And again, if we grab this address here, this contract address right here, we pop back onto OpenSea, we paste that in, we'll scroll down, we can see there is a result here. We'll hit refresh metadata, we'll refresh, and we can see that the metadata and the image actually is here. Now just remember, sometimes OpenSea is a little slow, sometimes Rinkeby is a little slow, so just be a little bit patient if they don't happen right away. But this is exactly what we're going to do. This is what we're going to be building, this way to both upload our own SVGs and upload our own random SVGs. I know I've showed this protocol enough, but I was just so blown away by this application. They do kind of a mix of the two, where they have some images, they have some SVGs already on chain, and the random number actually just mixes and matches the SVGs to create all these different images, which is really cool. And you can check these out on OpenSea. All these different attributes like this eye patch, the hair color, their eyes, these are all SVGs on chain that are randomly selected by a Chainlink VRF. So this is the type of thing that you could build, which I think is absolutely stellar. So now that we know what we're looking to build and how we're looking to build it, let's get started building this entire thing from scratch. So I'm going to go to my demos folder. I'm going to make dir all on chain generated NFT repo, cd all on chain generated repo. I'm going to open this up in my VS Code. Now, if you don't have VS Code, that's totally fine. This is just text editor that I'm going to be working with here. Remember, the first bits that we need to actually have installed are going to be Node.js. So we can check if we have that with node-version. And we also need, we're going to be using yarn. So we'll do yarn-version. We're going to need hardhat. So we'll make sure we have hardhat with hardhat -help. Oh, and I'm just going to go ahead and quit. Definitely have hardhat installed. There's some links in the README of this GitHub repository, again in the description, on how to download all these requirements. So great. So let's go ahead and get started by building a sample hardhat repository. So I'm just going to do npx hardhat, and we're going to go ahead and say create a sample project. We want the root to be right here. Yes, let's add a git ignore. We'll hit enter. Let's install some of those dependencies for us here. And great, we have our simple hardhat repository here. I'm actually going to go ahead and delete package-lock.json because I'm going to use yarn instead of npm. So in here, we have a couple simple contracts, some scripts. We're going to be deleting a lot of this stuff, but there's some great videos on kind of the layout of hardhat that you can learn in some other videos. So since we're making some contracts, we might as well start with the contracts. So we're going to start with that SVG NFT. This is kind of the simplest starter bit, and then we'll go to that more advanced randomized SVG that we'll work with in a bit. So I'm just going to go ahead and delete this contract here, move to trash. All right, so let's go ahead and create our first contract. This is going to be our SVG NFT.sol. And let's talk a little bit about what we want this contract to be able to do. So we want to be able to give the contract some SVG code, which we're going to go into how to actually generate this SVG code, and working with this SVG code, we're going to talk a little bit more about that. And it should output an NFT URI with this SVG code, storing all the NFT metadata on chain. right? And this is going to be this simple example of how we can do this SVG code. And then after we go through this simple example, then we'll do our random SVG, which will take this and level it up and make it explosively dynamic and way, way more unique and powerful and just way more fun. So let's go ahead, let's jump in, let's start building this Solidity smart contract. So we'll start with, of course, SPX, SPDEX, license identifier, MIT. I just did a little tab complete there. I will try to do as few tab completes as possible. We'll do Pragma, Solidity 0.8.0. We're going to be working with one of these newer versions of Solidity. We could really do any version, but we'll just do 8.0. And we'll make our contract, which will be SVG NFT. And boom, that's it. Now we have our contract. Yay. Now I do have a Solidity. Now I do have a Solidity extension in here. Solidity extension installed here to make it kind of format nicely and look like this. And we're going to close these because we're going to be focusing on the contracts now for a little bit. We're going to be building this as an ERC721 or an NFT. And of course, we don't want to have to reinvent the wheel, right? This ERC721, this NFT standard, it's been done, right? It's been done 100 times. So we can actually just borrow OpenZeppelin's ERC721 contracts to get started here. So we're going to go to their latest, their version 4.x, and we're going to add it. We're going to add these contracts in. It's actually yarn instead of npm. It's the same thing though. Yarn add at OpenZeppelin/contracts. And this is going to enable us to kind of work with these pre-built smart contracts that already have this NFT standard for us. So we're not going to have to rewrite every single function needed in an NFT. This already has everything for us. So, and once we install it, as this thing kind of installs here, this is all we're going to need to do to make a really simple NFT. Obviously, we're going to do more than just this, but this is kind of the main piece. So we're going to go ahead and import this OpenZeppelin code, this ERC721. However, even though I just said that, we're actually going to use one of OpenZeppelin's extensions on this. And if we go to GitHub, OpenZeppelin GitHub, I just did OpenZeppelin GitHub twice. You can actually see all the different contracts that they have in here, all the different things that they offer. We're going to go down to token, ERC721, because again, this is the NFT. We're going to use one of their extensions. We're going to use ERC721 URI storage, just because it's a little bit easier for us to set and unset the token URI. You can use kind of their base model ERC721, and this actually has some really nice gas improvements. But for the simplicity of the tutorial, we're going to use this extension that just makes it easier from a developer's perspective. This ERC721 URI storage, it's the exact same thing as an ERC721. It just has a couple of added nice little functions for us to use. So back in our code, let's get rid of this now. We're going to do import at OpenZeppelin/contracts/token/ERC721 /extensions, because we're going to use this extension that we're using, ERC721 URI storage.sol. We can even go to that contract. In here, we're literally grabbing all this code and we're plopping it at the top of our contract here, right? So it's got this token URI, it's got set token URI, it's got burn, it has all the functionality of ERC721. And what we're going to do is we're going to have our contract import that contract. So we're going to say contract SVG NFT is ERC721 URI storage. So just by doing this is Solidity's inheritance. We're saying our SVG NFT is importing everything that this contract has to offer, which again, it already has all the niceties of making an NFT. Perfect. So now our linter here is giving us an issue because it's saying, hey, you need to define some functions here, buddy. What are you doing? So we're going to go ahead and do that, right? So first, we need to make our constructor, which again, the constructor is the method that's called the instant we deploy the smart contract. And if we look into the docs for OpenZeppelin, we can see exactly what this constructor is going to look like. And all we need to do is give it a name and a symbol. This syntax here is saying, hey, we're using the constructor of the ERC 721 as part of our constructor. So it's a little bit weird in that regard, I know, but that's what we're doing. We're giving it a name and a symbol. So we're going to say ERC 721. We're going to name it SVG NFT, and we're going to give it a symbol of SVG NFT. Boom. This is going to be basically our contract collectible or collection, right? So all the NFTs that we're going to mint are going to be of type SVG NFT. So a lot of people say, hey, like how do I mint a collection? This is the collection. Like, so this would be contract Bored Apes or contract CryptoPunks. And then every time we mint one, we're going to mint a type of CryptoPunk, a type of Bored Ape, or in this regard, a type of SVG NFT. So let's go ahead and create that mint function that users can call to actually create themselves an NFT. So we're going to call function create, and we'll give this, and we'll have this take a string memory SVG, and we'll make this public. So we're going to pass this a public variable called SVG, and actually I'm going to turn this off for now. We're going to pass this an SVG. So let's talk about SVGs real quick. So here is an SVG tutorial, and I got a link to it in the description from W3 Schools. It's fantastic. It teaches you pretty much everything you need to know. So if we were to try this out, we could see like what this SVG code looks like in HTML, and this is it, right? It's basically these tags. It's very HTML similar, right? So in here we have a circle of width 100, height 100 that gets created like this, right? And so there's all these different commands and these different paths that we can do to make these SVGs. Now, one of the simplest ones is this path thing, where it just defines where a line is being drawn. And it has all these commands like move to, line to, and it's literally just like telling where to draw lines. And so here's an example of an SVG triangle, which we can click try ourselves. We can even play with it a little bit, right? So we have this move to 150, 0. These are coordinates. We have line 75, 200, line 75, 200, and then close here, right? So we can even mess with this a little bit. We can do like 200, run. We see it shifts over a little bit. We can get rid of the Z, right? We'll see what happens. Looks like actually nothing happens. We can get rid of this part. We'll see what happens. Looks like the whole thing disappears. Changing the shape of this, right? Because these commands are being slightly different. Now we could add all these other parameters in here, but for the purpose of our demo, we're actually going to just use move to and line to because both of these take 2 parameters, right? So move to, it takes 2 coordinates, line to, it takes 2 coordinates, and some of the rest of these take a lot more coordinates. So we just wanted to keep it really simple. Each one of these has 2 commands, right? It's going to be an X and a Y for each one of these. Boom, really simple. And we can generate different images with this lines, but this is where your creativity really comes in. You can go absolutely crazy with the rest of this. You can use an SVG generator to do all this, but again, link is in the description. So we're going to give this some SVG code, right? And let's even just take this triangle example here. Actually, I can just copy right here. Let's just take this triangle example, and we'll create a new folder called image, new file, and we'll try triangle.svg, and we'll just paste this triangle code in here. Now, the one thing the Web3 School doesn't actually have is it does need this thing called this XMLNS parameter in here, which kind of just defines where this is going to be hosted from. I'm just going to put in basically what are the defaults for this, which is going to be http://www.w3.org/2000/svg. Now, I also have an extension called SVG Viewer, this one right here, installed in my VS Code. And what I can do then is if I do Control P, or for those of you on Windows, you can do View Command Palette. That will work as well. Or Control P and then do this little caret thing. And now we can do SVG Viewer, View SVG, and we can see exactly what this triangle looks like in this little viewer here, right? And same thing, we can go ahead and edit this. We can make this like 200, right? And the triangle is going to shift over. This is what we're going to use to deploy. In the GitHub repository, we use a circle, but it doesn't really matter. You can use really whatever you want here. So we're going to pass this SVG, that code, to our function here. And just by passing this SVG, we're going to be able to store our NFT image, our NFT metadata directly on chain. Remember, in order to show one of these tokens, we're going to need its token URI, right? The token URI is going to be the most important thing. So we're going to have to turn this SVG into one of these token URIs. Again, if you don't know what that is, definitely go check out that Glorious Guide NFT video. It will teach you everything you need to know. So we need to turn this into a token URI, a unique resource identifier. And we're going to go ahead and do that right now. Now, so the first thing that we're going to do in this create function is we're going to want to mint one of these NFTs to whoever calls this create function. So our ERC 721 URI storage has a built-in function called safe mint, and it takes an address owner and a token ID. So we're just going to say message.sender, and some ID is going to be the token ID. So whenever we create an NFT, again, if this is a Bored Ape, it's this safe mint function that's called that's going to mint a specific one of those. Or if this is a CryptoPunk, this is minting one of those CryptoPunks. We're going to assign it to whoever calls this create function, and it needs a unique ID. So to keep track of all these different tokens, we're going to create a global variable, UN256, public token counter. We'll initialize it in our constructor to 0. We'll say token counter equals 0. And we'll just set the token ID of this safe mint to this token counter. And every time we mint one, we'll do token counter equals token counter plus 1. So we'll just increment this token counter so that every time we mint one, we're going to get a new token ID. Great. So we've minted our token here, but what's the token URI? What's the image URI? Right now, it's totally blank, which doesn't really help us at all. So we're going to need to create a function that's going to turn this SVG code, that's going to turn this triangle code right here into one of those token URIs. And okay, I'll show you what this looks like. Again, this token URI is what is going to return some metadata on what these NFTs actually look like. Okay, it's this function that will return something that looks like this, that will have the name, the description, the attributes, and then this image URI, right? Which in this example that I'm showing is going to be something like this blue circle, right? But for us, it's going to be a triangle because that's what we're doing in this demo here. Let's create a function that will turn this SVG into an image URI, right? Because we're going to actually have to stick the image URI into the token URI. So this is actually a little backwards. We're going to do the image URI first because the token URI includes the image URI. So let's create a function called SVG to image URI. And ideally, we should probably turn this into a library so anybody can use this. But for now, we're just gonna code it ourselves here. So what this is gonna do, right, is it's gonna turn, like we said, this code, and let's even just put this all to one line here. And we'll do save without formatting, so it actually does that. What we're going to want this to do is we're going to want to turn this big old thing into that example image URI, right? And it looks like this. So we can actually look at kind of the format of what this image URI is going to look like. So it's always going to start like this. So it's going to start with data, image, SVG plus XML, base 64. And all we need to do is we're just going to take our code, this SVG code, and we need to base 64 encode it, and then just add that base 64 encoding here. So this will be like base 64 encoding. And that's going to be our entire image URI, right? So if you look at this image URI here, you can see data, image, SVG, blah, 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 comma, then this big, huge string, right? All this big string is a base 64 encoded version of that SVG code, okay? So that's all we need to do. So let's go ahead and do exactly that, right? We're going to start, we're going to say string memory base URL is going to be equal to this data image SVG plus XML base 64. And that's going to be our starting point right here. Now, all we have to do is concat our base64 encoded version of this on top of our base URL, right? So we'll do string memory SVG base64 encoded is going to be equal to, and this is where we're going to base64 encode this bit here. So we're going to get a little bit fancy here, but in order for us to do this, we're actually going to use this base64-sol GitHub repository, base64 sol GitHub. So definitely be sure to star this repo. Oh, I'm not signed in, but definitely be sure to star this repo because it's what we're using and it is very helpful. It's got some really helpful functions in here. It's got this base64 library for us to use. So we're going to import this just by doing import base64-sol / base64.sol. And of course, we're going to add this with yarn add base64-sol, so we can actually have this in our project here. Boom. Okay, perfect. And then we're going to do, using this base64 library, we're going to say base64.encode, because this wonderful library already does this base64 encoding function for us. And we're just going to encode this string here. Now we have to actually do a little bit of weird conversion here. We have to first, we can't just do it like this. We have to first do abi.encode packed SVG. So we're encoding it with an ABI. Then we have to convert it to a string, and we have to then convert it to a bytes. So I know this looks like a whole lot of stuff here. Oh, and this should be a semicolon. Oops, and this should actually take a string memory SVG. Sorry. And we'll pass that SVG in here, right? So this is the base64 encoded version of our SVG. And this base64.encode, it returns a string. So I know this looks kind of crazy, but this is all we need to do to turn this into a base64 encoding. And what this is going to look like, it's going to basically look like, and if we go to our, pull up an example here, this base64 encoded string is going to look something like this, right? It's going to be this super long, seemingly random chunk of letters, but our data image SVG plus XML base64 URI understands this to be, okay, this is base64 encoded SVG. And I understand how these random numbers and letters actually work. So once we have these two, all we need to do is concat them together. So in order to do that, we can just do string image URI equals, and the way to concat strings in Solidity is doing this clever little string abi.encode packed base URL, comma, SVG base64 encoded. And then we cast it as a string. Sorry, this should be string memory. Boom, lovely. So right like this. This is how we concat these two strings together. Now this is going to look like, it's going to look like this, comma, this big string, right? So now this is what this should look like here. And we want our SVG to image URI to return this. So we're going to actually make this function a public pure, because it's actually not a view function, because it's not going to be reading anything off chain. So public pure, it's going to return string memory. And so then we can just say return image URI. So now we have this SVG to image URI, and this is something that it approximately should be returning. Okay? So in our create function, then what we can do is we can just call this, right? So we can say string memory image URI equals SVG to image URI SVG. Now we have our image URI, right? So that's going to be something that looks like this. This isn't our token URI. Oh, now this one in particular actually won't work because these are just actually random numbers and letters, but something like this would work, right? This, however, isn't our token URI. This is just the image URI, right? The token URI looks like this and has that image URI inside of it. So we actually need to wrap this image URI that we just created on chain inside of this bigger thing here. So what we want to do then is we're going to create another function called format token URI. And this is going to take in this image URI that we just created as a parameter and create that JSON object that we just saw. So let's do it. So it's going to take a string memory, image URI. And this is also going to be a public pure because it's not going to read any state. And it's just going to return a string memory, right? Now we're going to do a little bit of fancy stuff here as well. So since we know that this whole thing, again, needs to be this base 64 encoded, right? So we have this wonderful JSON object, but it's got to look like this, right? This is what the URL looks like to return this JSON object. We're going to do some fancy stuff, but let's make the JSON object first, and then we'll worry about converting it to this base 64 encoded here. Since we're just going to be making a string here, we can just start it off, right? So if we look at here, we're going to need, okay, we're going to need a bracket and a name. So let's go ahead, we'll do brackets and name. We'll put it in single quotes because it looks like we want to use a lot of double quotes in here. So we want a name for this, right? We'll call it SVG NFT. Great. Then we can do a comma description. What will this description be? An NFT based on an SVG. Great. We'll just literally copy paste that, or you can type this out. So we just need this name, description. What else do we need? Attributes. That could be blanks. We'll do attributes, or you could put stuff in here. Whatever you want to do. But then this image is the important thing, right? And let me even just let me toggle word rep on just so that it's so we can see everything here. So this image, and this is where we're going to put that image URI, right? So again, since we're concatenating thing here, we're going to do some concatenation in just a second. We'll do that comma. We'll put the image URI here, do another comma, and then we'll start up that string again. So that's equivalent of kind of having that quote here. This is equivalent to that image URI variable. And then we have another quote, and then we can just end it with a closing bracket. Great. And to concatenate this, again, we'll just do abi.encode packed. And this will be a string JSON, string memory JSON equals this guy right here. Oh, sorry, we gotta cast this to a string. Boom. Okay, cool. So this will return an object that looks exactly like this, which is great. But we got to go one step further. We, of course, need to then convert this into its base 64 encoded version. So how do we actually do that? Well, we're going to not have this be a string. We're actually going to convert this to a bytes object here. And then let me even just make this look a little nicer. So we'll do, and we got to put these little single quotes in here. So Solidity knows to concatenate everything, which is what we want. Boom. Okay, cool. Now that looks good. So remember those single quotes in here. So we're going to have to make this a bytes. And what we're going to do is with this bytes object, we're going to, once again, base64.encode. And we're going to just encode this whole thing here. Base64.encode. And then this is, again, going to return one of these giant long strings here. And all we then have to do is concatenate this with kind of the beginning of this base URL. The base URL for this JSON object is going to be a little bit different though. So we'll say string memory base URL. This one, instead of being data image SVG blah blah blah, right? We can even just copy paste it. This is going to be data application JSON. Okay, so this is different. Data application JSON. So this is saying, hey, this stuff here is a JSON object. It's not an image this time. And so what we're going to do then is we're going to do ABI. Once again, we're going to concatenate this base URL with this big thing here that we just made. We're going to concatenate them together, and then we're going to cast it as a string afterwards. So we're going to do that same thing, abi.encode packed, little bracket here, opening bracket, little closing bracket down here. And we're going to do the base URL combined, This is where having good formatting comes in really nicely. This base URL and the rest of this. So we're combining this base URL, which is this guy right here, with the base 64 encoded version of our JSON object. Perfect. And then we want to cast this whole thing as a string. Boom. And that's what we can return. So this is going to return literally something that looks like this, right? So it's going to return something like this, which is the URI for that JSON object for the token URI. So now we have a way to get our token URI. This is really cool. So what we can do now, back up in our create function, we're going to take this function and we'll do something like string memory token URI equals format token URI image URI, right? Because again, we're just passing our format token URI function, the image URI, so it can return this wonderful JSON object here. And this is showing us how we can actually update our token URI to be really whatever we want to be, right? We have this attribute section where we can add some really cool attributes. Definitely go check out my NFT mix if you want to see some other cool stuff with attributes, or the Truffle Dungeons and Dragons repository. Links in the description for both of those. In any case, now that we've created this token URI, we have this wonderful function, because we're using the ERC URI storage, called set token URI, that we can call set token URI. And we can just say, okay, set this token URI to our token ID, right? This token counter. Oops, these are backwards. Token counter, token URI. We're saying, hey, for this specific ID, right? So Bored Ape 0 or CryptoPunk 0 or SVG NFT 0, give it this token URI. It's going to look like whatever this object returns. And then once we're done there, we're going to increase the token counter amount by 1. And then I'm just going to do this underscore SVG, make these underscore SVGs just because I like having my parameters start with like an underscore. It's just going to bother me if I don't put it in here now. So just added those underscores. You don't have to, but it'll bother me. So, so great. That's all we really need. We do want to do one more thing to make our lives a lot easier when we're working with this, is we do want to emit an event every time we create one of these NFTs. This will make our lives a lot better for migrating later on, for testing, for doing a whole lot of stuff. So we're just going to create an event. If you're unsure what events are, there's a link in the description to learn some more. But we're going to do an event created SVG NFT. We're going to do a UINT 256 indexed token ID and a string token URI. Indexed token ID. And then when we create this, we're going to emit this event, emit created SVG NFT, and we'll give it this token counter and token URI. So yeah, events are really helpful. I'm not going to go too deep into them now. Okay, cool. So now we have this part done. So typically what I like to do is I like to build my deploy script, because our deploy scripts will help us run our tests, and often you want to test your deployments as well. So to do this, I use a plugin called Hard Hat Deploy. That's really helpful. This guy is an absolute beast. Builds really, really cool stuff. We can go to the Hard Hat documentation to check this out. Documentation. Let's look up Hard Hat Deploy. Right, it's in their plugins down here. It's really, really helpful, and we'll just add it here with yarn add Hard Hat Deploy, or yarn add -- dev Hard Hat Deploy. So we're only going to need this for dev work. Great. Or you could just do npm install -d. That works as well. And cool. So now what we can do is we create a deploy folder, and anytime we do npx hard hat deploy, it'll run through everything in our deploy folder here, right? So if you're familiar with Truffle, this is similar to the Truffle migrations here. Let's go ahead and build our deploy script. So we'll do 01 deploy svg nft.javascript. And this is going to have everything that we need to actually deploy this. Now, when we run this Hard Hat deploy script, Hard Hat's going to give us some really helpful things to help us understand how to deploy this. So I'm going to type some stuff. Might be a little confusing. Don't worry, just stick with it. It'll make sense shortly. So we're going to do module.exports equals an async function here. This is where some JavaScript knowledge comes into play. And we're going to add get named accounts. This is a hard hat deploy function that allows us to work with the deployer. We're going to do deployments. This will get us some really helpful things like logging, like it's there, and then also get chain ID, which is really helpful for testing versus test nets and doing a lot of really fancy stuff there. So this is an async function that we're going to describe down here. So for now, just think of this as how we're going to start this deploy function here. From this deployments, we're going to get two variables. We're going to get deploy and log from our deployments bit. From get named accounts, we're going to grab deployer, which we're going to use to deploy. And this is going to be equal to await get named accounts. And I do have an auto save, auto format for my JavaScript. Hence, every time I hit save, it kind of reformats a little bit. And then we'll do const chain ID equals await get chain ID. So I know there's a lot of stuff here. Don't worry, it'll make sense. So I really like this log thing because I can just type stuff like log. And this is basically console.log, right? So I like to kind of start my stuff with like a bunch of lines here in hard hat saying, hey, we're getting started. We're about to, shit's about to get real. All right, we're popping off now. And the first thing we're going to do is we're going to deploy that SVG code. So we're going to say const SVG NFT equals await deploy, and this is all we need to do, deploy it, SVG NFT, and then we can add some parameters in here for how we want to deploy it. We're going to say from deployer, and we're going to do logging is true. So, okay, what's going on here? This deploy bit knows that all of our contracts are in this contract folder, and it's going to look for this SVG NFT, which it'll know, it'll grab from this contract name, right? And it's going to return it from deployer, which is await get named accounts. What get named accounts does is it looks in our hard hat config for one of these named accounts. Right now, we don't have one. So we're going to add one in here. So in this module.exports thing, we're actually going to change the solidity to 8.0. We're going to add this named accounts bit. So we're going to do named accounts like this. And we're going to say this deployer, we're going to give it a default of 0. Whenever we deploy from one of our mnemonics, it's always going to take the 0 with 1, right? Remember how in our MetaMasks, we can have a whole bunch of different accounts here, right? And these are all with the same mnemonic device. Well, by saying deployer default is 0, we're saying account 0 is going to be our default this deployer here. Now, of course, the question then is, oh, okay, well, how does it know what our mnemonic is? Absolutely great question. We're going to define that in our networks. So we're going to do networks. Our default network is going to be hard hat. This is kind of our local test fake network here. And in hard hat, we're just going to have a little blank nothing here, and we get automatically assigned a mnemonic here. But for something like Rinkeby, which we're going to work with later, we are going to need some accounts defined. And we'll get into this in a little bit. For now, we'll just leave it blank. Get named accounts, deployer is defaulting to 0. When we work with our hard hat network, it's going to give us a mnemonic, and it's just say work with account 0. So that's what we're doing here. We're saying from deployer, which is our 0th account in MetaMask. And actually, I didn't even compile. I should have compiled way earlier. I guess I'll compile now, make sure everything's good. Okay, cool. Compilation finished successfully. So if you run npx hard hat compile and it doesn't compile, you have an issue. Go back into the code, rewatch some of this video and be sure to figure that out. Also, I do this thing called shorthand and autocomplete. You can use npm i-g hard hat shorthand or yarn add global hard hat shorthand like this. And what you'll be able to do is stuff like hh compile. And this is the exact same thing as running npx hard hat compile, but obviously it's much faster because I can just do hard hat compile. Anyways, with that all being said, so we're deploying this SVG NFT. And then I usually like to do a little log, saying you have deployed an NFT contract to, we'll add this little variable thing in here, svg nft.address. Cool. So we've gone ahead and deployed it. We can even test this in here by just running hardhat deploy or npx hardhat deploy. Oops, I forgot to add this require hardhat deploy in our config here. So let's go back to our config. We'll scroll to the top, require hardhat deploy, right? And let's try hardhat deploy again. And this should run this deploy script on kind of our fake network and perfect, right? So if you're getting this, that means things are compiling. Your script is working so far up to this point. However, we want to just add everything in this little script here, right? We could break out, creating and SVG to image URI into kind of their own deploy scripts or their own tasks or whatever, but we're just going to add everything right in here. So the next thing that we're going to need to do then is we're going to need to call this create function with some SVG code. So we're going to save our SVG code, again, in this image triangle.svg. Feel free to add really whatever you want here. Just remember to add this XML, MLNS bit here, because this is going to be an important piece for our code to actually really understand what's going on here. Once we have it in here, we can just read from this file to get our SVG. So we'll do let SVG equals fs.read file sync. And then we're going to go ahead and add this fs in here. So we'll do const fs equals require fs. And then we'll do yarn add fs in our terminal. So we can work with fs. Great, that's in there now. So we'll do svg equals fs.read file sync. And we'll say, we'll let the file path equal ./image/ whatever you have here. Do triangle.svg. So we're going to read that file path with encoding of UTF-8. And for this, I found it's best to just kind of have it at one line. Don't use a new line or else it'll get confused here. So just make sure it kind of looks like that. Now we'll have our SVG read in, and we're going to call svg.create, right? We're going to call this create function by passing in this SVG thing here. So this is what we're going to pass to our created SVG contract. So now that we have this deployed, we're going to actually need to go ahead and work with it. So we're going to do a couple things here. We're going to do const svg nft contract equals await ethers.get contract factory svg nft. Let's get rid of this. svg nft. So we're going to need to work with ethers here. What this is going to do, it's going to get us kind of all the contract information about this svg nft contract. Now to grab that, we're going to need to go back to our hardhat config, and at the top, we're going to have to do require at Nomic Labs / hardhat ethers. And we're going to go ahead and grab this, pop on a new terminal again, and yarn add at Nomic Labs hardhat ethers here. One of these wonderful plugins. And then we're also going to want to do yarn add ethers, so we can work with this ethers package, and we'll just test to see if everything's working with our hardhat deploy. Great, things are working spectacularly. Once we have the contract here, we're going to add a signer, so an account to sign our transactions. So we'll say const signer equals accounts of 0. And let's get our accounts actually from const accounts equals await hre.ethers.get signers. HRE stands for the hardhat runtime environment built in whenever we run one of these hardhat scripts. .ethers.get signers. This again just grabs one of these accounts, kind of similar to deployer. The reason that we got to do all this extra stuff is because this technically isn't part of the deployment process. This is like extra stuff that we're doing. We could do all this in a script, but we're kind of lazy. We're engineers. We want to automate everything. Now we're going to do const svg nft. Right, we're not quite done there. Is going to be a new ethers.contract, and this is going to have this svg contracts interface and ABI and all the functions. It's going to have this signer here, and it's going to have the address. So this is the line that actually gets us like an SVG NFT that makes it easy to make transactions. So we're going to say it's the SVG NFT.address, SVG NFT contract.interface. And then we're going to do one more thing. We're going to get a network name. And this is actually going to come from a network config that we're going to go ahead and define. So typically what I like to do, and this is something I actually pulled from Aave, is along with our hardhat config, we'll make a helper hardhat config.js. And in here we'll have a lot of wonderful little helpful tips. And we'll have something in here called network config, which will just have some helpful variables for each different network. For example, network 31337. This is the hardhat network. We're going to give it a name here of localhost. And then for something like Rinkeby, which we're going to work with later, as a chain ID of 4, we're going to give that a name of Rinkeby. But we'll get to that later. So at the bottom, we're just going to export this network config so that our deploy script can work with it. So we'll do module.exports equals network config. And then in here, oh, sorry, it keeps auto importing stuff. I don't want it to auto import. Sorry. Back in here, we're gonna grab that network config that we just made. So we'll say let network config equals require dot helper hardhat config. Now that we have this network config, we can get the network name by doing network config of that chain ID, right? And again, hardhat network is 31137 chain ID, and then we'll just grab the name. Now, the reason we're grabbing this network name here is because typically when we deploy to an actual network, we're going to want to verify our contract. So this has a little green check mark. Having this green check mark on Etherscan means that we can scroll down and we can see all the code in here. So we're going to want to make it so that Etherscan can get that little check mark. So I usually do a little logging here saying verify with little new line, and we'll say npx hardhat verify -- network, that network name, and then this will be svg nft.address. Then after this, typically, this is a plugin. I'll show you how to do this in a second. Typically, we also add the constructor arguments. If we go to our svg nft, this has no constructor arguments. So for this one, we can just do exactly what we're doing here. Verify with this thing right here. So for example, if we did like hardhat deploy again, we're going to get this command that says npx verify with npx hardhat verify -- network localhost, since we're on hardhat, and the address of that svg nft contract that we just made. This obviously won't work on localhost, but it'll work on Rinkeby, Kovan, mainnet, etc. We've deployed our svg nft. Nice. We have some svg code. We've done all this work to like get our contract. We've done some like verification stuff. Let's actually go ahead and call this create function, right? Because we just deploying this contract will mint this factory contract, but we don't have any NFTs. This is basically our collectible, but this create function will create an instance of this collectible, right? So let's go ahead and do this. We'll go ahead now and we'll create a transaction. So we'll say let transaction response. Oftentimes you'll see transaction response as TX. Sometimes you'll also see transaction receipt as TX, but this is going to be a type transaction response equals await svg nft.create. And we're going to pass that svg code. So svg.create is going to take this new ethers contract that we made, right? That's at this svg address. It has the ABI/interface of our svg contract, and the signer is that deployer, that zeroth account in here. And we're going to make this transaction. Now what we're going to want to do is we're going to want to wait for that transaction to complete. So we're going to say let receipt or transaction receipt equals await transaction response dot wait 1. We're going to wait for one block for this transaction to go through. Then we'll do a quick log saying log, you've made an NFT. And then this create function, like we showed before, is going to create us an NFT, bring it through this SVG to URI thing, and then format it to a token URI. So we're going to be able to read that from the chain. We'll say log, you can view the token URI here. And we'll do await SVG NFT dot token URI of 0, right? Or that first one that we create. So if we run this now, hardhat deploy, we should see something that looks like this. Hey, you can view your token URI here because we're passing it our SVG code of triangle.svg, right? So everything's pre-populated, and this is exactly what it'll look like if we were to do this on a real blockchain. So if we put this in here, we get nothing. Okay, I forgot a comma here, right? Base 64, it's going to need a comma. So back in our function here, we just have to add this comma in here. That was my mistake. Let's try that again. Hardhat deploy. And okay, so now we can grab this, copy this. Now that we have this comma here, we'll paste it in, and we can see we do indeed get this JSON object, right? Name, SVG NFT, a description. Well, looks like we actually forgot a couple commas here, right? We have name, SVG NFT. There should be a comma here before description. So this actually wouldn't render on OpenSea, but let's see if the triangle is at least correct. Great, the triangle is at least correct. But let's go ahead and fix this. We need a comma here. We need a comma here. Let's look back. Where did we forget our commas? Forgot a comma here. Description. We need a comma here. And we need a comma here. So we forgot a couple commas. Try this one more time. Hardhat deploy. All right, here we go. One more time. We'll grab this. Paste it in. There we go. Much better. Name, SVG NFT, comma. Description, right here, comma. Attributes, comma. Image. Boom. Now this will render correctly on something like OpenSea. We do indeed see our little triangle here. So what do we do now? Well, we can now go ahead and deploy this to a real blockchain or a testnet blockchain. We are not going to deploy this one to Polygon. We're going to deploy our next example to Polygon. But how do we deploy this one to a testnet just to make sure that it actually would work on OpenSea? Well, we're going to go back to our hardhat config and we're going to add some stuff. Right now, our only network that we have any defined stuff in it is hardhat. Right, but we were saying, hey, we're going to need to work with Rinkeby. So let's add some stuff in here. So first we'll add this Rinkeby network. I'm just going to delete this for now. This, again, Rinkeby is an Ethereum testnet for us to test for free what this would look like on a real chain. So we're going to say, hey, we're going to deploy to this Rinkeby chain in here. And we need to do two things here. We need to give it a URL to connect to the Rinkeby chain. And then we also need to do, like I said before, this accounts thing. So the URL we're going to grab by getting some environment variables. This URL is the way that we can connect to the Rinkeby blockchain. So I'm a big fan of using Alchemy. Alchemy.com. Is it .com? Yep, alchemy.com. What you can do is you can log in, create a new account. You'll get a dashboard that looks like this. We can hit create app. I'm going to call this SVG. I'm just going to call this NFTs. Description is going to be NFTs. Development environment, Ethereum, and we're going to be on the Rinkeby chain. When I hit create app here, it's going to give us this new network below. Again, I have a couple others up. We can click into it and we can hit view key. And this will give us an HTTP endpoint. Right? And this is what we're going to want to use. Now, here's the naive way of doing this, is copying this and just putting some double quotes and pasting it in here. That is not what we're going to do. That's really bad. You never want to hard code these into your code. Instead, we're going to set it as an environment variable, which is a lot better. For any serious project, I don't put it in a .env file, but a .env file is an easy way to set environment variables. We have a link in the description to learn more about environment variables and setting them safely. We're going to go ahead and use this .env method for the time being. And in here, we're going to add Rinkeby, RPC URL equals single quote, and then we'll paste this in here. And I'm going to delete this. I'm going to delete this key right after this video so nobody can steal it. Now we have this environment variable back in our hardhat config. What we can do is we can grab this environment variable by doing const or consistent const rinkab RPC URL equals process.env.rinkb RPC URL. And then we're going to do this other thing called require.env. So we're going to do require.env.config. We're going to, this line will load all the environment variables from our .env, and we'll be able to use this RPC URL. And now we can copy paste this here. Now we're able to connect to the Rinkeby blockchain to deploy smart contracts to it. So cool. We do have to add this .env bit here. So we're going to do yarn add.env, and perfect. Now we are able to work with our .env file, and we're able to grab this Rinkeby RPC URL, so that's not hard-coded in our code here. Now what do we need to do? Well, the other thing we need to do is we need an account. We need something that is able to, that has Rinkeby Ethereum and eventually Rinkeby link. So we're going to do accounts, and we're going to be pulling our accounts from our mnemonic phrase. We're going to call it mnemonic. Again, we're going to create this environment variable called mnemonic that's going to have our mnemonic. And then we'll grab it with const mnemonic equals process.env.mnemonic. So again, in our .env, we're going to do mnemonic equals, and this is where we're going to put our mnemonic, like frog, cat, dog, you know, whatever. Where can we find our mnemonic? Well, great question, young person who's asking me this question. Go to your MetaMask, right? You're going to want to need a MetaMask, and you're going to need some testnet Rinkeby ETH, and some, not for this part, but eventually we'll need some testnet Rinkeby link. Whenever I'm looking for testnet faucets, I always go to this, I always just do link token contracts in Google. This link token contracts in the Chainlink doc shows up, and it always has the latest faucets and their locations for each testnet. So I'm going to look for Rinkeby, and we have great. Testnet ETH is available here. We'll click this, we'll send a tweet, and we'll get some ether with a tweet we send. So we create like a tweet, we post the link to the tweet in here, we hit give me ether, and it'll give us some ether, which is a lot of fun. And then we'll get some Rinkeby ETH here. Again, the reason we're using Rinkeby is because OpenSea has a testnet that works with Rinkeby to test everything that we're doing. Again, I've already got a whole bunch of ETH in here, so we're good to go. Then you'll want to grab your mnemonic by clicking this, settings, security and privacy, and then hit reveal secret recovery phrase. Something that I never ever do is when I'm testing, I never work with a real wallet, okay? So for testing here, create a new wallet, a brand new wallet, so you can have a brand new mnemonic phrase. If you just create a new account, it's still gonna have the same mnemonic. If you're in MetaMask, you're like, oh, okay, I'll just hit create account. It will still have the same mnemonic here, right? So you're gonna wanna create a new profile, import a new MetaMask, whatever, right? I highly recommend using a different MetaMask and a different mnemonic from your production one and from any MetaMask that has real money in it. So we're gonna need a MetaMask. There's a link in the description to download MetaMask if you don't have it. And remember, we're gonna need to be on this Rinkeby test network, right? We can't be on main, we're gonna be working with Rinkeby. So we need the Rinkeby ETH and later on the Rinkeby link. So once we have that and we put our mnemonic in here, I'm just gonna delete it for now because I already have this test mnemonic set as an environment variable, but you're gonna wanna put it in here. Once we have that in our config, we just do mnemonic, we'll pull it in from our environment variable like so. The last thing I like to do here is I like to do save deployments to be true so that we save all of our deployments. One more thing in our .env. Remember how in here we do this little verify thing? Well, in order to do this verify thing, we're going to need to add this hardhat etherscan. Yes, there's a whole lot of these plugins that we do. So to do it, we can do npm install -s save devs at Nomic Labs right here, or we can just do what I'm going to do, which is yarn add --dev at Nomic Labs /hardhat etherscan. We paste it in. While that's downloading, we're going to grab this require statement and add it to our hardhat config.js. So back in our hardhat config, I'm going to do bop require at Nomic Labs /hardhat etherscan put that into the top. And then we have to add this little Etherscan bit. So I'm actually just going to do it raw in our hardhat.config. We're going to do Etherscan and then API key. Oops, API key. And this is where we add our Etherscan API key. If your brain's going a million miles per hour and you're already getting ahead of me, you might already be thinking, okay, well, I'm probably going to set that in my env. You're absolutely right. So we can go to Etherscan. We can sign in. We can go to this developers. This is optional, but it's something nice to do. We can sign in, and you can create an API key. So they have some pretty good docs on creating an API key, but once you have that, you'll just put that API key in right here. And then we can do the same thing with Etherscan. We'll say, we'll scroll up to the top. We'll do const Etherscan API key equals process.env.etherscan API key. And then we'll grab this, and the API key will be this Etherscan API key. And we'll need to come here. And now with this piece and the API key, which again, mine's already set, so I'm just gonna delete it for now. All right, we've got a whole lot of stuff going on. So now that we've added all this in here, we can now deploy this contract to the RinkB chain. How do we do that? Well, my friend, we just do hardhat, or if you didn't install the shorthand, npx hardhat deploy -- network RinkB. That's it. We just add -- network RinkB. Whoops, I have accounts here twice. Let's undo that. Let's grab the save deployments bit. Put it outside of accounts. Now let's try that command again. And you can just hit up. You should be able to do everything fine. Now let's hit enter. Perfect. Now we're actually deploying this to the RinkB blockchain. If we grab this little transaction hash here, we go to RinkB Etherscan, paste that transaction hash in, we can see this is a transaction that's happening on RinkB right now. And it came directly from our wallet, and we can actually see that our amount went down, right? Because it came right from here. Now, this might take a few minutes to actually update. It looks like we already went through. So back in our code here, we see everything that just happened. You've deployed an NFT contract to here. We have our verify with bit posted out. And if we did our Etherscan API key and adding it to our config right, we can just copy this line, paste it here. Looks like I did something here wrong as well. This should be uppercase. Try this again. And okay, now it's actually going through. So we're actually going to verify this contract that we just created. And right now, if we look at our contract, it says, hey, are you the creator? This is what your code looks like. It's just a bunch of random letters and numbers, which isn't helpful to us at all. Our verification went through correctly. So now if we reopen this page, we'll see, aha, we did it. It's verified. And it has all of that code in here that we just created, right? This is exactly our contract. So it's split up into the different files, right? All these different imports and stuff. But this is exactly what we just deployed, which is great because that means we can read some values on here. We can write some values on here. We can look at the code. We can see transactions and everything. Additionally, what we did is in our deploy, we called create with an SVG, and then it outputted a token URI of 0. So we can actually see that exactly what it outputted. We can go to contract, read contract. We can go to token URI. We'll pop that 0 in here. And we'll see, aha, here is that exact token URI that we just created on chain. We'll grab this. We'll paste it into another window, which it's not going to work quite yet. We'll add the comma. We'll grab the rest. We'll paste that in there. And boom, this is the token URI that's on chain. Now we'll grab this image URI again, copy that, paste it into the browser, and this is what we should see on OpenSea with this contract. So what we can do is we can grab this address, we'll go to testnets.opensea.io, we'll paste this address into the search bar, and OpenSea will go, hey, there's something there. And it sees indeed that we have an NFT that we just deployed, and it has a triangle here. If you don't see it here, you can hit refresh. You might want to go to my profile. Sometimes OpenSea is a little bit slow, but boom, we can see everything here, right? We can even see, an NFT based on an SVG. We can see the name. Everything we just deployed is here. So if you've made it this far, you've just done something insane. You've created an NFT on chain using JavaScript that it just uses SVGs and is 100% on chain. This is incredibly, incredibly powerful and incredibly awesome. However, this isn't the only reason why we're here. Now, if you've reached this point in this coding journey, you should be incredibly, incredibly excited and proud of yourself because you've just done something amazing. You've created SVG NFTs on the blockchain. You've showed how to get them onto Rinkeby, onto a real testnet. Now, that method of deploying these NFTs to a chain is going to be exactly the same as deploying to a Polygon or any other real chain, which we're going to go into now. Now, what we're going to do, though, is we're going to crank the dial up, and we're going to answer some more interesting questions. So these SVG NFTs are cool, but how do we know that they have any real value? Well, if we could just mint unlimited amounts of these and we get to pick the SVGs, then that's not really that cool, right? Anybody could just mint a copy of really any NFT. So to create a true amount of scarcity and a true amount of rarity to these NFTs, we can add some randomization to what these SVGs actually look like. This is one of the issues that is currently there for trading cards, for example. The company behind those trading cards could mint as many of those super rare cards as they want, and you would never know the wiser. We're going to introduce a method that will guarantee the randomness of the SVGs that we're going to make, and we're going to randomize these SVGs. With this method, we'll also learn how we can layer these images on top of each other by using this SVG method. We can layer different paths, combine them into one SVG, and pop it onto the blockchain. So that's what we're going to do now. Number one, we're going to randomize our SVGs now. Number two, we're going to learn how to be a little bit more creative and layering with these NFTs. And number three, we're going to deploy this to a real blockchain. We're going to deploy this to the Polygon blockchain, a real mainnet. And this is going to be incredibly cheap. And then number four, a lot of people say, how do I do a 10,000 NFT drop? We're going to learn how to do that as well. So stay tuned. Let's get into part two. Oh, and then ideally we write some tests for this as well. We have this sample test in here. I'm just going to delete this for now. We're not going to go over the testing in here. However, if you go into the README, we will have some tests for both this SVG and our randomized SVG that we're going to do. Now, let's jump into this more advanced NFT method of creating true scarcity, true randomness, adding this layering component, randomizing our SVGs, and then deploying to a real chain, deploying to the Polygon blockchain. Polygon is a blockchain that is currently supported by OpenSea, so we should be able to see it immediately on OpenSea as well. Are you ready? Because I am. Let's jump in. So we're going to start by creating a new contract. We're going to call it random.svg.sol. And we're going to get started really similarly to how we did our last piece. So I'm going to skip over talking about the same functions we talked about last time. So let's just get started. SPDX, license, identifier, MIT, pragma solidity 0.8.0. We're going to call this contract random SVG. Oops. And boom. Now, this is going to be using that same ERC721 storage.sol. So we can even just copy this, paste it in here. And we're going to say this contract is ERC721 URI storage. Let's go ahead and create our constructor here. Constructor. It's same as the SVG NFT. We're going to give it a name and a token symbol. So we can literally just copy paste that, add the little brackets here. Our name is going to be different. We're going to call it random SVG. And the symbol is going to be RSNFT. So random SVG NFT. That's our little name for it. Cool. Now we are going to have to add a whole bunch of these other functions in here, but let's do this step by step, right? Let's do this one at a time. So instead of us having our create function add an SVG here, we are going to generate a randomized SVG, right? So if we go back to our Web3 tutorials here, right, for SVG, we're going to scroll down to path, right? Because this is going to be the way that we're going to do our randomness. You can use your randomness with really any of the things in here, but you'll see why in a second, why we're going to use path, because path is really easy. So again, with our triangle, we'll try this ourselves. We're really just going to be working with this move and these line 2 commands, right? We're not going to work with Z at all. And this is going to look exactly the same. So we could do some more lines, do 100, 100, run it. It would look like this. We do another line. Maybe we'll do line 25, 25, 24, and it'll just keep doing lines like that, right? So we're going to set this up so that this path command is going to be randomized between these move to and these draw line commands, right? So we're going to flip between the two of those. And so this is how we're going to randomize this. We could also add multiple paths, and we can change this. We'll do like move 0 to 500, line to 25, 123, or 200. And then we'll do another line, maybe 100, 100. Cool, we'll get something that looks like this, right? So we're going to do some different paths, right? The more these paths, the more that they're going to stack on top of each other. We can also give them a fill or a color. For example, like we could color this blue, and now it shows up as blue. Or we could do red, and it shows up as red. So we'll have these be different colors. We're also going to do, for our fills, we're just going to do transparent, and then stroke equals blue. So we're going to have the fill be transparent. However, the lines are going to be colored, right? And so that's what we're going to do. We're going to have them all be transparent, but we're going to have some lines. But you can see we have all these different commands that we can use to kind of make this more and more random as we go along. But this is basically what we're going to do. So how do we get this started? Well, let's go ahead and get this started with a create function. So we'll do function, create. And this time it's going to take no parameters because we want this SVG to be randomly created. We don't want to have to pass it anything. We want these to come up naturally. So we're going to say, have this create function. And how are we going to do this? What's this create function actually going to do? This will be a public function, so anybody can do this. Well, we're going to want this to get a random number, use that random number to generate some random SVG code. Then we're going to want a base 64, encode the SVG code, and then get the token URI. Token URI, and mint the NFT. Boom. That's what we want to do here. Now, there is an issue with randomness on the blockchain. So a lot of people, when they work with randomness, or when they work with, or they think about randomness on chain, in JavaScript or Python or whatever, you'll do something like math.random, right? Now, you actually can't do this on a blockchain and get true randomness. You can only get what's called pseudo randomness doing something like this. Or you might see a lot of people do like kakac, block.difficulty or something like that. This will get you a pseudo random number. And I've seen it time and time again, people using a randomness method like this, and them getting hacked and losing, any and all money that they put into their projects. So we want a way to get true randomness. However, blockchains are deterministic. That's definitely not how you spell it, but they're deterministic, which means that by definition, they themselves can't actually get random numbers. So we need to look outside the blockchain to get a random number. This is where oracles come into play. And in particular, Chainlink VRF, or Chainlink verifiably or verifiable randomness function, which is a way for us to get a truly random number. So we can head over to docs.chain.link. We'll scroll down to using randomness, get a random number, and we'll see some code here. This is what we'll use to actually get one of these random numbers here. Since we're actually looking off chain to get a random number, it's actually going to happen in 2 transactions, this Chainlink VRF. So I'll have a link in the description to these documentations for you to take a look at it a little bit more to learn some more how this actually works. But in any case, how it works is in one function, we make a request to an off-chain node, right? So in one transaction, the Chainlink node is going to take this request, generate a random number. There's an on-chain contract called the VRF coordinator that's going to verifiably prove that the number is random I know, absolutely wild that you can do that. There's a little bit of cryptographic magic that goes on. If you want to check out the contracts, you absolutely should. But in a second transaction, we're going to call this fulfill randomness function, and that's going to return our randomness function here. So this is a 2-transaction process. So our create function is actually just going to request a randomness, and then once we've returned that function, then we can actually do everything that we need to do with our randomness. So let's go back to our contract, and the first thing that we need to do is get this random number here. So let's learn how to do this from the Chainlink documentation. So the first thing that we need to do here is we need to import some Chainlink contract code. And I know this, this version is 0.6.6. We're going to use this for the 0.8.8 version. So we're literally going to copy this line, scroll up to here, oops, paste it in. This is import at chainlink/contracts, src version 0.8 vref consumer-base.sol. Then of course we have to add these at chainlink/contracts. So we'll do yarn add at chainlink/contracts. Bada bing, bada boom. So now we have that. And then we have to inherit all the functionality with this is VR consumer base, right? The exact same way we're inheriting this ERC 721. We're going to inherit this VRF consumer base code as well. So we're going to do comma, VRF consumer base. Now this random SVG is both an ERC 721 and it is Chainlink VRF consumable or workable. In order to get a random number, we need to tell our contract where this VRF coordinator or this random number checker contract is. The Chainlink token, because these Chainlink oracles are paid an oracle gas in the form of a Chainlink token to perform their service, and then a key hash, which uniquely identifies which Chainlink node we're going to work with, and then the fee, which varies by network. We're going to be paying 0.1 link in oracle gas to this Chainlink node to get this random number. Again, all these numbers are different per chain. We're going to be working with Polygon, which is like 0.0001 link, so it's infinitesimally small. Similar to the ERC 721, our VRF consumer base has this little constructor here. So we got to go ahead and grab this VRF consumer base, and add this constructor to our constructor, like so. Now, each chain that we work with is going to have a different VRF coordinator contract, a different link token contract, a different key hash, and a different fee. So we want to parameterize all these variables. And we can do that by passing them to our main constructor and then pass it from our constructor to the VRF consumer base constructor. Sounds like a mouthful, but don't worry, it'll make sense as we go along here. So let's even just kind of make this look a little bit nicer here. So first thing we need to do is we need a VRF coordinator, which we're going to pass to our constructor. We're going to say address underscore VRF coordinator. What else do we need? We need a link token. So we'll do an address underscore link token. We need a key hash, and this is a bytes 32. So we'll say bytes 32 key hash. And then we need this fee, which is a uint256. So we'll do uint256 underscore fee. And now we can pass this VRF coordinator and this link token to our VRF consumer base. So we're going to say VRF coordinator, boom, like that. Link token, boom, like that. And what we're going to do is we're going to save this key hash. We're going to save this key hash and this fee as global variables here. So we're going to say bytes 32 key hash, bytes 32 public key hash. We'll do a uint256 public fee. And then in our constructor here, we'll do fee equals that fee. And we'll do key hash equals key hash, right? Similar to how they're doing it here. Key hash, fee, random result. We're not going to save the random result yet, but we'll get there. So perfect. In the example here, it gives us a VRF coordinator, link token, key hash for the Coven network, but we're parameterizing it so we can work with any network that we want. Now, in our create function, this is going to call function. Aha, I should spell things correctly. This is going to call the Chainlink VRF, and in a second function, we're going to return that random number and do some stuff with it. So we're going to call that function by doing exactly what it says right here. Function get random number, public returns, blah, blah, blah. We're going to do something really similar to this. We're going to say function create. It's going to be public. It's going to return bytes 32 request request ID. Returns bytes 32 request ID to get this random number. By saying bytes 32 request ID, this is actually the same as initializing this request ID variable. So now we can just go ahead and say request ID equals request randomness, and we're going to pass it that key hash and the fee that we got from our constructor, right? So with this, our contract needs to be funded with link to call this function. So you'll see how we do that when we get to the scripting section. But this is the main piece to get that random number. Once we get a random number, once it gets returned, it's going to get returned to a different function called function fulfill randomness. The Chainlink VRF code is smart enough to know, okay, if somebody calls request randomness, I'm going to return in a second transaction to the fulfill randomness function. And this takes a bytes 32 request ID. When we request randomness, we create this little request ID saying, hey, I am request number 1. And when we return it, we say, hey, here's request number 1. If somebody says, hey, I'm request number 2, this will return with, hey, here's the answer for request number 2. And it also returns a U256 random number, right? So it returns the request number and then that random number. Now this is going to be an internal function. It's called an internal override because the VRF coordinator is actually going to be the one to call this, right? So we're not going to let other people call this function. Only the VRF coordinator is going to be the one to call this function, and it's overriding an implementation of fulfill randomness. We're saying, hey, this is going to be the real fulfill randomness function that you're going to want to call. Call our fulfill randomness. And cool. Once we return this random number to here, then we can go about our SVG business, right? We can take that random number, generate a random SVG with it, and then do some stuff. So this is going to be that random number that we get. And what we're going to want to do is we're going to want to do something really similar to here. We're going to want to take this random number, turn it into a random SVG, and then do all this other stuff. Now, there is an issue with this. There is an issue. Boom, 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 boom. The Chainlink VRF has a max gas of 200,000 gas, or 200,000 computation units. What does this mean? This means that if what we do with this random number is sufficiently complex, the Chainlink node is going to go, that's really hard for me. That's going to be a lot of work. So what we're going to want to do instead is just say, hey, no problem, Chainlink node, just return the random number. We will deal with the heavy lifting. We will make the transaction. We will spend the gas to do this. For context, we're probably going to do something like 2 million gas, which is a lot of gas, but that's because we're doing a lot of heavy lifting on chain. Again, this method is great because we have all of our metadata on chain, but it's not so great because it's definitely more expensive gas-wise. So we're going to fulfill randomness, and we're going to use this to just get a random number, and then we're going to create an additional function called function finish mint, and this will be the function that actually does the rest of the work with our random number. So we'll call create, we'll request a random number, we'll get a random number back with fulfill randomness, and then later on we'll call an additional function called finish mint because the Chainlink VRF is going to have a hard time spending all this gas. So when a user requests randomness, we're going to want to map whoever called this function with their request ID. That way later on, when they get a random number, we can say, okay, you were Patrick. You were request ID 7. Okay, cool. This was the random number that you got returned. And here's your token ID, right? So we're going to create a mapping called request ID to sender. We're going to create this at the top here. We're going to do mapping bytes 32 to address and For the demos, I just make everything public, but you could probably make this internal. Public request ID to sender. And we're going to say, okay, so the request ID of request ID is going to be equal to message.sender. So we're saying this request was initialized by whoever called this function. And now we can keep track of them and then assign them to the NFT later on. Then we're going to need to create a token ID for this new token that we're created. So we'll do uint256 token ID equals some token counter, similar to last time, which we need to go ahead and initialize. We'll do token counter equals 0. And at the top, uint256 public token counter. Start it with 0. Oh, token ID, token counter. Awesome. Once we get a token ID, we're going to do another mapping. We're going to map this token ID also with the request ID. Why? Because again, down here, we're going to need to say, okay, sender, here's your token ID. So we're going to need to also map that to our request ID. So we're going to create a new mapping called request ID to token ID. We're going to create this at the top. We'll do mapping bytes 32 to a uint256 public request ID to token ID. And we'll do request ID to token ID of that request ID. It's now going to be mapped to this new token ID that we just created. We're then going to increment the token counter, right? So we're going to say token counter equals token counter plus 1 so that we never have duplicate token counters. This is pretty much our whole function. We are going to do one additional thing so that we can track this better. We can test this better as well. So we are going to do one of these events again. And we're going to create an event called, we're going to emit an event called requested random SVG. And we'll give it a request ID and a token ID. And that means at the top, we're going to do an event requested random SVG. And we'll give this a bytes 32 indexed request ID. And then a uint256 indexed token ID. Remember, indexing an event, indexing a parameter in an event just means it's going to be a topic. And for the testing here, I'm not really too worried about gas, so we're just going to index everything. Great. This function is done. Believe it or not, this function is done. However, this function was one of the easier parts. So we can make sure that we're doing things right. We can try harder at compile. We can see if we're great. We are on the path to glory. Things are compiling. This makes us very happy. These don't do anything, but it still compiles, at least, which is good. We've requested a random number. Great. Now that we've requested one, Chainlink Node's going to go, I got you. I'm going to make a random number for you, and I'm going to return it to fulfill randomness. So what happens when we fulfill this randomness here? Well, we're going to have to store this random number somewhere so that we can generate our random SVG, and then we'll call a function later on to generate that random SVG. So first, in this fulfill randomness, we're going to grab the address of the NFT owner, which is going to be equal to this request ID to sender of this request ID, right? Because we have this request ID to sender. Up here, when we create the request, we say, okay, Patrick, you take ticket number 0. And then down here, when it says, hey, who's ticket number 0? I go, oh, that's me. And it goes, here's your random number, ticket number 0. We also do the same thing for uint256, token ID. Same thing, right? We have this request ID to token ID, request ID to token ID, request ID. Perfect. So that's how we can keep track of the token ID and the user who called this create function across these two, this asynchronous function, if you will. Now that we have the owner and the token ID and the random number, we can go ahead and call safemint NFT owner token ID. So in our svg.sol, we did the same thing, safemint, message.sender, token counter. We just waited to mint the NFT until the random number was had, right? Because once we have the random number, we can't actually hack it. If we minted this NFT back in the create, It could be hacked a little bit easier, but now that we have the random number, exactly what the NFT looks like technically has already been done. We just haven't spent the gas to do that. And if that doesn't make sense, don't worry about it. Just keep following along. Now we have a token ID, we have a random number, but we can't do this. We can't call this, generate random SVG. We can't call this because this is going to cost a lot of gas. Chainlink node at the moment, depending on the network, won't be able to handle that load. So we're just going to we're going to store this random number with the token ID so that we can do that computation later ourselves. So we're going to create another mapping, token ID to random number of token ID is going to equal to that random number that we just got. So of course, at the top, we're going to do a mapping of uint256 to uint256 public token ID to random number. That way we have this mapping now. I'm also going to omit another event. It's really good practice, actually, whenever you do a mapping to omit an event. We might want to do one for these as well, but we're not going to. We're just going to omit created, unfinished, random SVG. We're going to pass it the token ID and the random number. This takes a token ID and a random number. We're going to scroll up to the top, make another one of these, event, paste. We'll do a uint256 indexed token ID. And we don't really need to index the random number, so we'll just do a uint256 random number. And then congrats, this is all we need to do here. That's our whole function. So let's see if this compiles with HH compile. Perfect. Compiles fantastically. So now we can move on to finish mint, where this is going to be the bulk of what we do, right? So in our create function call, and I'm going to remove these comments here just because to make our code look a little bit nicer. We create by calling our requested randomness, right? We go ahead, we request a random number. We're going to reserve a token ID. We get it fulfilled. And we go ahead and mint and assign that token ID. We have this random number. All we have to do is finish using this random number to generate some random SVG stuff, right? We're going to have this finish mint function, and it's going to take a uint256 token ID. So we're going to say, hey, we're going to finish minting a specific token ID because it's got the random number. It's already been minted. All we got to do is add the token URI to it, really. So we got to do a couple things. We have to check to see if it's been minted and a random number is returned, right? We got to check that. Then we're going to have to generate some random SVG code. Then we're going to have to turn that into an image URI. And then we're going to use that image URI to format into a token URI. And then we're all set here. So these are the main things that we have to do. Now we could do something like import, dot slash, what is it? SVG NFT dot sol, and borrow those functions. But we're just going to go ahead and rewrite some of those functions again, just in case you skip to this section and you want to be able to follow along here. Let's go ahead and we'll do some checks here. So first thing we're going to do, we're going to require the bytes of the token URI of the token ID dot length is less than or equal to 0. We're going to check first. This is going to check to say, hey, is this token URI already set? If it is, we're going to say, token URI is already all set. Can't do that. What are you doing? You're being crazy. So if it's already set, we're going to not let them call this finishment function. Then we're going to require the token counter is greater than the token ID. Because if this is less than the token ID, then we know that we're minting some crazy token that hasn't actually been minted yet. We're going to say, hey, you need to be greater than the token ID. Otherwise, token ID has not been minted yet. And finally, we're going to require token ID to random number of the token ID we're looking to finish is greater than 0. If it's not greater than 0, this means that the Chainlink VRF probably hasn't responded. So we'll say need to wait for Chainlink VRF. Cool. So we're checking to see if this has already been done. We're checking to see if this token ID even exists. And we're checking to see if a random number for that token ID exists. Perfect. Let's move on. So first thing we're going to need to do, we've done this checking bit. This is like, check. We did this first part, right? How do we, we'll go like this. Check. We did this first part. Let's even, we'll blank these ones, right? Check. Did the first part. Awesome. Now we're going to generate some random SVG code. So first we're going to need that random number. So we'll do uint 256, random number, and this probably should have an underscore actually. Yeah, okay, we'll do an underscore. Boom. We should probably do that for these two, but whatever. It's not a big deal. You know, you can use kind of whatever code conventions that you want, but yeah, ideally you do underscores for those. But anyways, finishment. We're going to need to get this random number from token ID to random number. Right? That mapping that we used up here, we're going to use that again to just grab this random number back. And now we have this random number, and we can use this as our seed to generate some SVG code. So let's do that. We'll do string memory SVG equals generate SVG. We, of course, don't have a generate SVG function, so we're probably going to have to build one. Once we do generate this SVG, again, we're going to do string memory image URI equals SVG to image URI SVG. And then once we have that image URI, we can go ahead and do string memory token URI equals format token URI, the image URI, right? So I know none of these functions are built yet. Don't worry, I'm just saying here's what we're going to do. We're going to get the SVG, turn it into an image URI, add that image URI to our token URI, and we're going to go ahead and set token URI of the token ID to this token URI. And then we'll go ahead, emit created random SVG. We're going to give it a token ID and an SVG. So we're going to emit this event that we haven't created yet. We'll go up here, event created random SVG. We'll give this a uint 256 indexed token ID and a string token URI. Okay, so I know none of these functions are built, and it's going, what are you talking about? Oh, and this is like this, this is like this. It's going, this doesn't exist, this doesn't exist, this doesn't exist, but this is essentially what we're doing, right? So this is going to generate some random SVG code. Then we're going to turn that into an image URI with this line right here. Then with this line, we're going to go ahead and use that image URI to format into a token URI, right? So these are the functions that are going to do all of that. So let's build these functions one at a time. The main one that we're going to focus on is generate SVG, right? Because SVG to image URI and format token URI are, what do you know? SVG to image URI and format token URI, right? These are going to be exactly the same. So we can copy paste them, or again, we could do the import thing, but we're not going to for this one. But if you're going to do this in production, you know, that's a much better method. But anyways, I digress. So let's create this function, generate SVG, and then as far as the code goes, we're going to be home free. So it's going to take a uint 256 random number. Of course, this is going to be a public view function, and it's going to return a string memory. We'll call it final SVG. So we've initialized this final SVG, and that's what we're going to save to. So how do we create this random SVG? Well, this is the million-dollar question here, right? So this is kind of the sample of how we're doing this stuff. Let's look back here and think how we want to do this. Well, let me even move this over. We're probably going to want a random number of paths. right? So because each one of these paths could be a different thing, right? We could make a red path here. We could do this like 0, 50, right? Run, get some different lines. Each one of these, we want these different paths to make different lines. So we're going to give it a random number of paths. This hypothetically could be an infinite number of paths here, right? To save on some gas, we're going to cut down on the number of paths. We're going to create a max number of paths here. So at the top, this is something that we're going to do, right? Because we don't want this to be like a billion paths here, a billion of these different types of lines. We're just going to say, we're going to create a uint256 public. We're going to call it max number of paths. In our constructor, we'll set this to something like 10. We'll say at maximum, we'll do 10 paths, right? The bigger this number, the more gas we're going to have to spend, because if we have, a ton of paths here, right? If this ends up being our code, this is going to be very expensive to put on chain versus this is going to be a lot cheaper. So we'll just keep it maximized to 10. Then inside of here, we're going to have all these D commands, right? Telling us what to do. Same thing, we could get something like, like this, which the more commands, the more expensive this is going to get as well. So we're going to want to create some maximum number of commands as well, maximum number of path commands. So additionally, with max number of paths, we're going to do uint256 public max number of path commands. And for now, we're just going to hard code it to 5. Max number of path commands equals 5. We're also going to want to pick the height and the width. So they have it to these. We're just going to do 500. We're going to create another variable here, and then we can even label this. We'll say these are the SVG parameters, right? Like so. We'll do a uint256 public size. We'll say size equals 500, right? So we'll default to 500, 500. We'll choose the path commands that we want to use, right? Because remember, we have all of these, but we're just going to keep it simple. We're just going to use just these two, move to and line to, because they both take only 2 parameters. So we're going to create a little string array called path commands. So we'll do string array public path commands. And you'll notice this isn't storage, or excuse me, this isn't memory, because this actually is in storage here. So we'll have this path commands up here. And ideally, we probably would want to make this immutable to save on gas. But again, you do gas optimizations another time. And down in our constructor, we'll do path commands equals m, comma, l, because we only want to do the move to and line to. And let's also parameterize some of these different stroke colors, like blue, red, etc. So we'll create one more string array, public colors, and we'll do colors equals, we'll do red, blue, green, yellow, black, and white. So these are going to be the max number of colors, the max paths, the size, the max commands, and all this stuff. We could hypothetically go insane with this, right? And make this, way bigger. We could make more paths, more commands, more path commands, more colors, whatever we want. And it would just increase the number of variations that we can get. With this right here, we already have a ton of variations that we can get, because we're going to be choosing some random number of paths with some random parameters, with some random colors. We're already like millions and millions and millions of different combinations here. So I'm happy with how random this is going to be. Now that we've identified the types of commands that we're going to use for this SVG, let's go ahead and generate some of this SVG stuff. So first, let's get the number of paths that we're going to use, right? Let's use this random number to pick a number of paths. A uint256 number of paths. And the way we're going to get this number is by taking our random number and doing this mod function. So we're going to do random number mod max number of paths plus 1 so that it always has at least one path. What this mod function is going to do is it's going to do what's called, modulo arithmetic. So let's say, you had 100 divided by 10. Well, 100 divided by 10 is going to be 10. This divides evenly. There's no remainder. So 100 mod 10 is going to be 10 would be equal to 0. However, if we were to do like 100 divided by 11, or excuse me, sorry, 101 divided by 10, we would get like 10 point something, and the remainder would be 1, right? These divide evenly, but there's going to be one that doesn't divide evenly. So 101 mod 10 is going to be equal to 1. There's one remainder. There's one left over, right? Similarly, 102 mod 10 was going to be 2. However, 110 mod 10 is going to be back to 0 because these divide evenly. So that's how the modulo function works. And that's how we can pick a random number out of our max paths to get kind of what we're going to get, right? So our max paths is what? It's 10. So we're going to get between 1 and 10 here. 1 and 10 paths. And that's how we're going to get our random paths. So now that we have the paths, right? Let me just undo all this. Now that we have the number of paths that we're going to get, let's go ahead and start, building this SVG. So we're going to do final SVG. Again, it's already been initialized with our little returns function here. Final SVG is going to be equal to a string that's going to start with, again, what do we do for this one? It's going to need to start with this SVG tag XML and S and this, XML and S, this thing right here. So I'm literally going to copy that, go back over here, paste it in. And we're going to want to take these double quotes and turn them into single quotes for the solidity here. So yeah, so anything inside of these double quotes is going to be single quotes, right? So these are all going to be single quotes instead of double quotes. And then we're going to say, inside this little SVG bracket, we're going to do height and width. So height is going to be equal to, we'll do another single quote here. And we're going to do a little comma, because we're going to do some string concatenation here. Comma, size, right? We want this to be 500. However, size is a uint 256 and not a string. So we're going to actually have to create a function called uint 256 to string. And I'm just going to copy paste that. I'm not actually going to show you guys how to do that. I copy pasted this from Stack Overflow, so I'm literally just I'm not going to walk you through this. This is the function I'm using from uint to string, and we're going to wrap this size into uint to string. Link in the description on how to get this function here. There's a Stack Overflow question. If you literally just Google convert uint to string in Solidity, you'll come across this. It has this function here, which is what we're using. And yeah, use this. So copy paste it into your code. I think ideally this will eventually turn into a library, but for now, just copy paste it. Uint to string of the size. We're going to go back to some string stuff here. And then I'm going to turn on, turn toggle word wrap on just so that it wraps around and it's a little easier to see. But these are all still on the same line, as you can see kind of with VS Code here. So we'll do a comma here. So we'll just do a width equals, we'll do a single quote, close that off, comma, again, uint to string size, comma, we'll start back the string up, and then we'll close this bracket like this. So of course, since we're doing this string concatenation, we're going to do avi.encode packed. Open and close bracket like this, little semicolon there. This is just going to be basically this first line, right? With that XML and S equals, whatever, blah, 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 blah. So cool. We have this first line here. We're going to need to add the paths. We're going to need to add the closing tag. But for now, we have the first line. Great. Now what are we going to do? Well, we're going to loop through this number of paths, and we're going to generate a random path from, again, this random number. So to loop through this, we're going to do a for loop. We'll say for uint I. We're going to start with 0. I is going to be less than number of paths, I plus plus. This is how you do like what's called a for loop in computer science. You can just Google like what is a for loop if you're unfamiliar with this. But now we're going to generate a random path for each path. However, I want a slightly different random number for each one of these paths. Otherwise, it might generate the same path for every single one. So what we're going to do is we're going to use this expand concept, which you can actually learn about again in the best practices here, how to get basically multiple random numbers from a single random number. So we'll do something like uint 256 new RNG equals, we're going to do some crazy stuff, uint 256 keckac 256 abi.encode, not encode packed, random number I. So I know you might be saying, what the heck is going on here? Basically, we're hashing this keckac 256 as a hash function. We're hashing this random number mixed with the path number that we're on into a new number, casting it as a uint 256, and saying, hey, this is our new random number. This is fine because nobody can snoop this, right? Nobody can say, oh, I know what this randomness is going to be. You know, once we return the random number, it's already decided, it's already deterministic what that's going to be, and nobody can snoop this. So this is a case where doing something like this is okay. You wouldn't want to do this, a method like this, on just the create function, because then some people could brute force and cheat and do some very nasty things. So once we have this new RNG, what we can do is we can generate the path with this new RNG, right? Because we're using one random number to get the number of paths. We're going to use another random number to generate the path itself. So we're going to do string memory path svg equals generate path. Yes, we're going to create a new function, and we're going to pass it this new RNG here. And once we get the path generated, we're again going to do final svg equals, and we're going to concat this new path with our svg. So we're going to say string, abi.encode packed, because this is how we concat in Solidity, final svg with the path svg. So once we generate the path, which again, we're going to define this in a second, we concat them together, and we do that for all the different paths. Once we're done, we're going to add a closing tag, right? So once we've made all these paths and added them, we're just going to add this closing tag, and then we're done, right? So then we can do final svg equals string. Again, we're going to do some concatenation, abi.encode packed, final svg, comma, and we're just going to do a closing svg tag. Whew! And this is what's going to get returned, right? Because in our function declaration, we said we're going to return some variable of type string memory called final svg, and boom, it's going to be right here. All right, so now we just have to create this generate path command. And I got a hint for you. We got to do one more function after this, but we're so close. We're right there. So we're going to do function. Let's define this generate path. This is going to take a uint 256 random number, and what's this going to do? It's going to be a public view that returns a string memory path svg. Beautiful. And we're going to do something really similar to this generate svg code. But we're going to focus just on generating the path piece here. So first thing we're going to do is we're going to pick how many commands that we want, right? So we picked the number of paths. Now we're going to pick the number of path commands inside of our path here. So we're going to do uint 256, number of path commands, equals random number mod max number of path commands plus 1. We're going to use the exact same methodology here. We're going to start our path SVG with this bit right here. Boom. So I'm even just going to copy this. Equals this. And of course, we're going to turn this into a single quote. And then once again, we're going to do a for loop through this number of commands, number of path commands. So we're going to do for uint I equals 0. I is less than number of path commands, I plus plus. And let's get into it. So we'll do string memory path command equals generate path command. And yep, you guessed it, we got another function. This is the function that we're going to have to make. But before that, once again, we're going to create a new random number. So we're going to do uint256 new RNG again, which is going to be equal to this uint256 kekak 256 abi.encode random number, comma, and we'll do size plus I, right? So this random number will be different than this one because we're going to hash that random number with the size plus I, right? So it's something totally different than what we're hashing with up there. Great. And then we're going to take this new RNG, pass it to a function we have yet to build called generate path command. Oh, do I spell this wrong? Kachak, excuse me. Generate path command. Once we have this path command, once we have this random path command, we'll do path svg equals string abi.encode packed path svg, comma, path command. Okay, so once we have all the commands put together, we're going to add fill transparent and then a color. We'll do string memory color equals colors underscore random number random number mod colors.length to get that random number, or excuse me, to get that random color. And then we're going to put it all together. So we'll say this path SVG, right? This whole path is going to be, start with this, add those path commands, and then we're going to add this, the fill, and the stroke color. So path SVG is going to be a string. We're going to concatenate some string stuff, encode packed, path SVG, comma. We'll do the single quotes inside of some double quotes. Fill equals transparent parent. Stroke equals, and here's where we'll do comma. We'll do that color that we just created. And then we'll do the double quotes, single quote. We'll close this off. Okay, and this path SVG will get returned because, again, in our function declaration, we're saying, hey, a variable named path SVG is what you're going to return. So we have one more command we got to do. This generate path command. So we'll do function, generate path command. You might start to suspect what this one's going to look like. This is going to take a uint256 random number. This again will be a public view, and this is going to return a string memory path command. This one's going to be a little bit easier, all right? So we're going to grab our path command by doing, once again, our mod function, right? We're going to look at all these path commands, which we only have 2. We're going to do exactly what we did with colors, and we're just going to randomly pick one of the 2 using the mod function, right? So this is index 0, this is index 1. Sorry, I didn't explain what we did with the colors, but we modded it to get a number between 0, 1, 2, 3, 4, 5, between 0 and 5. And if it's 0, it's red, 1 is blue, green, yellow, black, etc. So we're going to do the exact same thing down here. Path command equals path commands, random number, mod, path commands, dot length. Once we have a path command, which again, it's just going to be M or L, what are we going to do? Well, we're going to have to get some random parameters to add to it, right? Like how in here, this has the M has 150 and 0, L has 75, 200, some X and Y coordinates for these. So we're going to do uint256 parameter 1 is going to be, once again, we're going to use this random number to create another random number. So we'll do uint256, check 256, abi.encode, random number, and we'll do size times 2 or something like that, right? And we'll mod this by the size, because we don't want these parameters to be bigger than the size, right? So our max size right now is 500. If this went to like 5,000, our SVG code would be like, what are you talking about? This is only 500 by 500. So we're going to do the same thing. I'm literally just going to copy this line for parameter 2. But I'm going to do size times 2, or size times 3, just so that these are different. So this will be times 2 times 3. We'll call this parameter 2. And now we'll get the path command. And now we'll set the rest of this path command. We'll say path command. It's going to be string abi.encode packed of itself, path command, comma, space, right? Because we're going to do a little space in between these parameters. Again, we have parameter 1, parameter 2, but they're uints. We need to make them strings. So we're going to do uint to string parameter 1, comma, another space, uint to string parameter 2. And that's going to be all of our path commands here, right? And our generate path is going to go ahead and close off, the path, add the fill transparent stroke and all that stuff. And oh my goodness, that is a lot of code that we just wrote. That is a lot of code. So awesome though. Generate SVG is going to generate some paths, generate some random path commands. And oh my goodness, we have a way to generate some SVGs. This is going to be some SVG that looks just like this triangle thing, right? Or just like this right here. Once we have this, we can do SVG to image URI and format token URI. And guess what? I'm just going to copy paste. So SVG to token URI. If you didn't watch the original part of the video, just check out the GitHub that we're working with and copy this, because I'm not going to go over it again. So we're going to paste this this function SVG to image URI, and I'm even just going to delete these giant comments because it's making our code a little bit less readable. We are doing this base 64 stuff, so similar to this first contract, we are going to copy this import bit, import base 64 -sol, right? So we can do that stuff, and then this is completed. Now we just got to copy this format to token URI function, which, boom, is right here. Add it in. We're going to delete this guy. We're going to format this a little bit nicer. Move this back here. And oh my goodness, we have everything. Holy mackerel. Does this even compile though? Let's hope so. I'm praying it compiles. It doesn't compile. Where did I mess up? Compilation failed. Wrong argument count for function called. 3 arguments given, but expected 1. I missed a closing parenthesis here. And I think we're good. Hard hat compile. And I had an extra one here. So this should just have 3 over here. Let's try this now. Oh my goodness. We have compiled. We have done it. Now we just got to write some deploy scripts. Let's do this. So we have our deploy SVG NFT. We're going to do a lot of similar stuff that we did in here. Luckily, we've already got our hard hat config set up. We've got some env set up. We're good to go. So let's go ahead. New file. Say o2 deploy random svg.sol. Okay, and let's get to work on deploying this. All right, so we're going to start exactly the same way. Module.exports equals async, like this. Get named accounts. This is how we're going to get those accounts. Deployments. This is how we're going to do all of our deployments. And get chain ID, which is important for getting a chain ID. And this is not a Solidity file. This is a JavaScript file. See, I didn't want to do JavaScript so bad. I just would rather do Solidity. Anyways, we're going to start this out the same way. So we'll do const deploy. We're going to add this new thing called get. We'll talk about that in a minute. Log equals deployments. We'll do const deployer equals await get named accounts. Const chain ID equals await get chain ID. Right, really similar start here. Now we have to do a couple of different things here though. So in here we said, okay, cool. Now let's deploy, right? However, in this new contract, in this new SV or random SVG, when we deploy, we're passing some arguments, right? In our constructor, we're passing a VRF coordinator, a link token, a key hash, and a fee. And these change chain to chain. So we're going to need a way for us to, when we deploy, for us to know which of these that we're working with. Now, I'm going to kind of quickly go over mocking. I'm not going to go too deep into it, but if we are on a local chain like hard hat, what is the link token address? What's the link token address? Well, the answer is there is none. So what we're going to do, so what we do is deploy a fake one. So we deploy a fake one for our local chain so we can test and work with it. But for real chains, we use the real ones. So that's what we have to do. When we're working on our local hard hat, we're going to deploy a fake link token. This is called mocking. And if we're going to work on a real chain, we're going to use the real token. Okay? So let's do that. So first we're going to say if chain ID is equal to 31337, then this means we are on a local chain. This means we're on a local chain and we want to go ahead and deploy and work with some mock tokens, right? A mock VRF and a mock link token, right? Because this contract, VRF coordinator, won't have been deployed. This link token also won't have been deployed. So we're going to deploy mock versions of that. Typically, I put all my mocks in a different deploy script called 00 deploy mocks.javascript. And I have some stuff in here that says, okay, are you on a local chain? If yes, this is the script that will deploy those fake contracts. So before we get into deploying our random SVG, we're going to deploy some mocks. So we are going to start this the exact same way. Module.exports equals async. Boom. Get named accounts. Deployments. Get chain ID. And let's do it. So we'll do const deploy, comma log. We'll grab those from deployments. We'll do const deployer from await get named accounts. And then we'll do const chain ID equals await get chain ID. So now, same thing. We're going to say if chain ID is equal to 31337. If we're on that hard hat, local hard hat network, we'll do a quick log, local network detected, deploying mocks, and we'll go ahead and deploy that fake link token and that fake VRF coordinator mock. So these are contracts that we're going to have to deploy, a link token contract and a VRF coordinator contract. Right now, we don't have those in our contracts folder, right? Right now, if we look in contracts, there's nothing in here. Normally, what people will do is they'll create a new folder called test or tests, and that's where they'll go ahead and add these bits in. I know that I can just pull a link token contract right from a chainlink/token package. So I'm just going to do this link token.sol. You can grab this test folder from there's a hard hat starter kit on GitHub right here that has in its deploy folder, in its contracts folder, it has a test folder. You can literally copy paste these. That'll work perfectly. or you can just follow along, do it like this. But literally all that's going to be in here is SPDX license identifier MIT. We're going to use the original link deployment, so we'll do pragma solidity caret 0.4.24, and we're just going to do import at chainlink /token /contracts /v0 contracts /v0.4 /link token .sol, and that's all we need. This is going to import this link token contract that has all the link token stuff in it. We do, of course, need to add this then. Yarn add at chainlink /token so that this will work. And since we're using this 0.4 version of Solidity in here, we'll go to our hardhat config. We'll scroll to the bottom. Right now we only have one version of Solidity. We're going to go ahead and change that. We're going to turn this into a little bracket here. And we'll say compilers. And we'll give it a list of compilers in here. So first version is going to be version 0.8.0, comma, version 0.4.24. I know that we're actually going to use a couple different versions, so I'm just going to put them in here now. Version 0.6.6, comma, version 0.7.0. We're going to save, and this is how you can have compilers, across different versions in your hardhat stuff. So, boom, lovely. So we've imported the link token. Perfect. Now we're going to do the same thing for the VRF coordinator or the VRF coordinator mock. So we'll do new file, VRF coordinator mock.sol. And we're going to do the same thing, SPDX license identifier MIT, pragma solidity. This one's going to be caret 0.6.0 or 6 or whatever you want to do, or 0, whatever, it doesn't matter. And then we're going to do import. This one's actually going to be at chainlink /contracts /src /v0.6 /tests /vrf coordinator mock.sol. And that's all we need. And don't worry about if your linter freaks out here. Don't worry about it. But that's all we need. Since we're going to import these contracts, this is the same as just plopping this entire contract into this file. So now we have both a link token and a VRF coordinator mock. But they're also separate from kind of our main contracts, and we know, okay, these are really just for testing. So in our deploy mocks, now that we have those contracts, we can go ahead and deploy them. So we'll do const link token equals await deploy link token.
In case you missed it, we will be pre-screening this set of courses.
And then we're going to deploy the VRF coordinator mock. We'll say const VRF or VRF coordinator mock equals await deploy VRF coordinator mock, comma, from deployer logs true. And this one actually does take arguments. We can see if we go to GitHub, chainlink contracts, src v0.6 tests VRF coordinator mock. You'll see in its constructor, it takes the link token address as its parameter. So we'll do that by doing args, and we'll just say link token.address. That's how we pass the address in. And that's really all we have to do. Log mocks deployed. And then we're going to want to do this one last thing at the bottom, module.exports.tags. And we're going to add all RSVG an SVG. What these tags will allow us to do is when we actually deploy, any deploy script that's tagged with whatever tag we give it to do that, right? So if we did hard hat deploy -- tags SVG right now, all this would do would be deploy mocks. And actually, this is a good way to test to see if it's working. It looks like it's not working. Looks like I spelled link token wrong. Token. Try that again. Tags SVG. And perfect. This is exactly what we've done, and that's all we did. Because this only ran the deploy mocks script, because right now, deploy mocks is the only one with this SVG tag. I don't believe we added that in here. We'll add that to our deploy SVG in a minute, but this is kind of a really nice feature for working with this deploy thing. Anyways, so now we have some mocks deployed in our deploy mocks. Now we can go back to our main, O2 of deploying this randomness thing. So if we're on the local chain, we're going to want to use those mocks that we deployed earlier. And this is where this get thing is going to come in. So we're just going to say let link token equals await get that link token that we already deployed. Right? Isn't that convenient? We're just saying, hey, just grab it. We already deployed it. Just go get it. Same thing with VRF coordinator mock. It's going to be await get, you guessed it, VRF coordinator mock. Cool. And that's it. So that's all we have to do. Now, if we're not on a local chain, we're going to need to get the link token address and the VRF coordinator address. So outside of this, we're going to initialize those variables. We'll say let link token address, comma, VRF coordinator address. And in here, we're going to say link token address equals link token.address, VRF coordinator address equals VRF coordinator VRF coordinator mock.address. If we're not on a local chain, if we're on any other local chain, we're going to need these values stored somewhere. Where do you think we could find those? Oh my goodness, Patrick, I remember we have a helper config that does exactly this. So what does this look like? Well, if we're on a local host, we don't need the link token and the VRF coordinator. If we're on Rinkeby, we are going to need those. So we'll go to contract addresses of using randomness. We'll go down to Rinkeby. We have a link token and a link coordinator. So we'll grab this, we'll copy this link token address. And for network 4, we'll say link token equals, or excuse me, link token is going to be, boom, that right there. VRF coordinator. And we have the link token and VRF
trying to make a GDI for the stream,
we'll grab
but
this
not
network
working. I don't
config
know.
object, right? By at the top of this, we'll say let network config equals require / helper hardhat config. Now we'll have this network config in here, and we'll say else link token address is going to equal to this network config at this chain ID's index of link token. And we're going to do the same thing for the VRF coordinator address. So we'll copy this, paste it here, and this will be VRF coordinator. Now we got to add, of course, the key hash and the fee. Now, if we're on a local network, these don't really matter. So we don't have to do this kind of if stuff here, right? We can just do const key hash equals network config chain ID key hash const fee equals network config chain ID fee. And in our helper config, we're going to do key hash, which again We're going to grab from right here, chain link documentation. We'll grab that key hash, pop it in here. Oops, I need a comma right here. And then we'll do fee, which we're going to do 0.1 link, which is going to be 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which again, this is in, this is in joules / way, whatever you want to call it. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. That means the decimal place is right here, right? So this is equivalent to 0.1 link for this. Perfect. Now, I usually just copy paste these two for the local host because, again, for localhost or hard hat, it doesn't matter. So now we have the fee. Now we've got all this stuff here because this constructor takes all these arguments. I'm just going to combine them together into a variable called args. And I'm going to say args, or let args equal this list, vrf coordinator, vrf coordinator address, link token address, key hash, and fee. And we're going to deploy these the exact same way we deploy to everything else. So I like to do a little log here saying, hey, let's get it started. Let's get it started. We'll do const random svg await deploy. And I know I'm oscillating between single and double quotes here. Random svg, comma. We'll do the args here. So we'll say again from deployer. Args is going to be this args list we just made, the arguments, and we're going to say log true. So this, if we just do hard hat deploy, now it's going to deploy everything.
I used hard hat when I made my script. It was
SVG NFT.
It was a little bit involved, more than involved.
If we
it took
just
me
want to
14
deploy
hours
this
to do my
random
first
NFT,
smart contract using Solidity,
and all the random NFT
hard
stuff,
hat,
including
JavaScript,
mocks, we can just add this
Node.js.
tag here to this deploy script. So we do exports.tags equals, we'll say all, and rsvg. And then while we're here, in our O1, we'll do module.exports.tags equals, we'll say all, and just SVG. So 0.1 will be SVG, 0.2 will be RSVG. So we can do hard hat deploy --tags RSVG, and this will deploy the mocks because these have the RSVG tags, and it'll deploy our RSVG. So let's go ahead and run this on the hard hat network. We'll see if this works. We're running into an issue. Deploy script.func is not a function because this is module.exports, not export. Whoopsies. Let's try that again. Hard hat deploy --tags RSVG. Chained ID is not a thing, so let's make this chain ID. Let's try that again. Got another error in here. What's it saying?
See how easy it is to make little errors? That's where I'm
Let's
at. I have one little error, and then I can do it.
Tired here.
I just need some coder to be nice enough to fix the code because I can't figure it out. I do not know how to do it like that.
Are we done?
These guys are professionals.
Absolutely not. We're just getting started. So we'll do log. You have deployed your NFT contract. Yay. And once again, we'll do that verification process. So we'll do const network name equals network config, chain ID, name, and then we'll do log, verify with /m mpx hard hat verify -- network name, network name, random svg.address, and we're going to do some fancy stuff because then we have to add all the arguments. But we're going to do args.toString, so it's going to take this list up here, turn this into a string, but we're going to then replace, this is with a little regex here, replace all the commas in that string with spaces. So that'll say, hey, this is how you're going to verify it. We'll even run this again to make sure it works. Yep, verify with npx hardhat. This is the contract address, and here are all the arguments for the constructor. Okay, cool. And now we're going to want to interact with this contract, right? We're going to want to call the create function. We're going to want to fund it with link. So we're going to want to interact with this random SVG. The first thing we need to do, though, is we're going to need to fund this contract with some Chainlink token in order to use the Chainlink VRF. So
you can get free F on a test network, but
link. So we'll say let network ID.
Works.
We're going to do await. So we're going to
really
fund it with
into that. Where to get it, the right place,
amount, right? That's
et cetera, blah blah blah.
Maybe double it. Maybe that times 2 or something. We'll just go with the fee for now. So in order to do this, we're going to have to do const link token contract equals await ethers.contract. Excuse me, await ethers.get contract factory of the link token. And then it's probably going to, yep, it's going to do that. Don't let it do that. Don't let it import ethers for us here.
Oh my God.
Accounts equals await hardhat runtime environment. Hardhat runtime environment. Don't do headers, please. Okay, you're going to do headers. Hardhat runtime environment dot ethers dot get signers. Call it signer.
Soaked with oil.
Signer equals accounts of 0. Then we'll do const link token equals new ethers dot contract of the link token address, link token contract dot interface, and the signers. Excuse me, and the signer.
Yes.
And what we're going to do is we're going to do let funding transaction equal await link token dot transfer. We're going to send rsvg dot address that fee amount. We're going to do fund await fund transaction dot wait. We're going to wait for one block to happen. Great. And now our contract will be funded with link. And that's all we have to do. All right, next. Now we're going to create an NFT by calling a random number. We're getting so close. So let's get our contract here. We'll do const random SVG contract equals await ethers.get contract factory random SVG. We can just do const random SVG equals new ethers.contract random SVG dot address random SVG contract dot interface and then signer. And now we can just do let creation transaction equals to random SVG dot create. I'm also going to pass a gas limit. I know we haven't done that in the past, but we're going to want to pass a gas limit here of 300,000. And we'll do creation tx dot wait for 1. And we'll say let receipt equals creation tx dot wait. So we're waiting for this transaction to go through. Now we are going to do something special with this receipt here. With this receipt, we're going to grab the token ID, and you're going to see why we're going to need that in a minute. So in our random SVG, remember how we emitted some events, right? On our create, we emitted an event that had the request ID and the token ID, both of them being indexed. So I know that in this receipts logging or in its events, from its topics, aka its indexed events, I can get that token ID from this transaction receipt. So I can do let token ID equals receipt.events, and I know that this is the fourth event because I know the Chainlink code also emits a whole bunch of events. So if you're working with other imported contracts, you just need to keep track of if and when they emitted events. But I know, and excuse me, topic 0 is always going to be kind of the hash of this whole thing. Topic 1 is this one, and then topic 2 is this token ID. So I can do .topics 2. We're also going to use, but now that we have this token ID, what we can do is we can do a quick log and say, you've made your NFT. This is token number, and we'll do token ID .toString, and then we'll say log. Let's wait for the Chainlink node to respond. Because remember, we do have to wait for that second transaction to happen. Now, if we're on a local chain, there is no Chainlink node, right? So if we're on a local chain, we're just going to pretend, we're going to mock that there's a response. So we'll say if chain ID equals, actually we'll do it does not equal 31337, which again is, we're saying if it's not a local host, we're going to do some stuff. Otherwise, we're going to do some other stuff. So I'm actually going to start with the local host stuff, even though it says, even though this looks kind of backwards. So else, this is saying if we are on a local chain, right, what do we want to do? We're going to say const vrf coordinator mock equals await deployments dot get vrf coordinator mock vrf coordinator equals await ethers dot get contract at vrf coordinator mock comma vrf coordinator mock dot address comma signer, using that same signer we're always using. And what we're going to do is we're going to pretend to be the VRF node ourselves. So if we're on a local chain where there is no Chainlink node, we're going to say we're going to be the Chainlink node. We're going to be this dummy Chainlink node. So we're going to say let vrf tx equals await vrf coordinator. And now we're going to pretend to be the Chainlink VRF node and return this response back to our smart contract. So we can actually go check out this contract on GitHub, this VRF coordinator mock. Again, contracts, Chainlink contracts source v6 test VRF coordinator mock. And the function that it actually uses to return through that VRF coordinator and return the random number is this function callback with randomness. So we're going to pretend to be the Chainlink node and call back with randomness here. So we're going to give it a request ID, a random number, and the address of our consumer contract, which in our case is our random SVG. So we're going to do that by .call back with randomness. And we're going to have to pass the request ID, randomness, and consumer contract. So the same way we got the token ID, right, in here, in our random SVG, we also are indexing the request ID right here. So we can grab this from the topics as well. So we'll do callback with randomness. I'm going to turn toggle word wrap back on. Receipt.logs, the fourth event or the fourth log, which I know up here we did events, but I just kind of want to show you that you can do events or logs. They're the exact same thing. Like I said, we know that this is the fourth log, aka the third index log or third index event. Dot topics and 1, right? Because the first index topic is always going to be the event itself. So the 0th index is the event itself, and then the first topic is going to be this request ID. Great. So that's the request ID. We'll give it a random number. In this case, we'll do 77777, right? Or whatever we want. And then we're going to pass it back to the random svg.address. Then we'll do await vrf tx.wait 1 And then our random number will have been returned, right? So at this point, this function fulfill randomness will have been done. That token ID will now have a random number associated with it. So we can go ahead then and call this finish mint function. So we'll do a quick log saying, now let's finish the mint. And we'll do let finish tx equals random svg dot finish mint. And we need to pass it. We need to pass the token ID that we just created, which again, we're getting from up here. So we're going to pass the token ID. And this one, we're also going to need to add a manual gas limit. Otherwise, it might break. And yep, we're going to do a big number. We're going to do 2 million. So 2, 1, 2, 3, 1, 2, 3. 2 million for the gas limit. Then we'll do await. Finish tx.wait for it to be included. Oh, and this should also be an await. Excuse me. Wait. And then our token URI should be complete, right? Because this finish mint, once this function goes through, should return us a token URI for that token. So then we can do log. You can view the token URI here. And await random svg dot token URI of token ID, right? Or 0. And that's it for us kind of mocking or pretending to be the Chainlink node. So this is going to be everything that we're going to need to do now is hardhat deploy -- tags rsvg, and we'll see if we did this little script right. And it looks like we didn't. Get contract factor is not a function. Factor re, that should be a function. Let's try again. This should also be factor re. Let's try this again. And whoops, we should not be doing this require. My VS Code was a little aggressive and just kept pulling that in. So let's try this one more time. Creation tx.wait is not a function. We probably just, yep, we need to await this here. And then we also need to await creation tx.wait. I'm going to add all these fun little awaits in here. And we have another issue. The RF coordinator mock is not defined. Coordinator mock, how about that? That one defined? Yep, that one looks like that's defined. Couple typos. And bada bing! So we're gifted this output here. So we're saying verify with this verify. Again, I needed to make this a little bit nicer, but it's fine. Let's wait for the Chainlink node to respond. Now let's finish the mint. And here is our token URI. So if we grab this, paste it into our browser, we do indeed see the metadata pop up. And we'll pop our image URI in here. It looks like we had an issue. Error on line 1 at column 614, opening and ending tag mismatch, path line 1 in SVG. So if you get something like that, it means that we did something wrong. Right here. This actually needs to be a backslash instead of just a closing point here. So let's go ahead and fix that. We'll go ahead and rerun this. Hardhat deploy -- tags. All right, let's try this again. We'll grab this token URI. We'll paste it in here. We'll see if this image URI looks good. We'll copy that. And boom, we have a random SVG created. Obviously, this is pseudo-random because right now we're just always using 777, but it's a good way to test locally, what this is going to be. Now that we've tested this locally, we know that this is going to work. We'll add our code to do this on a real chain. And it's going to be pretty much the exact same as this, except we're not going to have to do any of this mocking stuff. So the first thing that we need to do is we need to actually await for the Chainlink node to respond, right? We could add like a subscriber that listens for events. We're just going to take the dumb approach here and just wait some number of seconds. So the last time I tested this, Rinkeby was being really slow. So we're just going to wait an obnoxious number of seconds to make sure we give it plenty of time. So we're going to do await, new promise, r set timeout, r comma 18, 1, 2, 3, 18, 0, 1, 2, 3. This is basically time.sleep in Python. and we're going to wait for 180 seconds. We're just going to give the chain link node plenty of time to respond if we're working on a real chain. Then, once we do that, we'll say log. Now let's finish the mint. 2, 3. Similar to what we did down here. And then we'll do let finish tx equals await random SVG, let finish mint, token ID, comma. Again, let's add this gas limit in here of 2 million. And then we'll do await finish tx dot wait of 1 block. And then this should be all done, right? This is a lot easier, obviously, because we're not mocking on our local blockchain, right? This is just like, hey, we're just interacting with the chain straight up. So now we can just do log. You can view the token URI here. Await random SVG token URI of 0, or excuse me, token ID. And that's it. So now we have all of our code in here to actually deploy this to a testnet and to a mainnet. So let's go ahead and do that, right? So in our hard hat config, we already have all of our Etherscan stuff, all of our RinkB scan, or excuse me, Etherscan stuff, and all of our RinkB stuff. Our MetaMask does indeed have ETH, but remember, we will need some testnet RinkB link as well to work with the Chainlink VRF. So again, just Google link token contracts, and this we can always find the latest faucets on this page. We'll just look for RinkB here. Great, testnet link is available here. Boom. All I got to do is grab my address, pop it in here. I'm not a robot. Send me a 100 test link or whatever it is, and we'll be able to see it in our MetaMask. If you don't see it in your MetaMask, it's because you probably didn't add the token. What you'll want to do is you'll want to take this address here, copy it. In here, you want to hit add token, paste it in here, and link will show up. And I've already added it, so it says token already has been added it. But once you do that, link will pop up here with all your link. Once we have our link and our Ethereum and our RinkB, we can just go ahead and deploy this the exact same way. So we'll do a hard hat deploy -- network RinkB -- tags RSVG. Now, since we're doing tags RSVG, it won't deploy our deploy SVG NFT, our other project, right? Because the tags aren't in RSVG, it's just SVG. The other thing it won't do is it won't deploy mocks. And this is really good because we don't want to have to waste the gas deploying the mocks here. This is because, again, in this our deploy mock script, we're just saying if it's on a local chain. That's the only time we're deploying the mocks. So let's go ahead. We'll deploy this to RinkB. So we are going to have to wait a little bit. So now's a good time to go to the bathroom, grab a cup of coffee, or something like that. You're doing a number of things, right? We're first going to deploy our random SVG contract. Then we're going to fund it with some link token to work with the Chainlink VRF. Then we're going to request that random number by calling the create function. We're going to have to wait a few minutes for the Chainlink node to respond. And once it does respond, we're going to call the finish mint function. And once it's done, you can view the token URI here, and we should be able to pop that address of the token into OpenSea and see it on chain, which is incredibly exciting. And woo, after some time, we do indeed see this massive URI here. And we're saying, hey, it's been responded. So we know that this is the token URI that's actually on chain. So we can grab this. Let's copy this, paste it into our browser. Okay, we do indeed see some stuff here. We'll grab that image URI. We'll paste it in. And we see this. And we know this is somewhere on chain. So I can go back to my output script here. I can verify the contract if I want to. I'm not going to bother for now. Deploying random RSVG to here, deployed at here with this much gas. Now we can go to testnets.opensea.io, paste that address in here, click here. We can see there's one result. Looks like there's nothing here right now. Let's go ahead and refresh the metadata. And after we refresh the page, we do indeed see our completely randomized image here. This is so exciting! Now, if you want to take a break, now's a great time to take a break. However, I am going to show you how to actually deploy this to a real blockchain, because we are going to deploy this, to the Polygon chain. Now, to deploy this to the Polygon chain, all we have to do is add some network information for Polygon. That's it. Everything else stays the same. We do also have to do it in our helper config. So these are the two files that we have to change to add this. But before I do this, I want to talk about two other important things and two questions that I get asked a lot. The first question is how to sell the NFTs and set the price. So this is the first question that we're going to answer. How do we set the price of these NFTs before we actually launch this on a real chain? Well, if we go back to our randomsvg.sol, is right now anybody can call this create function. We can change this though, so that there's a fee associated with this create function. So what we can do is we can add a little require here. We could say require message.value, and message.value is how much people actually send, is greater than or equal to some price, right? Some price that we set. And I'm gonna just say price, and then if they don't send enough money, we're gonna say need to send more ETH. So we need to define this price variable. So we're going to make this a global. We'll do uint256 public price. And right in our constructor, we could say price equals, if we wanted this to cost 1 ETH, it'd be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8. Right? We do something like this. Or maybe we'll get rid of a 0, and this will be 0.1 ETH slash Matic slash Ava X, whatever. This is going to be 1.1 of that. Let me just double check. Let me just double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. You could even add like a set price function or something, whatever you want, right? And that means in our O2 deploy randomness, we're going to have to change our create function. We do creation transaction equals random rsvg.create. We're going to have to do a comma, value of this much, right? So we're going to have to send this amount with it. And then we also have to make this a public payable function. Additionally, you're probably going to want to be able to withdraw this ETH. So we'll say function withdraw public withdraw. Now we only want the owner of this function to be able to do this, right? So we're going to add in a little only owner modifier. So we're going to do modifier only owner require message.sender equals owner, not owner if they're not the owner. And then add the rest of the code here. We need to define an owner somewhere. So right in our constructor, actually right up at the top, we're going to say address payable public owner. And we'll define owner equals message.sender. So whoever created this transaction, and then we need to do address payable. Owner equals message.sender. This is going to be a payable message.sender. And down back in our withdraw function, we're going to make this an only owner. And we'll say owner.transfer address this dot balance. And this should be public payable. So I know we just added this function in here so that we can pay. If you wanted, you could add like a function set price. That is an only owner function that changes the price. You can kind of do whatever you want. But for right now, we're just going to say, okay, price is always going to be 0.1 ETH. Now, in our deployment, we're just going to have to add this bit here, and we should be good to go. Let's just double check that this works. Run it deploy. Looks like we ran into an issue. That's right. JavaScript hates numbers, so we'll put quotes around it. Let's try again, and boom, looks like we're successful here. Yes, this is absolutely 100% something you should test and write tests for. Like I said, we're going to skip it for now, but something like this withdraw thing is really important to getting right, so definitely want to write some tests. So,
awesomeness.
Okay, cool. How to sell the NFTs and set the price. Boom! We just did that.
Wow.
Now, another question we get is how to mint 10,000. How do we mint a ton of these, right? Well, what we can do is what you could do is instead of having every single person have to call this create function, right? Right now, when users call this create function, they are the ones fronting the cost of creating the NFT. But what you could do is you could call this create function, and then you could have this create function mint all 10,000 NFTs using the random number from Chainlink, right? So remember how we did this? KCAC 256 ABI.encode random number I. Using this method, we could use this method, 10,000 times and get 10,000 random numbers. Just do a for loop behind all those random numbers, and boom, we'd be good to go. So how do we mint 10,000? Well, all you have to do is call this mint function, this safe mint function 10,000 times, right? So in our fulfill randomness, we'd get a random number, and in our finish mint, we would do like for uint a is less than 10,000, a plus plus, and you'd loop through that list, and you'd follow this through all 10,000 of those. So I know this is a little bit pseudocodey, but this is essentially how you would do it. So that's the next question. Final question I always get: how to deploy to a main network. Well, I'm going to show you how to deploy to Matic, and it's going to be the exact same way for deploying to mainnet. Exact same process. We're going to have to add a new network to our helper config, and then when we deploy, just change the network flag. So we're going to use Matic here. So we can find our details, or for Polygon, excuse me. We can do Polygon MetaMask, and we can find the details right here. So we're going to first grab this URL here, copy this, go into here, networks. We're going to create a new network, call this one Polygon. Polygon URL is going to be this URL right here. Accounts are going to be accounts, mnemonic. Oh, I did the double accounts again. Mnemonic. And we'll do save deployments as true. Boom. That's all we need to do for our hardhead config. Then we need to add some stuff in our helper hardhead config. So if we go to the Polygon documentation or Matic documentation, we can see URL. The chain ID is 137. So we'll do 137 here. Name will be Polygon. We need the link token, VRF coordinator, key hash, and fee. We can go back to the link token contracts. We'll scroll up to Polygon or Matic. Oh, excuse me. We'll scroll to our random place. Contract addresses. Polygon Matic is the first one, which is great. We'll grab this link token address. We'll do link token. It's this here. VRF coordinator is this one. So we'll say VRF coordinator is this right here. Key hash is here. So we'll say key hash is that right there. And then we'll do fee. It's going to be 0.0001. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. And then what is it? 1, 2, 3, 4. So we're going to do 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 3 zeros, 3 zeros. Perfect. So this is going to be 0.1231 link. And that's all we have to do. So of course, I'm testing with a mnemonic that doesn't have any link or any actual stuff in it, right? Because when I set this up in our hardhead config, I said, hey, don't do this with a mnemonic with any real money in it, right? Don't put in your .env file a real mnemonic. I'm going to go ahead, I'm going to add a real mnemonic as an environment variable just so I can deploy this script, and then I'm going to remove it right away. So I am going to pause recording as I do this. Now, actually, before I do that, I do want to point something out on working with Polygon and working with Link on Polygon. So Polygon has this thing called the Matic Bridge, which allows you to bridge your tokens from one chain to another, right? We can log in with MetaMask, and it'll allow us to swap tokens over. The thing is, though, the Polygon Matic Bridge isn't ERC-677 compatible. So the token that we get, we can't actually use with Matic. Once we get the Link token bridged over, we actually have to swap it using this peg swap application to swap it from the Matic version of the Link token to the real version of the Link token. You might be a little confused, be like, hey, why are there two Chainlink tokens in here? This address here is going to be the correct one, and the one that you get, you're going to want to use this swapper to swap it over. There's also a video on this in Link token contracts. Polygon, if this is confusing, you can watch this video. It has the whole thing as well. Oh, what do you know? That's me. I'm going to go off screen for a second, add my mnemonic in here so I can deploy this to Matic, and then we'll get it done. All right, I've gone ahead and added it as an environment variable. Let's go ahead and deploy this to a real chain with real money. So we'll do hard hat deploy -- network Polygon -- tags RSVG. And let's see if this works. And we actually got an error here. Cannot read toString of undefined. It looks like this took a little too long to actually make. And it looks like it actually got mad at me because my gas price wasn't set great. So these are some of the things that you will sometimes have to finagle with. So our create actually went through fine, which is good. But our finish transaction did not. So we added a gas limit. We'd have to add like a gas price. We're just going to add 20 Gwei as a gas price. So I know we're creating a whole bunch of random SVGs here. I'm fine to create a whole bunch. I don't really care. I think this will cost me a solid $3. So I'm not too mad about this. So if we see, we go down to token counter. We have 5 in here. So I minted a whole bunch, but I just didn't finish minting them, right? Because we ran into some weird JavaScript errors. And what we can do on Polygon Scan with our verified contract is we can just go down to this finish mint area. We'll go try to finish mint token ID 0. I'm going to edit the gas fee. Or excuse me, I'm going to edit the gas price to being 20 Gwei just to be crazy expensive, just so that we guarantee it's going to go through. We'll view our transaction now. And it looks like that increased gas cost did allow this to go through. And perfect. That means we were able to finish minting our 0th token. So it should have a token ID now. Now, if we go back, I'm going to go back to my regular browser now. Now, if we go to OpenSea, should be able to pop this address in here. And we do indeed see we have this random SVG in OpenSea. You can see we're now no longer on a testnet. We have some results in here. We'll go to token ID 0 because this is the one that we just finished minting. We'll refresh it, refresh the metadata, then we'll refresh the page. And we can see, aha, perfect. We have the SVG. This one's pretty lackluster. It's just a yellow line. We've deployed this to a real network for real money. Now, I know this was a longer video, and we went through a ton in this video, and I hope everybody here learned a lot about deploying NFTs, working with Hard Hat, working with Polygon, and everything like that. So definitely be sure to leave your questions in the comments. Definitely be sure to make issues on that GitHub repository if you have any other questions. Fork it, star it, share on Twitter, at me at PatrickAlphaC, and say hi. Whew, we went through a ton of stuff here. Now, to close off this video, I just want to give everybody an update with what's been going on. I've missed videos for about a month now, and we're getting very subscribers. So be sure to subscribe because at 10,000 subs, we're doing a tattoo reveal, which is going to be incredibly fun. So for those of you who've been missing, I've been working on a couple of really big projects, and hopefully very soon you'll see the fruits of that labor. Up to date with the latest and greatest smart contract coding tools, resources, and everything to make you an insanely powerful smart contract engineer. So don't worry, I didn't go anywhere, but there is a fantastic video coming out very soon, and that video will be back in our favorite Python. Hope everybody learned a lot. Be sure to like and subscribe. Let me know in the comments what you next, and we'll talk to you then.
Welcome to the beginner's course on how to build 12 data apps in Python with Streamlit. My name's Chanin Nanta Senamat, and I'll be your instructor for today. Some of you might know me as the Data Professor from my YouTube channel, Data Professor, where I teach data science, machine learning, and also provide a bioinformatics project walkthrough. Aside from being a YouTuber, I'm also an associate professor of bioinformatics, where I teach and do research at the interface of machine learning and computational drug discovery. In this course, we will be building 12 interactive data-driven web applications in Python using the Streamlit library. So Streamlit will allow you to make use of data and also all of the Python libraries such as NumPy, SciPy, Matplotlib, Seaborn, right inside the Python environment, and you'll also be able to create an interactive web application that will be able to pre-process data sets, visualize the data, and also make prediction from machine learning in the form of a web application. So a basic working knowledge of Python is assumed, but don't worry, I'll be in your hand and provide you with a step-by-step walkthrough where I will be simplifying the concept and topics covered. Before proceeding further, let's take a look at the 12 data web applications that we will be building today. I've also rearranged the topic according to the topics covered. And so in apps number 1 and 8, we will be building a very simple stock price application. App number 8, we will be building a simple bioinformatics DNA count application. Afterwards, we will be building 4 EDA applications using the basketball data, football data, S&P 500 stock price, and also the cryptocurrency price data. We'll also be developing 2 classification models and embedding that into the web application for the iris dataset and also the penguins dataset. We'll also be building 2 regression models on the Boston housing data and also the bioinformatics solubility data. And finally, we'll also be showing you how you could deploy your application to the Heroku platform and also to the Streamlit sharing platform. And so for more data science, machine learning, and bioinformatic projects, please make sure to subscribe to my YouTube channel, The Data Professor, and also follow me on Medium, where I regularly publish blog posts on data science and also machine learning. So links to all of these are provided in the description of this video. Also grab yourself a cup of coffee, and without further ado, let's get started. Have you ever wanted to build a data-driven web application for your data science projects? But perhaps you might be intimidated by the difficulty of coding in Django or in Flask. If you answered one or all of the above, then you want to watch this video to the end, because I'm going to show you how you could build a data-driven web application in just a few lines of code. And so without further ado, So the name of the Python library that allows you to build a simple data-driven web application is called Streamlit. Actually, this Python library was brought to my attention by one of the subscribers of this YouTube channel, Iqbal, for recommending this excellent Python library that will allow you to develop a simple data-driven web application for your data science project. And so the first thing that you want to do is head over to the Streamlit website by typing in streamlit.io. And so I'm going to provide you the link in the description of this video. So this is the website of Streamlit. And as you will see, it says that it is the fastest way to build a data application. And so here you can see that you could build a OpenCV within Streamlit, and you could add a lot of interactive elements as well. So in order to get started, you want to install Streamlit. And so you could do that by typing in pip install Streamlit. And after the installation process is finished, you could type in Streamlit hello in order to get installed. And as you can see here, a simple web application could be built in just a few lines of code. And you will see in this second example that you could also add widgets to the web application as well. And so this slider widget will allow you to select numbers just by sliding the slider bar. And in this third example here, you could deploy your web application easily using Git. And there you have it, a minimal framework for building a powerful web application while just requiring you just a few lines of code. And so here are some of the gallery of web application built using Streamlit. So let's have a look at the gallery. Okay, so this awesome web application using TensorFlow was built in Streamlit. And there are other awesome examples of Streamlit applications that were built by the user community. And so here are just a selection of these. So if you have built a web application using Streamlit, you could also share it via Twitter. And the Streamlit website will be showcasing your web application in this gallery page. So you can see here that a lot of applications have been built using Streamlit. Okay, so now that we have a brief introduction about Streamlit, let's have a look at how we can build one for ourselves. Okay, so the first thing that you want to do is fire up. So if you're using a Microsoft Windows, you want to type in the search bar, CMD, and then you will see a terminal prompt coming up. And in this terminal prompt, you want to type in pip install and then Streamlit. And then hit enter. And since I have already installed Streamlit, so I'm going to proceed with showing you how you can build the application. So I installed inside the Conda environment. And so I want to activate my environment by typing in Conda activate DP. All right, so I've created a Python file called my, and the contents of the file is shown here. So you could add it is approximately 20 lines of code. So if you deduct the empty spaces, then it should be less than 20 lines of code. And so aside from installing Streamlit, in this example, you also want to install yfinance. So you could type in pip install yfinance. Okay, and after you have done so, then you want to type the following lines of code in. But for your convenience, I'm going to share you the link to this file on the Data Professor GitHub. So you want to check in the description of this video and download this file. Okay, so the first 3 lines of code are just simply importing the yfinance as yf, import Streamlit as st, import pandas as pd, and then this block of code, the header of the web application. So as you will see here that this is in Markdown language, and with the hashtag here, it is indicating that this line is a heading type 1. So it's going to be a big text. And then it's going to be an ordinary text saying shown are the stock closing price and volume of Google. And then here, in this blocks of code, I've taken from the Towards Data Science article. So you want to check that article out and give this article a clap. And so I extracted some lines from this article. And so this line of code will be the ticker symbol of Google. And so it is GOOGL. And then in this line of code, we're going to take in the ticker symbol of Google. And so we're going to retrieve historical data of Google stock with a period set at 1 day, and the starting date is May 31st, 2010 with a ending date of May 31st, 2020. And then we're going to save this into the ticker data frame. And then the contents of this data frame will comprise of the following columns: open, high, low, close, volume, dividends, and stock splits. Okay, so in this web application, we're going to show you 2 line chart, and we're going to show the closing price and also demo the volume. Okay, and so this is a very simple web application, and then you could customize this to your own liking. So I'm going to show you that we could also edit the contents of the file and the web application updated version in real time. Alright, so let's type in cd desktop because this file is on the desktop, and then I'm going to type in streamlit run and then the name of the application, which is myapp.py, enter, and that's it. Okay, so it's going to spawn up a web server, and this is what you're going to see, a simple stock price application. Okay, so let me show you side by side the code and the application. All right, here. So here, the simple stock price app here is the heading. And since it is one hashtag, it means that in one style, H1 in HTML language. But if we have two, then it will be a bit smaller. So let's save it. And then it detects that the source file has changed. And then we should select always rerun. And then we should select always rerun. And so it's going to update to be a bit smaller, as you will see here. And if I add additional hashtag and save it, it will be even smaller. Okay, so I'm going to change it back to one hashtag, and so it is heading 1. Let me try. Okay, so let's maybe modify this a bit in markdown manner. So closing price, I'm going to make it bold, volume, I'm going to make it bold and in italic. See, so you could customize the style in markdown style. So you want to refer to the markdown cheat sheet, and I think this is a good one to refer to. So the markdown cheat sheet by Adam Pritchard, and it has everything that you would ever wanted to know about markdown. All right, so you could add cool stuff in here. You could add lists, unordered lists. You could add links. You could add images. You could add tables. Okay. Like for example, let me copy this. And then I'm gonna just put it here. All right, so it's a table. Okay, very neat, right? Okay, but let's delete it for simplicity. So the ticker symbol is Google. So we can even customize the ticker symbol to be other values as well. So let's say AAPL for Apple. Save it, and then this is the price for Apple. So I could update this like that. Okay, as you can see, it will update automatically to the website. Okay, so this is the date range that are shown in this line chart. And this is the actual line chart. So if I wanted to delete one of them and then save it, then only one will be shown. Okay. And let's say that I want to write something in. Okay, so I'm going to write here the heading 1 closing price. Maybe make it heading 2. All right, and I'm going to do the same for the volume. As you will see, this is the customized version. Okay, so if you zoom in, zoom out, you could even do that as well. This is a interactive chart. And if you want to zoom to the original version, you would just double click on it. Right, same thing here. Just double click on it, and it'll go to the original state. And so there you have it, a data-driven web application in just a few lines of code. Do you want to build a bioinformatics web application? If you answered yes, then you want to watch this video to the end, because in this video, I'm going to show you how you could build a very simple bioinformatics web application in Python. And without further ado, we're starting. So the bioinformatics web application that we are going to build today is called the DNA nucleotide count web application. Okay, so let's fire up the terminal. And let me activate my conda for Python. Conda activate. And the environment is called the DP. DP standing for Data Professor. And so let me go to the folder where I have my Streamlit web application files. cd desktop, cd streamlit, cd DNA. Okay, and so we have 3 files here. And so the aromatase.fasta is a example data file, but actually we're not using it to build the web application. So let's have only the Python DNA app.py and also the DNA logo.jpg. And the DNA logo will be displayed in the web application right here on line number 14. So let me fire up the web app. So I'm going to have to type in Streamlit and then run, and then the name of the app, which is dna-app.py. Okay, and so for those of you who don't have Streamlit installed, you could install it via pip. So you could simply do a pip install Streamlit. Okay, and so this image here is the logo, and the logo looks like this. Let me show it here. The logo is right here. So for this logo, I've drawn it using the in iPad. All right, so let's have a look at the web application. And let me show it side by side. Okay. Let me also increase the font size here. All right, there you go. So it's bigger for you guys. And right here too. Okay, there you go. So it's a lot bigger now. Okay, so let's take a look at the code here. So the first couple of lines here, we're going to be importing the necessary libraries for this web application. So on line number 5 here, we're going to make use of the data frame from the pandas library. And the basis of this web application will be using the Streamlit library. So we're going to import Streamlit as well. And for the graph here, we're going to make use of the Altair library. And then for displaying the logo, we're going to have to import from PIL, import image. Okay, so the block of code here from line number 10 to 24, we're essentially going to show the DNA logo. So we're going to create a variable called image, which contains the name of the logo. And then we're going to display the image here. And then we're going to display it by allowing the image to expand to the column width here. So it will expand to the column width. And then we're going to print out the header here, DNA nucleotide count web application right here, shown in bold. And then we're going to have a short explanation. This app counts the nucleotide composition of the query DNA. And then the 3 asterisks here will be showing the HR line. So the HR line is essentially the horizontal line here. Okay, and so the next block of code here will be showing the text box here. The DNA text box here, enter DNA sequence. So st.header will be showing the header here, enter DNA sequence, which is right here. And then the text box here will be displayed using the st.text area. Okay, and then we're going to have the height to be 250. So if you want it to be a bit smaller, then you could adjust the number here. And so you can see that when the height is 150, the height is smaller. And if it's 350, it'll be bigger. So let's have it at 250. Okay, and sequence input here, this is the sample DNA sequence shown here. So if I modify the name here, the name will be modified here. And the /n here is the new line. So if I don't have it here, then there won't be a new line. Okay. Like, for example, you could, import your DNA sequence and then command enter, and then you're going to get a different output. Okay. And so upon reading in the sequence here, st.text area, the input here in the text box will be provided or assigned to the sequence variable. And then for the sequence variable, we're going to split the lines. So each of the line here will be split. Okay. By splitting, it means that it will create a list of each of the line. So the first member of the list will be DNA query, and then the second line will be the second member of the list. Third line will be the third member, and the fourth line will be the fourth member of the list. And to provide this even clearer, let me show you. Not there, but here. All right, right here. So you're going to see here that when we use sequence and then we use dot split lines, we see that each of the line here, line number 1, line number 2, line number 3, line number 4, will be shown here as 4 members here of the list. 1, 2, 3, 4. Okay? And the lines will be indicated by the \n, which is the syntax for new line, which is also right here. So this is the equivalent of pressing the enter key on the keyboard, as so, like that, okay? That's a new line. All right, so let me take that out. And so we're gonna skip the first line here, sequence 1, which means that we're going to read lines number 2 onwards, because the first line will be the name of the sequence right here, which we don't want, because we want to compute the DNA composition using from lines number 1 onward, index number 1 onwards, which corresponds to the second member of the list, the index of 1 onwards. So that means index number 1, 2, and 3 until the n, right? Because the n is line number 3, index number 3. Okay, so line number 40 will essentially skip the sequence name because the index of the sequence name is 0. So it's going to skip this. And we're going to slice and select lines number 1, index number 1 onwards. So here, we're going to slice or select in the bracket here, index number 1 onwards, meaning that index number 1 here, onwards until the n. And it has a total of 3 additional lines, index 1, index 2, index 3. And then it will be assigned to the same name, sequence. Okay, so let's show it here again. As you can see, the name is now gone, and now we have only the sequence, and we have a total of 3 members in the list now. And before, there were a total of 4 members, including the sequence name as the first position, but because we have already selected the second member onwards, right here, second member onwards, second, third, fourth, it means that we're discarding the sequence name. And so here we have only the sequence. And so it's very helpful to have a look at the contents of the variable line by line so that you can see how the input data is being modified accordingly for each line of code here. Okay, and notice that we have a total of 3 members in the list. And so for the next line of code here, right here, we're going to join the 3 lines here together in order to form a long stretch of the... Let me show you what I mean. All right, here. So you can see that using the dot join sequence, and then because here we're saying that we don't want any space in between, so we're going to get 1 line of sequence here. Okay, so the 3 lines shown here will be combined into 1. And notice here that we have 2 quotation mark. If I add a space here, there will be a space added right here, space added here, space added here. Okay. Or we can even make it a new line, for example, to show you how the data is being modified. Okay, and it becomes a new line. Or if we say we want to add a dot, it will add a dot right here. See, it will add a dot here. And it will add a dot here. So we don't want to add anything here. We're going to just have the 2 quotation mark close together, and it will be 1 long stretch of line here. Okay, and now we have the DNA sequence that is pre-processed and ready for computation. So let me delete this again. All right, let's take a look further. So here, line number 46 is the comment for prints the input DNA sequence. So the DNA sequence that we see here will be printed here in the input header, DNA query. So this is have already pre-processed by joining all of the lines together. So the 3 lines will be joined. So as you can see, initially we read in the DNA sequence here, and then we deleted by discarding it, where we only take into consideration the nucleotide information here, and then we join it together into a single line, as shown here. And now, let's proceed to line number 50, DNA nucleotide count. Header is output DNA nucleotide count right here. So under this heading, we're going to different ways that you could display the output. So before displaying the output, we're going to do some computation. So in the first method here, print dictionary, all right? So we're going to use the subheader. So the subheader will be slightly smaller than the header. The font size will be slightly smaller. All right, and here, lines number 55 to 62, we're going to create a custom function for counting the DNA nucleotide from the sequence. So here, DEF, and then the name of the function, and then the input argument, SEQ, and then we're going to create a D variable, which is a dictionary, and then it's going to contain 4 members here. We're going to count the number of A in the DNA sequence. And for T, we're going to count the number of T using the .count function. Same thing for G, same thing for C. And then at the end, it will return the D variable. And so the D variable will be a dictionary containing the name of the nucleotide, A, T, G, or C, along with the of the nucleotide. So essentially, it will be a dictionary. Like for example, A, 59, T, 43, G, 52, C, 56. So 59, 43, 52, 56 means that there are a total of 59 adenine, here, 59 of A here, 43 of T, thymine, 52 of G, guanine, and 56 of C, the cytosine. Okay, so we're finished here now. We're up to here. Okay, and we're displaying the X, which is essentially applying the DNA custom function and the input sequence, and then we assign it to X here. And I believe that we didn't use the label or values here. Let's save it. All right. And so, okay, and so let's move on to the next block of code here. Number 2, print the text. Print the text, okay? So let's say that we want to print in human readable form because previously it looks like a dictionary, right? So not so friendly for the end user. So let's say that we want to print out the text here. We want to say there are 43 thymine, there are 52 adenine. Oh no, I mean guanine. It's a typo. Let me do it. So I guess I copy and paste it. So the abbreviation. All right, so the second part is finished now. Let's move on to the third part, display the data frame. All right, so here we're displaying it as a data frame. And so essentially there are 2 columns, the nucleotide and the count. And so this block of code here, we're going to create a data frame from the dictionary function. And then we're going to rename the column because at default, it will become 0. Here, let me show you. It will become 0. So we're going to relabel 0 to become count. Okay. Okay, and so as you can see, this block of code here will give you this data frame. And this data frame will be used for creating the following bar charts. In number 4, display the bar chart. And so for the 4th one here, we're going to be making the bar chart. And we're going to make use of the Altair library. So line number 87 will print the subheader. Lines number 88 to 91.